Hello everyone and welcome to Intellipaat. In this video, we will be taking a look at AWS, or also known as Amazon Web Services. Most of the world is moving towards cloud computing, especially after the pandemic. Every startup and most of the big corporations are transitioning to the cloud. The top three players in the market are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS started in the year 1995 when the e-commerce giant that we know today was building infrastructure for its website. Gartner has claimed that the AWS is the most dominant player in the cloud computing world and will continue to do so. Let us see what AWS is and what are all the services that it has in this video. But before that, please make sure that you subscribe to our YouTube channel and hit the bell icon for regular updates. Now, let us take a look at the agenda for this video. Firstly, there will be an introduction to cloud computing, followed by virtualization and cloud computing, followed by models and deployments, followed by cloud service providers, and then we'll move on to what is AWS exactly, followed by identity and access management, followed by AWS buckets, then we'll take a look at IAM dashboard and features, followed by introduction to EC2, or also known as Elastic Compute Cloud, followed by Elastic IP addresses. And finally, we'll be taking a look at a hands-on for the above mentioned services.
Fine, let's get started with the introduction to cloud computing. Let's understand the basics. What is cloud computing? What exactly it's all about? In simplest terms, cloud computing is when you use a computer, a server which is given to you by someone else. This server has to be accessed over the internet by a web-based tool or for personal business use cases. See, basically a cloud computing is nothing but it's a platform, and it's being used to ensure that it's being used to ensure that you can access the documents over the internet. Documents, storage, server, virtual compute units, whatever resources you're going to be using or going to be deploying, you deploy those resources or you consume those resources over the internet. Whether it's a compute infrastructure, it's a virtual resources that you want to deploy, basically the database, network, storage, these things you consume over the internet virtually, right? So cloud computing means that a computer or a server is running in some other data center. That hardware or the infrastructure you don't own. And what exactly you do is that infrastructure is being given to you in such a way that you can access those resources or that infrastructure while making sure that you can use internet or maybe you can use VPN. So you use that or you consume those resources virtually. You use or consume those resources virtually over the internet. For example, let's imagine that I want to ensure that, for example, I'm using OneDrive as to store my documents, right? So I'm storing my documents on OneDrive or Google Drive. Now, the Google Drive or the OneDrive documents that I'm storing, those are not stored on my own local computer. Instead, those documents are stored on the data centers owned by Google or Microsoft. Fine. So cloud computing is not just a term that's been used in a business use case or business environment. Even nowadays, the apps, the storage, for example, we watch YouTube videos, Netflix. Are those media files or videos stored on our own local storage? Are we using a pen drive? No. The Netflix, the YouTube that we're using, the media is stored somewhere else. The videos are stored somewhere else. We just use internet to stream those media files. Okay. So we use Netflix or YouTube. Videos are stored somewhere else in their own data centers, but we stream that media and we consume those things over the internet. So whether it's a media, whether it is storage, it's a very common thing nowadays that we use cloud computing in day-to-day life. What about businesses? See, businesses use this infrastructure to ensure that the database, network, and storage infrastructure is deployed. The storage, networking, and database infrastructure is deployed in some other data center, and the businesses can use that infrastructure without any upfront investment. So that's about the stuff. So cloud computing in the simplest means that the computer, the server, the storage, the database infrastructure is given to you over the internet and you consume it virtually. Fine. Now, why the businesses need this type of cloud computing environment or this infrastructure? See, if you see a data center infrastructure, it consists of a lot of investment in terms of, for example, today your company wants to set up a data center. Why company needs a data center? Because the IT applications, the software applications, the web applications, databases, they need to be served by servers. These servers are kept in racks, big racks, in big facilities that are called data centers. Now, data centers need a lot of investment. You have to lease a lot of land. You have to take care of the electricity, power, cooling, backups, everything. Also, you have to hire some experts, some data center experts to maintain those data centers. So data centers deployment needs a lot of investment in a long run. So millions of dollars are needed. If you want to set up even a medium-sized data center, it means that it needs investment of hundreds of thousands or maybe millions of US dollars. So a lot of investment, planning, time, effort goes into building these data centers. Now, what AWS says, or what, for example, Amazon Web Services, Google Cloud Platform, Microsoft Azure, these are big giants. They already have their data centers deployed in different parts of the globe. What these companies, these giants says, that you use our data centers. You use our data centers and you pay the bills based on your consumption. So in this case, we use the concept called virtualization. Virtualization means that it's a virtual version of something, maybe an OS, operating system, server, storage, device, networking, and so on. Basically, the thing is that virtualization is a backbone of the cloud computing. Anything that you deploy in a cloud infrastructure, you access that virtually. Why virtually? Because you can't see exactly the physical server at the back end or the computer running at the back in the background. For example, if I'm using Microsoft OneDrive, these documents that are stored on the cloud must be stored somewhere on a physical server owned by Microsoft. I can't see that physical server. I can only see the documents. This means that it's virtual. It's not physical. The web applications that you're leveraging, the databases that you're using, the storage that that you're leveraging, that infrastructure you can't see physically. It's completely virtual. It is completely virtual. So this means that you access those resources virtually. Now, in terms of a compute infrastructure, virtualization means that on the same physical server, you run different virtual machines. You run different virtual machines. So what this concept says is, let me just show you that. This concept of virtualization is very basic. What you do in terms of the virtualization is that, okay, let's imagine. So before virtualization, what was this entire setup? See, before virtualization, the setup was very simple. So let's imagine before or prior to virtualization, what was supposed to be done was that you have a physical server. This is a physical box. It is a server. It can be, let's imagine, an HP, an IBM, or a Dell physical server. Right? It's a physical machine that you own. Now, before virtualization, what you're supposed to do was that on this physical server, only one operating system was supposed to be deployed. For example, I want to launch upon it Windows Server 2008. Kind of discontinued now. So only one operating system can be deployed on the same physical server. Fine. Now, in this case, this means that the same physical server can be used for only one use case. Only one operating system can be launched upon it. Now, things changed after virtualization. What they did is, so this virtualization is a pretty much old concept, but it gained popularity in year 2010, almost a decade back. So what they say is, what virtualization means that you have the same physical server, you create a layer upon it. It's called hypervisor. What is that? It's called hypervisor. Now, hypervisor is a layer. It's a software that you install upon the physical server. Okay, it's called hypervisor. This hypervisor helps you to deploy multiple virtual machines on the same physical server. What are these? These are called virtual machines. What are these? These are called virtual machines. Now, these virtual machines can have different operating systems running upon them. For example, upon this, I'm running Ubuntu 20.04. On these two, I'm running, for example, Red Hat Linux. On this one, I'm running Windows Server 2022. Okay, so can you see the difference between these two different scenarios? Before virtualization, only one operating system could have been deployed on the physical server. Only one operating system. But after the virtualization, on the same physical server, you install a hypervisor. It's a client software, and you start installing the virtual machines on the hypervisor. Each virtual machine can run a different set of operating system. Okay. Now, what are the benefits that you reap out of it? What are the benefits? Yeah, it's installed on a bare metal. That's right. It's installed on a bare metal or on a physical server. Now, the examples are there are a lot of examples that you will see in the industry. For example, the very first hypervisor that gained popularity was or is VMware ESXi. ESXi. Zen is a hypervisor which is used by AWS. There are a lot of hypervisors, but these VMware ESXi is the most popular, all of them. So these are the hypervisors given to you by different vendors. You install those hypervisors and you run different virtual machines on the same physical server. Even that's not the case. You might have heard about VMware Fusion parallel desktop. For example, I use VMware Fusion. It's not exactly the hypervisor, but I am running Ubuntu and Windows. I'm using Macintosh as an operating system, but on the same physical server, I'm running Windows 10 and Ubuntu 64, Ubuntu 20.04. Okay, so this VMware Fusion helps me to install Windows and Ubuntu on a Mac computer, right? So virtualization means that on the same physical server, you can deploy different virtual machines, and those virtual machines can have different operating systems. Now, what are the benefits that came with it? Can anyone tell me the benefits? If you have any experience working on the virtual machines, what are the benefits out of it? What benefits you think you might get out of it? Yeah, so it's a lot cheaper because you can optimize resources. See, instead of getting only one, so it's cheaper, it takes less space in a data center. Less space means that it's more environment friendly. It's more environment friendly because now the same physical server can take the same space, but on the same physical server you can run different operating systems. So you will the data centers will have less carbon footprint. They will have less carbon footprint, cheaper, affordable. Yeah, so it's cheaper, takes less space, environment friendly, takes less carbon footprint, right? Because data centers are humongous. They emit a lot of pollution. So instead of having, for example, if 10 servers, I just need 3 servers, the same space, so I can optimize my I can make the best use of the storage space available to me. For example, in this room, I want to have a rack of servers. Before virtualization, if I needed 100 servers, after virtualization, I just need 10 servers. That's it. Okay. So yes, these are the two main benefits. You can have multiple benefits, but it's more cheaper, takes less space, it's more environment friendly, takes less space, it will have less carbon footprint. Okay. Now these cloud providers, Amazon, Microsoft, Google Cloud Platform, DigitalOcean, IBM, what these companies do is that they said, okay, we save the money and we pass on the benefits to you. So they make the things cheaper for you because they have to invest less compared to before using the virtualization. For example, this physical server, let's suppose it has 1 terabyte of SSD storage, and let's suppose 8 terabyte. It has 8 terabyte of SSD storage and 244 gigs of RAM. Okay. Now this complete this thing needs to be shared among these physical servers. So the number of virtual machines depend upon that. What's the amount of storage and the RAM that compute? What are the compute capabilities, the physical specifications of that physical server, and that needs to be shared among these virtual machines. For example, I'm saying this virtual machine will consume maybe 32 gig of RAM plus maybe 1 terabyte of SSD storage. Now you can just minus 244 and minus 32 out of 244, or you are left with 7 terabyte of storage. So basically, the thing is that the amount of physical storage and the RAM that physical server has, you need to divide it based on your requirement among those virtual machines. So those many virtual machines you can deploy. And so until you exhaust these physical specifications, based on that, you can deploy the number of virtual machines. You have to divide it based on your requirement. Fine. So the number of virtual machines depend upon that what's the physical specification of that physical server and how you have distributed that compute infrastructure among the virtual machines deployed on the physical server. Fine. So there's no limit. So basically, based on the physical specification of the physical server, the number of virtual machines and the type of them can be deployed. Fine. So that's about the stuff before virtualization and the after virtualization, and these are the benefits that you reap out of this thing. So basically, you're able to best optimize your physical infrastructure. You get the most of the benefits out of this entire setup. Fine. All right. So that's about the virtualization. Now, it's not only the virtualization that has empowered the cloud computing, it's the internet. Fine. Now, a decade ago, the internet was not that much fast. Okay. But now we are getting very high speed internet connectivity. I want to access the data, my data stored in a data center, which is maybe in a different country. I'm in India. Maybe the data center resources that I want to access is in Netherlands, maybe in Switzerland, maybe in let's suppose in US. I can easily do it. I can easily access the storage data very fast because the internet is very fast nowadays. Any data that's stored, anything that I want to leverage in any data center which is far away from me, I can easily access it because of the fast internet. So virtualization and the fast internet connectivity nowadays, it has made the cloud computing accessible and very popular. YouTube, Netflix are what are these? These are the cloud computing services only. Now, back on the days we used to have CDs, DVDs. Used to store the media over there, cassettes, VHS. Now we don't have to store those locally. These media files are streamed from a data center which is far away from you. It is far away from you, right? And you stream that media. The media files are stored somewhere else, but you stream that media because of the fast internet. So virtualization and internet, these are the two things that have made cloud computing very popular and very accessible, even for a common person. It's not just a business, but even for the common person. Now, what are the advantages? See, the very first advantage of the cloud computing is first thing first, you don't have to do any investment. As a business, there's no investment needed. For example, let's imagine you get the idea to initiate a startup company. Okay, for example, you want to become a pharmaceutical organization. Now, as a pharmaceutical company, what your main business is? What your main business is to do research, to manufacture medicines, distribute them, right? So pharmaceuticals is your main business. Now, nowadays, every company needs an IT infrastructure to run their in-house business applications, or maybe to host their websites and promote their, because nowadays you can order the medicines from the app. So even the public infrastructure needs a backend IT or software architecture. So anything your pharmaceutical company has made business into pharma, into clinical trials, or maybe manufacturing of the medicines, distributing, and so on. Now the thing is that let's suppose you have procured $5 million from your investor. Now that $5 million out of which two or three or maybe $1 million has to go through the data center deployment, or maybe you have to lease out some rack space, hire the IT professionals to procure a lot of rack space in different data centers, maybe invest in setting up a huge data center in advance. Now the thing is that for a startup company, it's a big challenge. So that startup company has to, there's a lot of budget issues. Instead of investing in the manufacturing of the medicines or doing R&D, a lot of money goes to setting up the IT infrastructure. Now this is very challenging. This used to be very challenging. Nowadays, you can see that a lot of startup companies are booming nowadays. Every day, hundreds of startup companies are coming up. Why? Because all of them are using cloud computing now. Ola started using AWS. Zomato is on AWS. There are multiple, I would say that Zomato, Swiggy, I would say almost all the cloud computing platforms, all the startup companies that started even 5 years back, they understood the benefits that they will leverage through by using cloud computing, because they don't have to set up these huge data centers now. They don't have to do a lot of investment. Instead, they divert that money to their own core business. And AWS says, okay, you can log in, you can just sign up. This is called AWS Management Console. Without any capital investment, you start using our data center resources, and you just pay for the consumption. Fine. This became easier for the startup companies to start their business and grow. Fine. So that's the thing. Now, for example, you want to watch the YouTube videos. I'm giving you a very simple example. Do you want to buy a cassette or a CD for that? No. You have the internet connectivity. You open YouTube and stream the video. So the data, the accessibility has become a lot cheaper compared to before. No capital expenses. It gives you a lot of flexibility. Fine. You get a lot of flexibility in terms of deploying resources in different parts of globe. Security is also one of the benefits. See, basically, one thing is that you also get the security on premises, but now cloud vendors give you a lot of security tools to secure your data. Okay. Now, getting a new server is just a matter of few seconds. If you want to deploy a server, it's a matter of few seconds only. Let me show you one thing. For example, now I guess all of you have access to the AWS Maven console. You don't have to log into it. But I want to show you one thing. If I want to deploy one single server without any planning, without any capital expenses or expenditure, I can easily deploy a server in few simple clicks. Let me show you. Okay, hang on one second. Now this is called AWS Management Console. You have to use a credit card or debit card to sign up, but without any true investment or any huge investment or any investment at all, I can just quickly deploy a virtual server on the fly and install and launch a web application upon it, right? So I just quickly go to launch instance. I'm just showing you as a simple stuff. In just a few seconds, I'll get a complete virtual machine, a complete server without any proper planning, without any capital investment, which is kind of impossible if you don't use cloud computing. If you don't use cloud computing, you have to get a rack space in a data center, maybe get your own data center, which includes months and months of planning, years of investment, and maintenance. So I'm saying, okay, I just could get a virtual server. I can easily deploy a web app upon it and give the website URL to my customers. They can access my products and services. Getting a new server is extremely easy now. Extremely easy, no investment or very, very less investment. This is one of the biggest benefits that you get with cloud computing. You get so many resources, up to thousands of servers in just few seconds without any investment, without any prior planning or any setup. Fine. Plus, you get a lot of flexibility. For example, AWS helps you to scatter your resources in different parts of the globe. I can deploy my resources in different parts of Asia, in Canada, in Europe, in US, in Africa. I can use any one of the data centers in any parts of the globe. This is a flexibility that your cloud vendor gives to you. I don't have to set up a data center in Hong Kong, in Mumbai. I don't have to set up a data center in Singapore, in Tokyo, in Frankfurt. I don't have to set up my data centers over there. The things are there in front of me. I just need to use it. It's a cooked meal served on the plate. Simple. You don't have to prepare anything. No months and months of planning, no investment, no expenditure. You simply get access to thousands of resources at your fingertips. So you get a lot of flexibility in terms of resources management. Now, there was a question, what's a downside? Downside is that you can't customize it based on your business requirement. See, AWS is now it's serving more than 2 million customers. Okay, so customization benefits you don't get on cloud computing, right? They can't customize based on every customer's requirement, because if if 2 to 3 million customers are using AWS, it's very hard to them to customize their platform based on every customer's requirement. Impossible. So the customization you don't get on cloud computing. You have to stick to what your cloud vendor gives to you. Okay. And you have to be happy with that. But yes, the benefits that you get are humongous. Fine. So that's about the stuff. I guess this is clear. See, customization means that, for example, let's imagine I want to change this dashboard based on my requirement. I want to make sure that, okay, if I go to the instance, these options should not be there. Or maybe, for example, when I deploy the instance, okay, so let's take one example. I want to make sure that when I deploy the instance, okay, let's suppose I go to instance types. Instance types are nothing but it's a type of virtual machines that you get based on the CPU and RAM requirements. I'm giving one simple example. It's loading right now. It's a whole list. Okay. Now, instance types give you a certain amount of CPU and RAM for every virtual machine. Now, this is not customizable. For example, T2.micro. Now, I'm just giving one example. I'm not going into details. It's the type of virtual machine you can deploy, which gives you 1 gig of RAM only. Okay. The next one, T2.small, gives you 2 gig of RAM. Now, I can't change the RAMs. Is this set for me? T2.xlarge gives me 16 gigs of RAM, right? Now, you can't see anything which gives you 24 gigs of RAM. Okay. So basically, you can't customize these things which are already predetermined. I can't say, okay, T2.xlarge should not have 16 gig, it should have 24 gig. I want to add 8 more gig of RAM. That thing is not available to me, right? So customization means that based on your special business needs, AWS cannot change their set format. If T2.xlarge virtual machine gives me 16 gig of RAM, it will give me 16 gig. I can't upgrade to 24 gig. Fine. That's what the customization I was talking about. It's not limited. It means that it's unlimited, but it is not tailored based on every customer's requirement, right? You understand the point? So, for example, you go to a retail store, right? And you see thousands of products lying there, but might be the product that you're looking for, you need your own customization to that. Okay, so that customization is not available. That's the main thing. I'm just telling you one single disadvantage because there was a question. I don't think there's a disadvantage, but there's a limitation. Fine. Now, for example, some country says X country data cannot be shared or saved outside the country. Is this possible? If yes, then how? Talking about the security and compliance requirements, the data residency requirements. The data from one country to another country can be shared among data players, but you have to see your data residency requirements. Does your company have a strict data residency requirements or not? If that's the case, so based on the region of AWS, you have to make sure that you only use that region. For example, I have a bank in Europe. I want to go to AWS. Because of the European Union GDPR data residency requirements, I need to stick to, I need to make sure that my customers' data is kept in Europe only. Okay. So in this case, I have to see my data residency requirements, and I can use I can keep my customers' database in any regions in Europe, right? AWS gives me the benefit to easily migrate or copy the data center in Asia Pacific. You have that flexibility, but you have to stick to the data residency requirements being set by your organization. So I think you got the benefits of the cloud computing. What are the benefits out of it? And what are the two things that empower cloud computing? Virtualization and the internet. Fine. If the algorithm was there that the things would be done automatically, then I would have lost my job a few years back. You, as a cloud engineer, the planning, the resource allocation, you have to do it by yourself, right? So there's no algorithm. Every resource that needs to be deployed based on the requirement, you have to choose at which instance type suits you. What's the amount of resources you want to allocate? So that's not decided by an algorithm. That's decided by an engineer. Fine. So, guys, that's about the basics that I've discussed so far. Now let's discuss the cloud computing deployment models. You don't have to go into the details, but let's understand that the three main models we use: IaaS, infrastructure as a service; PaaS, platform as a service; SaaS, software as a service. What are the differences? See, infrastructure as a service, IaaS, means that the infrastructure components like networking, virtual machines, databases, storage have been given to you. Infrastructure components. What you need to build an infrastructure: storage, compute, servers, then databases. These are some basic building blocks of infrastructure. So if you leverage them as service, it's called infrastructure as a service. For example, on AWS, if I go to AWS, even the EC2 this instances that we launch, the servers that we launch, they come under infrastructure as a service. There's a service called S3 that's for storing my data. Any storage service that your cloud vendor gives to you, it comes under infrastructure as a service. So storage, compute, database, anything that builds up in your infrastructure comes under infrastructure as a service. Fine. The next thing is called platform as a service, PaaS. Now it's mainly inclined towards developers, software developers, which helps in the ease of software development deployment. For example, Elastic Beanstalk. It is a service, this one, which helps a developer to easily run and manage web applications. right? So it comes under platform as a service. It gives a platform. For example, you can use Node.js, Python, Docker, Go, Glassfish. Those platforms consist of scripts, software, resources, programming, language runtime, everything that will ease.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
That will help you in the ease of deployment of your applications. So platform as a service gives you access to some services, like for example, Elastic Beanstalk, which helps a developer to easily deploy the applications. Fine, Elastic Beanstalk is one of the examples. On AWS, we have Lambda. Lambda generally it comes under infrastructure as a code, but Lambda can also be considered as a PaaS, platform as a service. It gives a platform to easily deploy the servers on the fly without getting into the infrastructure complexities. So it eases the deployment for you. Then we have software as a service. The last category, SaaS. What do you mean by that? Nowadays, the things we use, Google Drive, Google Docs, they come under software as a service. Even YouTube that you use, Netflix that you use, the apps that we use nowadays, they comes under software as a service. This means that the things are already pre-configured for you. You just need to sign in and start using it. Fine. For example, yeah, Gmail is a software as a service. We use Gmail. Do you have to configure any mail servers in advance? No. Mail servers you don't have to deploy in advance. You simply sign up for Gmail and start sending and receiving the emails. Gmail, Google Docs, these are the Dropbox. They come under software as a service, which means that you don't have to configure anything. The software is there for you. You sign up and start leveraging it. But the backend operations are handled on cloud. VPC, Ankit, comes under infrastructure as a service because VPC consists of the networking. It is a networking component. Fine, it's a networking component. You don't have to go into the details. Very simple, basic understanding. Right? Infrastructure as a service, which helps you to leverage infrastructure components like storage, database, networking, and compute. Platform as a service, it is used to enhance the developer productivity, gives some tools to developers to quickly deploy the applications like Elastic Beanstalk. Software as a service like Google Drive, Gmail, Microsoft OneDrive, Dropbox, it's simply used as an end product that you can sign up for and start using on the fly. Yeah, see, we are not talking about the virtual machines. Yeah, even though they're deployed on the virtual machines, but right now we're talking about the services that we're consuming, in what form we are consuming, in what form we are leveraging those services. Of course, they will be deployed on a physical machine or the virtual machine at the back end, but we are talking about the services that we get through them. Fine. So that's about the stuff. Okay. Now let's discuss the different cloud service providers. See, there are multiple cloud service providers nowadays that exist, but three are the major one. What are they? What are three main cloud service providers that exist in today's world? The three main cloud service giants are Amazon Web Services, the AWS that we are studying right now, Microsoft Azure, and the Google Cloud Platform. Right? So these are the three biggest giants in the cloud computing domain, with AWS on the top, Amazon Web Services on the top. Microsoft, some people are saying that it may come on the top, but right now AWS is on the top. AWS or Amazon Web Services is the biggest cloud service provider. Okay, and basically it is generally being adopted by a lot of popular companies like Reddit, Netflix, even US government uses AWS, and they have spread across multiple data centers across the globe. AWS is the biggest cloud service provider, followed by Microsoft Azure, which is second in this entire list, and Google Cloud Platform is in the third. Now, Google Cloud Platform, it offers most of the services like as software as a service. Google Suite, G Suite, Google Forms, Google Docs, Google Sheet. So the GCP, the Google Cloud Platform, they're mainly inclined towards the software as a service. AWS, mainly it's inclined towards the infrastructure as a service. Okay, so these are the three main giants in the industry. Then MS SQL and Oracle. See, basically these are the database services or the providers that we use. Fine. So if you leverage them on AWS, that they come under platform as a service. Fine. What is AWS? AWS provides the on-demand cloud computing services to businesses and individuals. It is the biggest cloud provider. It's owned by Amazon.com, which is owned by Jeff Bezos, which is one of the richest person now. I think on the second one after Elon Musk. I think now he's the richest one, Jeff Bezos, specializing in infrastructure as a service. Now AWS owns it generates more revenue than Amazon.com. Now it's a platform that helps businesses scale and grow by offering different cloud services on the fly, like compute power, content delivery, database storage, and other functionalities. So basically, it is one of the most popular and the biggest cloud service provider on this planet, which helps businesses scale and grow. And you can do that by leveraging different services like database storage, content delivery, compute power, and other functionalities. Fine. So that's about the stuff. Now, AWS, if you see this thing right now, AWS, this is called the AWS Maven console. This is the homepage of it. Okay, this is the homepage of the AWS. Now, AWS gives you a different set of services. If you go to the services right now, you don't have to just see what I'm showing you. It gives you different categories of services like database, developer tools, end user computing, front end web and mobile, game development, Internet of Things, machine learning. So they give you different set of services. For example, under compute, it gives me App Runner, Batch, EC2, Image Builder, Elastic Beanstalk, Lambda, Lightsail, Outpost, Serverless Application Repository. So based on different categories of services, they will give you different set of services under that category. For example, under database, we have DocumentDB, DynamoDB, Elasticache, RDS, key spaces, MemoryDB for RDS, Neptune, TimeStream. Okay, so they give you access to different set of services based on those categories. Now, as of now, AWS has more than 100 services on their board. So you don't have to use all the services, right? To architect your applications, I think 15 to 20 services are more than sufficient, right? So more than 100 services that AWS offers to you, and yes, so that's about the set of services that they offer to you. Now, every service is unique based on what is your business requirement, the pricing of it, and the configuration. We are here to understand some tools and services, some services out of this list, to understand that how to configure those services and how to put them into use to create a software architecture. Okay, so these are the suite of services that you have. Now, the next question that is that if you go to the home page, on the right hand side, you can see that this is a complete list of different geographical locations. So I'll discuss something with you. Two main global infrastructure components. One is the regions, and the other one is the availability zones. What are these? See, basically what you have to understand is that AWS has its data centers scattered across the globe, right? It's not just in India or in Frankfurt or in Paris that they have. They are present. They have their data centers present across the globe. So let me show you the exact website that there is. It's called AWS Global Infrastructure. Let me show you that. Now, what you have to do is, if you just scroll down, you're going to be seeing that this is the exact map of the global infrastructure. This is where shows the presence of AWS across the globe. The blue dots that you can see, this is where they have the data centers running, and the orange dots are the locations where they will be running their data centers very soon. For example, in Spain, they're running. Okay, so as of now, they are spread across 26 geographic regions. Okay, what are these geographic regions? These are nothing but these are the actual physical locations on globe, on planet Earth. So basically, it is the exact location from where they are running their data centers from. So what is a region over here? Let's try to understand. A region is nothing but, okay, so we are discussing over here, it's called, so right now we are discussing the global infrastructure. Let's try to understand that, because to architect your applications, to deploy your complete architecture, you have to understand that how they operate their infrastructure. So the very first thing is we're going to discuss the region. Let's understand. The very first component of the infrastructure is called region. What is region? It's a nothing but it's a geographical location. It's a geographical location. It's a piece of land on the globe from where the AWS operate. They have data centers located. It's a geographical location or it's a physical location, right? Where their data centers are running. Okay. It's a geographical location which consists of AWS owned data centers. It's a piece of land on the globe. It's a geographical location which consists of AWS owned data centers. Fine. As of now, if you see the documentation, they propose or they push forward this thing that we are scattered in 26 geographic regions. You can access, I think, 23 or 24 of them. Chinese and China regions and the US US government regions are restricted for you. So these are the regions you can access. These are the actual physical locations. For example, 2 on the east coast of US, North Virginia, Ohio, 2 on the west coast, California, Oregon, in Africa, Cape Town. We have 7 to 8 in Asia Pacific, including Mumbai, Hong Kong, Jakarta, Seoul, Singapore, Sydney, Tokyo, 1 in Canada, 6 in Europe, including Frankfurt, Ireland, London, Milan, Paris, Stockholm, 1 in Middle East, and 1 in South America. So can you see that they have dispersed their data centers in different geographical locations? Okay. Now, I'll let you know that how you decide that which location is the best fit for you. But right now, let's understand that each location it's called region, REGION. North Virginia is my first region. Ohio is another region. California is another region. Oregon is a different region. So each name that you can see in a list, it is a separate physical location. It's called region. Fine. Now, we understand it's a physical location. But what about those data centers? Those data centers that operate inside these regions are called availability zones. In the short form, it's labeled as AZs. Right? What are these AZs? What exactly these are? These are nothing but these are the facilities. These are so it can be, so availability zones are the facilities or the data centers which consist of the servers, which consist of the physical infrastructure or physical server, physical infrastructure, the physical servers. Fine. So availability zones are nothing but these are the facilities, these are the data centers which consist of your physical infrastructure, which contain your physical servers. A region is a geographical location which consists of the data centers. Those data centers are called the availability zones. Okay, that's about the region. It's a piece of land on the globe which consists of the data centers labeled as availability zones. Okay, now how you can access them? Let's imagine. So every region has a special name assigned to it. For example, if you see on the right hand side, North Virginia is US East 1. Ohio is US East 2. You don't have to remember them, just for the sake of understanding. Africa, Cape Town is AF South 1. Mumbai is AP South 1. Singapore is AP Southeast 1. Canada is CA Central 1. Frankfurt is EU Central 1. So they allocate a special name for each region. You don't have to memorize them, just for the sake of understanding. So they give a special name to every region. For example, Paris is EU West 3. Fine. Stockholm is EU North 1. So every region has a special name assigned to it. Let's pick Mumbai. Let's pick Mumbai right now. Now, what's the special name assigned to Mumbai? Okay, one thing you have to understand, each region is a separate physical infrastructure. Okay, every region is separate. You have to treat every region as a separate physical infrastructure or a network infrastructure. Mumbai If I switch to Mumbai, this will show me the Mumbai's services. Now, how can I see the data centers in Mumbai or the availability zones? For example, I go to EC2. EC2 stands for Elastic Compute Cloud. It helps me to deploy the virtual servers in the cloud. Now, if I go to EC2 dashboard, can you see that these are the 3 data centers I can view in Mumbai? First thing first, what's the label assigned to Mumbai? What's the name assigned to it? The name that is assigned to it is AP South 1. Okay, let's do this thing. Let's try to understand it based on the diagram. Let's imagine this circle that you can see, it represents Mumbai and it's labeled as AP South 1. Fine. What's that? This is Mumbai. It's labeled as AP South 1. This is the region. What's that? This is my region, a separate region that's called Mumbai. Fine. Now, this region that's called Mumbai consists of 3 availability zones. If I shoot back to the this Mumbai page, Mumbai is which region? AP South 1. Can you see that on the right hand side? And these are the 3 different availability zones: AP South 1A, AP South 1B, AP South 1C. These are the 3 separate availability zones. What are these? These are 3 separate availability zones. So if I go back, so these 3 blocks, you can assume this is AP South 1A, 1B, and 1C. Fine. What are these? These are 3 different availability zones linked with each other. So what are these? These 3 are separate availability zones or /AZs. Fine. So these are 3 different availability zones located in the region Mumbai. That's AP South 1. So AP South 1A, let me go back. AP South 1A, AP South 1B, AP South 1C are the 3 different availability zones located in AP South 1, which is Mumbai. Fine. Let's switch to another region that's called Europe, Frankfurt. So in Frankfurt, how the Frankfurt region is labeled as EU Central 1. Let me show you that. EU Central 1. EU Central 1 is which region? Frankfurt. What are 3 availability zones in Frankfurt? EU Central 1A, EU Central 1B, and EU Central 1C. 3 distinct data centers / availability zones / facilities. 3 different availability zones or data centers located in the confinement of Frankfurt. Okay, let's take last example. Let's pick North Virginia. Now this is the prime region because when AWS started out in 2006 officially, this was the first region. Now North Virginia on the east coast of US is labeled as US East 1. Because on the east coast it says US East 1. That was the first region on the east coast of US East 1. Ohio is US East 2. US East 1 is the region that represents North Virginia. Now, this northern of Virginia consists of 6 the data centers: US East 1A, US East 1B, C, D, E, F. These are 6 different AZs / facilities which consist of the physical servers housed within them. Fine. That's about the regions and availability zones. Is this concept clear? I'll further go deeper, but right now I'm just going to want to ensure that you understand this concept first. What is a region and what is the availability zone? Very basic, but yes, of course, we have to get started with basics now on AWS. So a region is a physical location. It's a geographical location which comprises of different data centers clustered together in a form of availability zone. Each availability zone is a facility, a data center, which comprises of your physical servers running in them. Fine. Can we say that AZs are as different data centers in a specific region? Yes. See, basically an AZ can be a collection of 2 or 3 data centers, but generally we say one AZ is equal to one DC. Sometimes it is 2 or 3 data centers collected together, but generally we say one AZ is equal to one data center. or a facility. One AC is equal to one DC. So logically, we assume that one AC is a one data center. So if I have three ACs, I have three data centers located in Mumbai. So one AC is equal to one DC. Sometimes there are two DCs connected with each other sometimes, but generally we say one AC is equal to one DC. Now these ACs are connected together with high-speed fiber optics. They're connected together with high-speed fiber optic cables, right? So there's a lot of data redundancy. Your applications can be backed up. They can be scattered across different data centers in a region. So they're connected together with high-speed fiber optic cables or optic fiber cables, whatever you want to say. So Israel availability zones are nothing but it's a grouping of data centers. One is equal to one data center. When you collect those together, they form a region. So a region is nothing but it's a collection of multiple data centers in the form of availability zones, right? So if one data center goes down, see, basically they promote something called high availability. What do you mean by high availability? Which means that your data and your applications are always available. They promote something called high availability. What do you mean by that? For example, if let's imagine if this goes down, if this data center goes down, you can use a second one. If this goes down, you can use a third one. If this also goes down, if the entire region goes down, you can use a second region as well. Okay, those strategies, how to use a different data center, a different region, in a in a in just matter of few seconds, we're going to discuss that afterwards. Fine. So AWS says that you can make your applications, your data more redundant, more resilient. Yeah, redundancy, you can say that. High availability, redundancy, that you can create multiple copies of the data. High availability, redundancy, and fault tolerance. If any fault happens, there's a tolerance to that. Fine. So basically, why they give you a complete infrastructure, you can easily make your data more redundant. You can create multiple copies of the data. You can scatter your application in such a way that if any infrastructure goes down, whether it's the availability zone or the complete region, you still have the continuity of your applications. Fine. That's about the stuff. I think this is clear. The concept of availability zones and the regions. Now, how to achieve these three things: high availability, redundancy, and fault tolerance? We're going to be using some services for that. Those services we're going to discuss, like for example, auto scaling, load balancing, snapshots, cross-region application. To achieve that, we use different services. Let me just list those services, not all of them, but some services. So we use some services and strategies to achieve these. High availability, data redundancy services are the following. Um, for example, uh, load balancing, auto scaling, okay, uh, snapshots, life cycle policies. I'm giving you a few examples over here. Uh, cross-region application. We're going to discuss all these services later on. This global accelerator, S3 storage classes. So we'll discuss all these services one by one as the time comes. Okay, so these are some of the, not all of them I've put forward. For example, there's one more service called multi-AZ, read replicas. We're going to discuss all these different strategies. Multi-AZ, read replicas. So we'll discuss all of them, right? So as the time comes, we'll discuss all the services that how to achieve high availability, redundancy, fault tolerance, and backup of your data. So we'll discuss we'll discuss all the services, including few more as we proceed. Yes, Jordan, the answer is yes. Fine. So that's about the main stuff. Fine. So as an architect, our job is to make use of these services to reap the benefits of cloud computing that it offers to us. And that's about the stuff. So let's get started with the first topic, that is identity and access management. What exactly that is? See, today you just, let's suppose that you're working for an organization. and you enter your office premises, and the very first thing that you do is that you just you sign up, you start your Windows computer and sign in. So the credentials that you have to sign into your Windows computer is different from the credentials that your coworker has who's sitting nearby. So every business application, every machine that you sign in, every employee of the organization has a set of own credentials to sign in. Fine. Why? Because it is extremely critical in a business environment that the access are being segregated based on your requirements, your roles and responsibilities, and based on what access you have, you can perform some operations. So this is where the same stuff comes in, where we discuss the IAM, that stands for Identity and Access Management. What's that? See, it's a web service that helps you to securely control access to resources. You use IAM to control who's authenticated, who is not, and you give the authorizations. What I mean by that? See, when you sign into AWS, when you sign up, the account that you're signed up for is called the root account, right? So the account that you're signed up for is the root account. What is the root account? Root account is the master account that you sign up using a credit card or debit card, right? So you use the credit card or debit card to sign up. If you use a credit or debit card to sign up with AWS, this means that you're using a root account or a master account. Now, what are the benefits? What are the advantages? And how exactly the entire thing is being set up for you? So what happens in this case is, the thing we're going to discuss is called the IAM, right? So what exactly you will be doing is identity and access management. Fine. Now, what exactly you need to do is, or understand is, that when you sign up for a root account, think from a business perspective, because you're going to be performing just the hands-on. But what about a complete business environment? Let's imagine a company named as Accenture signed up for a root account. Okay, so there's a business unit. There's a business unit, or for example, the company signed up. There's a company named as Accenture, or any company. It signs up for a root account. Sometimes we call it as a root account. Sometimes we call it as a master account. But generally, from the context of AWS, it's a root account. Now, that root account needs to be shared with internal employees. Who are these internal employees? These internal employees are your cloud engineer, solutions architects, DevOps engineer or DevOps professionals, developers, administrators, etc. Right? So a company signs up for a root account using its credit card, debit card. That root account it needs to be shared among all the people in the IT and software departments, so that these people can help in the deployment and management of the resources on the cloud or on AWS, right? Accenture CEO or CTO will not perform development, software testing, DevOps operations, architecture deployment, designing part. No. Who will do that? We will do that. So the company says that, okay, we sign up for a root account with AWS and we share that account among you. You help the company deploy, manage, design, architect, or I would say monitor the entire infrastructure on AWS, right? So what happens is that the root account create IAM users, right? So these people become, who are these people? They become the IAM users, which are nothing but these are the identities. What are these? These are the identities. You identify, okay, who is your solutions architect, and you give him the access. Who is the developer? You give him the access. So these people in your IT and software verticals will be helping you to deploy and manage the resources on Amazon's infrastructure. You create IAM users under the root account and you give them the access. Fine. So that's why it's called identity and access management. You create the identities, the users, and give them the access levels. Is this point clear? So basically, it is nothing but the root account ensures that you perform the authentication. Authentication means that you define the credentials for them. What's that? Authentication. Authentication means that the credentials that you set, and the authorization. What do you mean by authorization? Authorization means that the permissions that you want to give to them. Fine. What do you mean by authorization? Authorization means that the permission levels, the permissions, right? So a root account owner create multiple IAM users and says that, okay.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
I authenticate these users and I authorize them. They can perform these operations. For example, I a root account, a root account owner says, okay, I want to create a user named as Chris. There's a user, there's an IAM user. His name is Chris. Who is Chris? He is my lead developer, or he's my, for example, my database administrator, DB admin. So this means that I will give him the permissions. For example, he can access these database services on AWS. What are those database services? For example, we're going to discuss them afterwards. RDS, DynamoDB. So these are the database services on AWS. Some of the database services that the Chris should have access to. Who's the Chris? Is my database administrator. So I authenticate him and authorize him to use this service. You authenticate plus you authorize. This is the crux of the identity and access management, where you create the identities and you give them the permissions. Fine. Let's understand some more concepts. So why access management is needed? Because in a business environment, based on the roles and responsibilities that the company has given to you, you may be an administrator, you may be a web developer, you may be a data scientist. The company says that, okay, we'll give you access to certain dashboards, certain services, so that you can perform your responsibilities. A data scientist cannot access the web developer resources. A web developer cannot access the admin resources, and vice versa. Every person responsibility is being determined, segregated. Based on that, you get the access levels. Fine. Because in a business environment, you have to have a very strict and tight control upon the resource allocation. Fine. So let's understand the very first feature of IAM, that's called the IAM user. It represents an entity. It can be a person or a service, but 99.9% of the time, an IAM user is a person only. He's an employee in your IT software department. He can be a solutions architect, a cloud engineer, a DevOps professional, a Linux administrator, a database administrator, anyone. You identify that person. You create the identity or entity. By default, there are no permissions allocated. You define the permissions for that user, saying, okay, you are the user, we'll give you some permissions. Fine. So basically, the IAM user will be using AWS on behalf of the root user to perform day-to-day operations. Let me show you that. If I go to IAM, or the Identity and Access Management, let's see that. Now this is the AWS Management Console. Now I just go to the IAM, the Identity and Access Management. Let's go there and click on that. Now you need to find the services. There are two ways out. Either you can just click on this these dots, and you can see the categories of services over here. You can just go to you can just go to the services over here, and you can just search for the list of services. Or what you can do is that you can simply just type the name of the service on the top, IAM, and it shows up. You can see that IAM manage access to the AWS resources. Because right now I'm just giving you the conceptual understanding. So I just went to the IAM, the Identity and Access Management, and the dashboard appears. Now the thing is that you can see that on the top, I can't change the regions because IAM is a kind of a global service, right? Global service means that you don't need to change the regions to create the users groups roles. You don't need to do that. Now this is the IAM dashboard. Every service on AWS has its own special dashboard. Okay. Now I have the users created in one of the previous conversations, so let me just get rid of them and have a clean layout so that you can see exactly then how these users are created. So just give me a second over here. Fine. So what I'm going to do is right now is this is the dashboard, right? You can see that these are the IAM resources we have: groups, users, roles, policies, identity providers. Let's go to users. As of now, I have 0 users. So this is my, for example, this root account is owned by a company named as JP Morgan. It's a big organization. Let's imagine JP Morgan wants to leverage AWS. They use the company's credit card or debit card to sign up with AWS, maybe a business unit in JP Morgan. And JP Morgan says, now I want to bring the users on board who will work on AWS account on my behalf to perform day-to-day operations. So JP Morgan as an organization with its root account will create users. So I click on the users right now, and you can see that an IAM user is an identity with long-term credentials to interact with AWS. See, IAM user is nothing but it's the set of the root account. It acts as a root account with its own credentials. right? Most people confuse that IAM account is a different account. No, it's a parent-child relationship. So if you talk about an IAM account, so IAM account is nothing but, or an IAM user is nothing but it's an entity that uses its own credentials, to sign in to the root account. I'm sorry, I didn't put yeah. So IAM user uses its own credentials to sign into the root account, because a lot of people confuse saying, okay, IAM account is different, root account is different. No, IAM user is nothing but it's kind of a child of root account. It uses its own credentials to sign into the root account and perform operations and perform daily operations. Fine, this is clear. So let's do one thing. Let's go ahead and go back and let's create some users. So I click on add users over here. Add users. Now I can add multiple users at once. Now the thing is that in a business environment, you have some formats. Sometimes the company goes with the initial of the first name and the last name. For example, Steve Jobs, S the initial of the first name and Jobs as a surname. Or just type in Steve as a first name. This will be the user ID of the IAM user. This would be the username of the IAM user. So I add few names over here. Fine. So I've added 6 users as the IAM users. These are the usernames. Fine. Now the next thing that we're going to be doing would be that we give them the type of or the level of access or the credentials that I want to set. The first one is the programmatic access. Programmatic access means that if they're using the root account to perform some CLI commands, to run some CLI commands, to run some API or some other development tools. Basically, I'll show you that every user will get a key, so that key can be used to access AWS CLI, merge external tools with AWS. Fine. But the main thing is the password for the AWS Management Console access. These are the user IDs. I can set an auto-generated password or I can set a custom password. Okay. So let's imagine I can set a custom password real quick. Fine. So I set a custom password for them so that these people can use these usernames to sign in, and I've set the password for each one of them. Fine. Now I can uncheck this option which says required password reset. Now, because each one of these users will have the same password, if this is checked, every user will get prompt at the very first sign in to change its own password, to change his or her password. Fine. I will just uncheck it as of now, just for the simplicity. So that's why this is checked, so that every user has the same password. As soon as they sign in, they get a prompt to create their own new password. Okay. So I will uncheck it as of now. So these are the user IDs. I've set a custom password for them, and I've given them the programmatic access because they can use the keys to use the CLI, API, software development kits, or development tools with AWS that I will show you later on. Fine. Is this clear? Now, so this is about the stuff. Fine. So that's about the user IDs, the credentials that we have set. Okay. I click on X permissions. Now you'll be doing this hands-on. I'm just explaining you the concept. Don't do it right now. Just understand the concept so that you need to have the conceptual understanding first. Now, the next thing that I need to assign is the permissions. See, these users are of no use if I don't assign any permissions to them, right? For example, today you go to your company, you sign into a Windows computer, and you're not able to open any application. It's worthless. Every user needs credentials plus the access rights, what operations he or she can perform. Okay, so we can assign the permissions as of now, but as of now, I would skip the permissions. I can link the permissions afterwards. Click on Extract tags. Now tags are nothing but these are the optional parameters just to tag the entire configuration. It is nothing but it is obviously a useless feature right now, especially in this case. I click on Next Review. Now it says these users have no permissions. We know that. I get 6 users created with 2 types of access. I set a custom password for them. Fine. Now how exactly I can assign the permissions, I'll let you know afterwards. I click on create users and my users get created. Now let me show you one thing. These are 6 users created, and every user apart from the user ID and the password to sign in to the AWS Management Console will also get these keys. These keys can be used if they want to programmatically access AWS. What do you mean by programmatic access? For example, command line interface of AWS can be signed in using these keys. Okay, I'll show you one thing. So I'm not sure whether the CLI tool is installed on my computer. If I just go to the terminal, CLI we're going to discuss maybe afterwards. So if you just type in AWS configure Yeah. Can you see that it's asking for the access key? Let's suppose I copy the access key ID of Steve and copy the secret access key of him. Right now, I have used the command interface, the CLI, to log into AWS. Now I can run the command, for example, AWS S3 LS to see the list of because this user has no permissions. What he gets? Access denied. Can you see that? Access denied because this user is authenticated, but this user cannot list my S3 bucket. I'll let you know what this S3 bucket is, but generally it is a storage option. Fine. So these users can programmatically access my root account. For that, these keys are needed. Now I can send the email. It will open the email client on a computer to send them the instructions. I can just download the CSV to download this entire information in a CSV file. Click close, and you can see that this is being done. Okay. Now I think this is clear in terms of user account creation. Any questions you have, just let me know. So these users are created. Now, what about these users signing in? Okay, now the question now comes up, how these users can sign in. Okay, how these users can sign in. There are two ways out. Either these users can do one thing. They can go to aws.amazon.com, click on sign in. Okay, and once you sign into to the AWS, you get two options. Sign in as a root user email, root account, JP Morgan, or okay, if I click on, you can see that. Do you want to sign in as a root user or an IAM user? Root user, we know that JP Morgan has is a root account, but right now I want to sign in on behalf of the IAM user. Right now, it will ask you what's the account ID of the root account that you want to sign in. What's the account ID? The account ID of the root account. See, every root account, even you can want to see at the top right hand corner, you can see the account, your account ID. Every root account gets an account ID, but the IAM user doesn't get that. A root account will get a specific unique account ID. Fine. Every root owner, every root user will get a specific unique account ID. No two root accounts IDs will be same. So I copy it right now. Just go back and paste it because I want to sign in as an IAM user. Click on next. Okay. It will say, what's the username? I type in the username. What's the password? I just type in the password. And this user is able to sign in. This is the first way out. This is the first way out. You can see that this IAM user is signed in. This IAM user is signed in. Fine. This IAM user is signed in. Now, what about the second option? The second option is that if I go to my dashboard on the root account, can you see that on the IAM dashboard on the right hand side, there's a sign in URL. I can also give this URL to my IAM user so that he can sign in, right? If I copy this URL and show you right now, this user can also sign in using this URL. So that you have both options. You have both options. In this case, the IAM user does not need to put the root account ID. So Chris can also go ahead and put this link, the IAM user link, the dashboard link, and then he or she can easily sign in because it will automatically populate the account ID. Chris can sign in like this and put in the password. So you have both options. You have both the options over here. But this is relatively easy because in that case, in the first option that I showed you, the user had to put the account ID every time. But if I give this link to to every user, he or she can bookmark that link. The link will be the same for all the users. Fine. This IAM user link that will fetch from the root account and give to all my IAM users saying, okay, please use this link to sign in every time. Fine. So that's about the stuff. That's how an IAM user can sign in. Now let's understand this thing, that these users can sign in, but for example, if this user, Chris, I'm signed in on behalf of this user, if he tries to perform any operation, he will be kicked out. For example, he goes to all services and he says, okay, let me deploy an EC2 instance. An EC2 instance is nothing but it's a virtual machine. So immediately he will get an API error or access denied because I haven't applied any permissions whatsoever to any of the users. Fine. Now, how exactly that's being done? To assign the permissions, we use something called IAM policies. I'm not sure whether it's there on the IAM policies. What are the IAM policies? IAM policies are the way to assign the permissions. So these are the JSON documents which mention that what a user can do. You need to use the policies to assign the permissions to the user. Fine. If you don't assign the policies, the user will not get the access. How I give the access? I go back as a root user, JP Morgan. and I pick the user. The user named is as Chris. Now I go to Chris account and say, now guys, understand the concept. Again, I'm saying don't learn or try to do the same things on yourself, on your own. It will not help you. You don't have to learn the steps. Understand the concepts right now. Simply just sit and understand the concept. Don't do it anything, because I'll give you 1 hour or more than that to perform all these things by yourself. Your main responsibility is to sit and understand the things. Now I went to Chris' account. Chris has no permissions whatsoever. How I went to the Chris? I went to the users page on my root account. Click on the Chris username, and I'm being prompted saying that, okay, this user has no permissions. Could you please add permissions? I click on add permissions, and the 3 options I get. I go to the third most option on the right hand side, which says attach existing policies directly. Attach existing policies directly. Okay, these are the JSON policies I was talking about. Can you see that? These are the one that we use to perform the permission management. For example, the administrator access is a JSON policy that gives the highest level of access to any IAM user. I expand administrator access. It says provides full access to the AWS resources and accounts. Now, of course, every business will have only few administrators, not all of them. Okay. Now, this is the JSON policy. JSON stands for JavaScript Object Notation. This is the JSON version of it. This is the JSON version of it. Now, let me do one thing. Let me just go back to this thing, my tab, and explain you how the JSON policy works for you. So, how exactly the JSON policy functions? Fine. No, this is the only one that we can use. That's what I was talking about. That you don't get the customization or your own preferences once you go to the cloud. JSON policy, it consists of different parameters. The first one is the version of the code. The main thing is the statement. What's a statement? Try to understand this thing. A statement is nothing but it's a formal description of a single permission, which means that a statement includes permission. It can have multiple permissions or generally a single permission. A statement means that you have a permission. Now, in that statement, there are 2 types of effect: allow or deny. Using this policy, do you want to allow something or deny something? So there are 2 types of effects that a statement can make or a policy can make. What are they? One is allow, and the other one is, what's that? Deny. Right? Either you can allow something or you deny something through a policy. Then going back, what type of action? What type of action in this case we want to allow? What do you mean by action? Action means, for example, just for us simplicity, let's suppose read. So for example, read, write, or modify or change. What type of actions can be implemented? Okay, fine. So I'm saying, what do you want to allow or deny? What action? What type of action? And on which resource? Resource means AWS resource. Resource means service or a component. Fine. For example, I give you one example. Launch instances is an action, and EC2 instance is a resource. Is this concept clear? Fine. So I'm saying launch instances, instance means virtual machine, is an action, and EC2 instance, EC2 stand for Elastic Compute Cloud. It's a service that we use to deploy the virtual machines. Fine. So I'm saying a JSON policy is nothing but it's a formal description of a single permission. What type of effects that permission will make, allow or deny? What type of action? Read, write, change, launch, terminate. On what resource? So I'm saying, for example, launch instance is an action. EC2 instance is a resource. So I'm saying I want to launch my EC2 instances. It may sound a bit confusing right now, but as you start implementing these things, it will be very easy. So a JSON policy is nothing but it's a formal description of a single permission. Fine. Now, can you see over here? Action is asterisk, resource is asterisk. Because it provides full access, asterisk means everything, all. So if you see asterisk or a star anywhere in the policy, if you see the asterisk anywhere, it says all, everything, or anything. Basically, asterisk means everything, all, any, right? So, right, if you go back to this policy says, I want to allow every action to every resource, right? So because the administrator access gives full access, it allows every action to every resource. Okay. Now, I can choose some more policies, but right now it will confuse you. I choose the administrator access for my account Chris. Click on next review. So I'm adding this policy administrator access to the person Chris and add the permission. Now these permissions will be applied, or this permission will be applied directly to Chris. This permission will be applied directly to this user account. Now if I go back to Chris account, his account, previously he was unable to perform any operation. But now if I hit refresh, you will see the error will be gone. The error is gone because Chris has all the access now. He can perform any operation on any of the resources on behalf of the root account. See, if you see over here on the top right hand corner, what it shows, account ID. This is the root account ID, and IAM user Chris is the IAM user under the root account ID. Okay, so this is how we define the permissions for the user. Okay, now the problem is that these policies are default policies. There are two types of policies we have. One is custom, one is, so what are the two types of policies we have? What are the two types of policies we have? There are two types of policies we have. What are those? The first type of policy is default. Default, or something we call it as AWS managed policies. Okay, so if I just go to the policies, yeah, there are two types of policies we have. One is AWS managed. AWS managed are default policies. These are default, but you can't customize them. They cannot be customized. Fine. One is the AWS managed. The other one is the customer managed. Customer managed means that these are created by customer. Customer means the AWS account owners, created by customer, the AWS subscribers, and you can be customized. Fine. So there are two types of policies we have, AWS managed and the customer managed. So I think this is clear. Creating IAM users, the identities, and managing permissions using the policies. I think that this point is clear. Now I give you a very small brief description of the S3 bucket. What is S3 bucket? What are the objects? And then we'll start with the hands-on. Okay. So what we're going to do is, let's understand this concept, because the hands-on will be dependent on S3 bucket. So some people say, wow, why you're discussing S3 right now? Because it's not the part of IAM. Yes, it's not. But because the hands-on that we're going to do would include an S3 bucket, that's why I'll give you a very, very brief overview of it. See, we use a storage service that's called S3. We use S3 buckets to store our data. We use S3 buckets to store our contents. For example, this is my S3 bucket. Okay. Now this S3 bucket is nothing but it's a fundamental container, which means that it can contain your data. It's a fundamental container. It can contain your data, right? A bucket is a storage option which can contain your data. And the data that you put in the bucket is called an object. What's an object? It's a fundamental entity. It's a data only. It's a file, it's an image, it can be anything. It's an entity. It can be, for example, your image, your documents, image, docs, etc., etc. Anything. Fine. So it's nothing but it's a piece of document that you put in the bucket. Okay. A bucket is a container where you put all the data in the form of objects. Now over here, there are few read actions you can perform with S3 bucket. For example, list. List means you can see the list of data, list of buckets. Read, get. These are the read actions. Get means getting the data out of it. Or I would say, I'm sorry, no, get. Yeah, get is also read action. Listing the data, reading the data, getting the data. These are the read actions. Okay. Then we have write actions. For example, what are the write actions? For example, putting some data in the bucket. Put, delete. What are these? These are the write actions. Put, delete. These are the write actions. Fine. So with respect to the bucket, listing the buckets, the data out of it, list, read, get are the read actions. Put and delete are the write actions. Okay. So based on this thing, we're going to be doing a very extensive hands-on for an hour. I'm not sure whether we can complete it today itself, but we'll try to do the most of it. Okay. For those people who don't have the account, you just need to sit and watch what exactly is being done. So the concepts that we have discussed as of now, we're going to put that concept in a complete 1 hour document. It can take more than that. So let's get started now. What's the purpose of this hands-on? The purpose of this hands-on is to understand that how to create a customer managed policy. See, my approach is that I let you do the hands-on, guide you through the process of doing the hands-on, because you can put 1,000 questions. My experience is that out of 1,000 questions, 80% of the questions are not based on or not relevant. Why? Because if you don't do the hands-on by yourself, then even if you put the questions, they don't help you to clear your understanding or help you to understand the stuff at the root of it, right? Once you perform the operations by yourself, then you get the sense out of the things that we're discussing. 80% of the questions that people put, they forget what they asked just after 24 hours. Why? Because sometimes we don't even know that what we're asking. Once you do the hands-on, you're going to be seeing that 90% of your questions would already be answered. Because once you do the hands-on, what we exactly get at that time is that we get the knack of, or we just get to the root of the concept. We apply it and we understand exactly that how the things function properly. That's very important, right? Now the approach would be that I'll let you do. I'll just perform some steps by myself. In that journey, I'll explain you some basic concepts, some theoretical concepts. If you have any questions, you can put the questions in the chat box. Then I'll let you do the things, the few steps by yourself. You type in done. Then if you're stuck somewhere, I'll help you out. Once we complete, for example, first 10 steps, then we go to the next 10 steps. Understand the entire theory, understand the concept behind those steps, complete the next 20 steps, 10 steps, and then move to the next steps. That's what the approach is. Now the statement says, or the main agenda is that we need to create and attach a customer managed policy. Customer managed policy means that it's a default, it's not a default one. It's a policy that we create based on a business requirement. Okay. Now, why exactly that's needed? See, basically, we want to ensure that we create two S3 buckets and we create a policy so that we give the read access to one bucket and full access to the another bucket. Okay. Now, 90% of the people will be confused right now, but as you go step by step and explain the theory behind every step, you'll be able to understand exactly that why we're doing that step, and will help you to hone your understanding and your conceptual base. The first step is that we will create two S3 buckets. S3 buckets are nothing but these are the containers that we create with some basic parameters in which we can put the data. Now, why are we creating these buckets? Because the policy that we can be creating for as a root account owner right now, there's no IAM concept as of now. IAM user concept will come in the third step. As a root account owner, the free tier accounts that you are using right now, these are the root accounts because you signed up using credit card, debit card, right? Now, from the root account, you're going to be using or you're going to be creating two Amazon S3 buckets. So I'll show you the step number 1 to 7. Okay, you have to create two buckets, steps number 1 to 7. I'll show you. Don't do it right now. I give enough time, then you just type in done once you're done. So once you go back to your main account, just type in S3 keyword on the top. Click on S3. Fine. See what I'm doing. Don't do it right now because you can just use this document, the screenshots to do it to perform the steps on by yourself. Also, I'll help you. See what I'm doing. This is called S3 dashboard. What this is called? S3 dashboard. This is where we create the S3 buckets in which we can put our data into. Now I create two buckets right now. I click on create bucket. You can see that what are the buckets? These are the containers for data storage. It can be used for storing your business application data, business app data, your warehouse data, data warehouse data, BI data, or maybe your backup data, archive data, whatever data it is. It can store the data. Now you need to carefully assign a bucket name. Bucket names are unique in nature, which means that no two buckets on AWS can have the same name. S3 stands for Simple Storage Service. For example, Simple Storage Service. I use the bucket name as test. I click on create. It will simply say the bucket name already exists. Like two people don't have the same Gmail IDs. Two people don't have the same Facebook accounts, Facebook IDs. Similarly, no two buckets on AWS can have the same bucket names. So you have to think of a bucket name which is unique, right? And append one at the end of it. One or two or first or second, whatever you think is best for you. So I choose this name, IAM demo, Intel demo IAM first. You can choose the region where the bucket resides, or you can just keep it as it is. Scroll down and click on create bucket. Your bucket would be created. Fine, your bucket would be created. Now I click on create bucket one more time and just type in second for the second bucket. Okay. Scroll down and click on create bucket. 2 buckets are created, and if I sort by the creation date, I have 2 buckets.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
These are the 2 buckets that I've created. Intel Demo IM first, Intel Demo IM second. Now the bucket names can be alphanumeric. You can also put the numbers, right? But only 2 special symbols are allowed, a hyphen and a dot. You can also put numbers 1, 2, 3, whatever you can. So it can be alphanumeric. Steps number 1 to 7, you have to create 2 buckets. You follow the document, create 2 Amazon S3 buckets, which are nothing but these are the containers. You have the document with you. Steps number 1 to 7. Let me know once you're done. Just type in done on the chat box once you're done. It's well documented on the document, right? You can see the screenshots. Go slow. You don't have to catch a train or a plane. Don't choose or any of the setting which is not mentioned in the document. I've already mentioned those things in the document that you need to configure or you need to apply. Don't change any other thing that's not mentioned in the document. You just need to just assign the bucket name, choose a region or keep it to default, scroll down and click on create bucket. Simple thing. Simple instructions. Yeah, uppercase also. Uppercase should be allowed. Uppercase, basically we use lowercase only. We use, use lowercase. I think uppercase are not allowed. Yeah, don't use uppercase. Uppercase, so lowercase, alphanumeric, so it should be lowercase. So it should be lowercase only. Alphanumeric, it can be alphanumeric. It should be unique, right? And only 2 special symbols are allowed. One is dot and other one is hyphen. See, anything, again, I'm saying very simply, putting forward, you don't have to change any of the parameters. Simply scroll down and click on create bucket. Assign the bucket name, scroll down and click on create bucket. Just type in done once you're done. In this hands-on, the approach would be, see, in any account, so basically I'm talking about the root account only. So an AWS account can have up to 100 buckets. Fine. Now let's imagine I have a special requirement where my user Steve should have read-only access to the first bucket, okay, and he has the full access to the second bucket. There's a special requirement I have, full access to the second bucket. This is a special requirement that I have right now. So why did we create 2 buckets? We'll have the IAM user to have the read-only access to the first bucket and full access to the second bucket. Fine. Now the question would be, can't we use the default policy? Why are we creating the custom policy? I'll let you know why. If I go to the IAM and show you the policy right now, I go to the policies page. Let me show you. On the left hand side on the policies, if I just type in S3 read only, there's a default policy S3. This is the AWS managed default policy. If I expand this policy, can you see the description? What it says? Provides read only access to all the buckets. If I apply this default policy to my IAM user, by default, he will get the read-only access to all the buckets. So I may have 100 buckets in my account. Right now, how many buckets I have? 15. But the IAM user should get the read-only access to only one bucket, not the rest 14 or rest 99. Fine. So in these type of scenarios, the default policies, they don't suit your business requirement. My business requirement is very simple. Steve is my IAM user. He's an IAM user. He needs a read-only access to one bucket and full access to the second bucket. Now, if I go with the even if I show you the full access, even if I show you the full S3 full access policy, the problem is that it will give the full access to all the buckets. If I show you the S3 full access policy, it will give the full access to all the buckets. Can you see that? All buckets. But I just want to focus on 2 buckets. Read only access to one bucket, full access to the second bucket, and by default, access to other buckets will be denied. So that's why requirement is. For this, to fulfill this requirement, I don't have any other option but to create a customer managed policy which suits my customers' need, my needs, my business needs. Fine. So the next step would be that I'll show you how to create a customer managed policy. Simple. So I show you the steps and let you do the steps by yourself. afterwards. But see what I'm doing right now. I'll show you the step number 1 to 1 to 11. See, I'm doing what I'm doing. Don't be in a rush, okay? Because I'll be letting you understand the concepts first. Steps number 1. I go back to my account. Now don't ask root account or IAM account. IAM account I haven't created. You haven't created right now. So don't fall into the trap. I went to my account, search for IAM on the top, and it will take you to the IAM dashboard. Identity and Access Management, IAM. Okay, you go to the IAM and this will present on the screen the IAM dashboard. Okay, you don't have to create any user as of now. Simply go to the policies on the left hand side. Now you can see the list of policies. You can see a policy is an object in AWS that defines permissions. Click on create policy. Fine. Just be very careful what I'm doing because I'll not repeat the steps. Don't do it right now. Just see what I'm doing. Basically, the easiest way to define a policy is to use a visual editor. It's a tool where you select few things and automatically it spits out the JSON programming or JSON code for you for that policy. In this visual editor, we click on choose a service. Now for which service we are creating this policy for? S3. You choose S3. Now it will ask you for S3 what actions you want to include. List and read. Now these are documented in the document, so don't worry about these steps. So I'm saying list and read because I want to give the read only action or give the read only access to the first bucket. So I go back to my this actions IAM and choose list and read. Fine. Scroll down. Now it will ask you which resource you're referring to. You define the actions, you define the service, but what's exactly that resource is? You have to click on the resources bar, scroll down, and it says all resources or there's some specific resources. I need to pick bucket as my resource and specify the bucket ARN. ARN stands for Amazon Resource Name. It's a special identifier that you assign to the bucket, that AWS assigned to the bucket. So I click on add ARN. Okay. I go ahead and copy and paste the bucket name like this and paste it. This automatically populates the ARN or the Amazon resource name of the bucket. It's a special identifier that it links to its buckets or resources. If I choose any, then it will include all the buckets because asterisk means everything. So if the bucket name is asterisk, it says every bucket. But my concern is that this read only access should be given to the only one bucket only. And click on add. But what about the data that you put in that bucket? For that, you have to explicitly define the permissions. You need to go to object, says specify object resource ARN. Click on add ARN, define the bucket name, and write to the object name, choose any. So I'm saying that these permissions will be applied to every single object stored in the bucket. Click on add. Okay. Now guys, what about the next bucket now? For the next bucket, the steps that I'm going to show you are the steps number 12 to 24. See what I'm doing right now. What you have to do next is that you need to go back, scroll down. Can you see there's an option that says add additional permissions? Go over there. Now the next permission that we're going to add is for the second bucket. We'll perform the same step, choose a service. Which service we're going to choose? S3. Done. Now for the second bucket, I want to give the full access. I choose all S3 actions. All full access. I scroll down, go to the resources, specify the ARN now. Now the ARN would be for the second bucket. The only difference is that I'm giving the full access to the second bucket. I specify the second bucket name. Add. Scroll down, click on add ARN for the object. Specify the bucket name like this. And in the object name, I choose any. Basically, the steps are same for the second bucket, except that I give the full access to this bucket. Second bucket, click on add. Fine. So the first statement, we have two statements. The first statement gives a read-only access to the first bucket, and the second statement gives a full access to the second bucket. Fine. Click on next, add tags. Now tag is optional. No, you don't need to tag this configuration. Click on next review. Simply assign a name to this policy and name it as, for example, custom IAM policy for S3. That's it. Go ahead and click on create policy. Okay. Now Basically, the thing is that we have done most of the job, the critical job we have done, because the customer managed the main thing that we were supposed to do was that we need to create a customer managed policy. So that's been done. Okay, there's no challenge in terms of doing that. The next thing that comes into the entire scenario is that we need to test it. So in the step 3, after the step number 24, if you just go through the document, how to create multiple IAM rules. Divansh, IAM rules we haven't discussed as of now. Okay, rules is a separate concept. I'll discuss with you today itself after we're done with this. Okay, all right. So let's go to the next step, step 3. I'll show you the process to create an IAM user. It's a very simple thing. I've already shown you, but I'll just reiterate that entire process. So I'll create one user while making sure that that user is added on the customer managed policy that we just created and configured. Okay, so that we're going to be doing right now. So what we're going to do is step number 3, which is create an IAM user while attaching the customer manager or custom IAM policy to it. So this is the step that we will perform. So I'll show you the step, see what I'm doing, then I'll give you enough time to do it by yourself. So don't be in a rush. Fine, see what I'm doing right now. If I go back to the IAM dashboard, the main page from where we can access all the IAM resources, you're going to be seeing that on the left hand side we have users, roles, groups, and policies, or you can easily see that we have the users option on this page itself. I already have the 6 users. I'm pretty much sure that for you, you have 0 users. So if you go to the users page, you get the option to add user. So click on add user. Once you click on add user, then the next thing that it prompts you is the username. Username is you have to type in. You can just type first name of any person. Okay, so for example, I type in, let's suppose, my first name. Okay. Now, once I just type that the name, the first name, that will be the user ID of the IAM user. Under the credential, choose this one, password AWS management console access. Okay, we just want to generate a simple password for this user named as Rohan. Fine. I just go to the console password. Either you just go with the auto-generated password, or I would recommend choose a custom password that you can think of. Fine. You can just uncheck required password reset, because if you do that, then once you just sign in on behalf of this user, you'll be prompted to change the password. There's no need for that. Okay. So username, then I set a password and click on next permissions. Now this is where you need to attach the customer managed policy with the IAM user. So you need to go to attach existing policies directly. Just go over there. Okay. The third most option on the extreme right hand side, attach existing policies directly. Now you get this option, filter policies. Go to the filter policies and check customer managed. Fine. In the customer managed policy, you get a list of the customer managed policy that you created in the previous day. Choose it. Okay, this is the same policy through which this user will get the read-only access to the first bucket and the write and the full access to the second bucket. Okay, click on Extract tags. Tag is an optional parameter, not mandatory over here. Click on Exit Review. So this is a review page. It says username Rohan, console password custom. So I've just set the console password for this user, and this is the customer managed policy that I've linked with this user. So I click on create user, and this user gets manufactured. Okay, fine. Now to test this user access, I can use this link. So I copy this link over here. Okay, we can test it afterwards. Okay, so you have to perform the step number 3. Step number 3. Yeah. So please go ahead and do that. Done, Panu? Okay, great. Now comes the testing part. How to test? For testing purpose, we're going to be just go with the 4th step, which is test user access. I'm going to show you the steps right now. Very simple steps, nothing very technical. So basically, now if you have a different browser, you're going to need that, or you need to sign out from the root account. Now the thing is that to test the user access, it's a very simple concept. I'll show you the step number 4. So what you're going to do is that either if you hit close, you can just go to the dashboard and get the link, or you can just copy the link from here. So I copy the link, for example, like this in front of you, and I just open the Google Chrome browser. So right now the main browser I'm using Safari, but because I'll be using a different browser to test the user access, so I use Google Chrome. So I try a different browser right now and just paste this link. Yeah. So I've copied and pasted the IAM user link. Okay. Now it prompts me for the username and simply just type in the password. Done. Now to test the user access, you can play around if you want. If you, for example, if you just try to go to EC2, it's a service through which you can deploy your virtual machines or the EC2 instances. You're going to be seeing that you'll get the API error because apart from S3, you don't have access to this user has no access to any of the service. Now, if you just search for S3 and just go to the S3 storage option, you're going to be seeing the list of the buckets that that were created before. So this is the list of buckets that I have. Now, if you randomly, okay, so in my case, of course, you have two buckets. If I randomly pick any bucket, I would be getting this option, insufficient permissions to list the objects. If I pick, because I have 15 buckets right now, if randomly I pick any bucket, I'll be denied access. So I search for the bucket that we created yesterday, and I just go to the first bucket. Now, for this user, the IAM user, based on the policy statements, the IAM user has the read-only access to the first bucket. So I go to the first bucket right now and try to upload an object. What's an object? It's a piece of data. So I click on add files and try to upload a simple file. Okay. Click on upload and you'll see that it says upload failed. And what's the exact error message that it gives me? Access denied. Why? Because the IAM user has no access whatsoever to write any content to the system bucket. Similarly, if I just go to the buckets again, go to the second bucket and just try to upload the same object or the file to the second bucket, you're going to see that this would be successful because the IAM user, based on the policy that I've added to the user, has the full access to this bucket. Even this user can choose this object and click on delete. Even this user can easily delete the object. Write the object, delete the object because this user has a full access. Fine. Let's discuss the next concept. That is the concept of groups. What exactly that is and why do you need that? Let's start with the next feature. See, basically what happens is that in a business environment, especially in a big company, you just don't have 5 employees or 10 employees. You have hundreds, maybe thousands of people in your IT software departments. Now, basically, what is a group is that you collect the IAM users together in a group, and instead of assigning the permissions to the user, you assign the permission to the group of users. So the purpose of the IAM is it's very simple. It ensures that every single user is put in the group, and instead of assigning the permissions to the individual user, you assign the permission to the group, and all the users underneath will get the same permissions. For example, there are three groups on this PPT. One is admin, another one is developer, and the third one is operations. Fine. Now, in this case, what happens is that admin, developer, and operations are three groups. Under admin, I have three users: admin 1, admin 2, admin 3. Maybe these are, you can just put names: Steve, Chris, Kunal. Under developer, I have 5 developers. I put them under this individual groups. And instead of assigning the permissions to the users, I assign the permissions to the group. And consequently, every person in that group will get the same permission. Now, based on the best practices, this is the most recommended method of access management. Why it is so? Because in a business environment, the things are very process oriented. If you have 500 people working on AWS, if you start managing the permissions of every person out of 500, then it's very confusing, right? So to avoid that confusion, to ensure that you go with a very neat and clean process, and you go very process wise to ensure that the access levels are being given properly to every individual. You group the users together based on their job profiles, their roles and responsibilities, maybe their teams, maybe their business units, and then you assign the permissions based on the group itself, not the users. So what's the process? Let me show you. The process is that you just go back to the IAM page. On the left hand side, you can see that we have user groups. Go to user groups. Now, under the user groups, you can see that it shows you a definition. A user group is a collection of IAM users. So you click on create group, and for example, I name this group as developers. Fine. So this group is intended for my developers. So I simply assign the name as developers. Now once I assign this name to this group, then I start mentioning that which user or which of these users will be the part of my group. So what I do is that, for example, I pick Chris, Kavita, and Kunal. These three IAM users would be included in this group. They will be grouped together. Scroll down. There it says which of the following policies you'd be linking with the group. For example, my developers need access to code commit. It is one of the tools that the developers use. It is kind of a GitHub kind of service. So I choose code commit full access. Okay. Now my developers need access to pipeline, code pipeline full access. Okay. Then code guru, code guru. Let's see profiler full access. Then uh, code deploy. Let's choose this one. Code deploy full access. Fine. So I'm saying this is the group named as developers. I group three people together with the policies attached. I click on create group and you can see that my group got created. If I just go to the group right now, I can see the summary page of the group. The group name is developers. Fine. The group name is developers. I have three users, Chris, Kunal, and Kavita under the group. Now, because these three users are the part of the same group named as developers, if I go to permissions, all these four permissions, code commit full access, code deploy full access, code pipeline full access, code guru profiler full access, all these permissions of the policies would be common for all these three users because they are grouped together under the group called developers. So what I've done is that these permissions are attached to my group developers, and if I add any user under the same group, he or she will get the same permissions. For example, there's a button over here which says add users. I go to the group, add users. For example, I want to add Steve right now. I click on add users. Now I've added Steve in the list. So Steve will get the same permissions based on the policies linked with the group. So if I hire more developers in the future, all the developers will get the same permissions. I simply create the user ID and passwords. I set their credentials, put them under the group, and they will get the same permissions. This is the most process oriented and the most neat and clean method of the permissions management. Is this concept clear? So based on the best practices, you should never ever assign the policy directly to the user. Based on business best practices, you group the users together based on their job profiles or business units or teams, or maybe, for example, their responsibilities, and then you can do the permission management. That's about the stuff. This is how you do that. Okay, that's why we use groups so that we can group the people together based on their job profiles. All right. So that's about the stuff. The next thing that I'm going to discuss with you is the MFA and the IAM role. But I would suggest any question, guys. Is this concept clear? Okay, let me do one thing. Let me create one more group. For example, I go to the user groups and create a group for, let's suppose, new hires or yeah, graduate. Now that there are some graduate trainees who are being just who are freshers who are just passed out from the college, and I want to just go through the some training process. So I, for example, pick Suresh as one of the users over here, and also I pick Mahesh. Okay. Scroll down, and I look for the policy read only access. See what that policy looks like. Read only access. Okay. It is view only access. View only access. Can you see that? This view only access policy will give the grants a read only access to all the services. So for my graduate trainees, because they're just going through some training programs, they don't need to deploy anything. So I'm saying Mahesh and Suresh, they are my GTEs. These are new hires. I just want to show you them, or they want to just see the things. So I give them the view only access. I link this policy to them so that these people can just view the resources, but they don't have any option to delete or deploy anything. Fine. So I simply just scroll down and click on create group. Now, based on the group that I've just got created, if I just go to the graduate trainees and I see Mahesh and Suresh over here, Mahesh and Suresh, based on this policy, view only access will get the same permissions. That is the multi-factor authentication. What is this multi-factor authentication thing all about? See, basically, it is nothing but it's an add-on feature. So over here, let's discuss the multi-factor authentication or the MFA. So in this case, you might have seen this thing in your own company or on the organization. Basically, what you see is that there's a key that we use. That key is called RSA key, or it's called Gemalto key fob. I'm talking about this device. It's called Gemalto key fob. The technical word is we use as Gemalto key fob, but for the sake of because Gemalto is key fob is kind of how to pronounce sometimes. We to make it think easier, we use a term called RSA. Basically, RSA key. RSA key. Now, this key is the specialty of this key is that you link it with your applications. Apart from putting the user ID and passwords, you can also put the pin in that's being generated by this device, and this pin refreshes every few seconds. I think by default the timer value is 30 seconds. Let's suppose after every 30 seconds a new pin gets generated. This means that you have the physical access to this device every time you sign in. You use a new pin. So this is helpful in those scenarios when your password gets hacked or someone guesses your password, but because you have this device which generates a new pin every time, it is impossible to guess the pin that's there on your device. So it doubles the amount of security that your account should have. Fine. So this is the second layer of authentication that we add on upon our account sign in, whether it's a root user account or it's an IAM user account. This type of functionality is called the multi-factor authentication or multi-factor authentication, whatever way you want to pronounce it, right? So basically what happens is that these type of keys can be security tokens can be used, SMSs can be also used, and basically even you can use your smart devices. You can also use your smartphones, your mobile phones, your cell phones to have the same feature activated. So I'll show you a very small prototype through which you can enable the multi-factor authentication or the multi-factor authentication for your end user. Even for the root user, the process is same. And what is the intent? The intent is to ensure that you add on another layer of authentication or security for your accounts, or to your accounts to be more precise. That's what the purpose is. Fine. Okay. So I'll show you right now. So basically, the app that we use, we can use. Okay, let me just go to my open my iPad screen. Okay, when I restarted my computer, I had to my iPad got disconnected. Just give me a second over here. Now, the app that I'm talking about, you can get basically, the thing is that you can have your user devices being used, and let's imagine if I just go to the App Store, or you can just get them on the Play Store on the Android devices. You can look for and download any authenticator app which is available to you. So for example, I just go to the search option, just type in authenticator, right? Now you'll get multiple authenticator apps for free of cost. You don't have to pay for them. Google Authenticator, Microsoft Authenticator that use the most. You can use Salesforce Authenticator, whichever you think is the best for you. Okay. So you can use any one of these authenticators. Personally, I use Google Authenticator. I open the Authenticator app and let me remove the previous settings because I don't want to. Yeah. So I have the Authenticator app installed on my iPad. Let's imagine this iPad that is in my hands. It belongs to one of the IAM users. So this is a one-time activation process. Okay. And for example, I pick one of the users right now, and let's pick Chris. I want to activate. So let's suppose this iPad in my hands, it belongs to this user. I want that this user device should be the MFA device for him. It can be the tablet. It can be a smartphone, whatever you think is suitable. So I want to make this device as the Chris MFA device. So what I will do is that I go to this account. So right now I'm signed to the root account, and through my root account I want to activate the MFA for Chris. So I just go to the account details of Chris, and go to the security credentials. This feature you can find under the security credentials. Now, once I just go to the security credentials over here, you're going to be seeing that it says assigned MFA device. Can you see that? It says not assigned. This is set to not assigned. Now, I click on manage. It says that, okay, which type of device you're going to be using?
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Do you want to use the Gemalto token, the same RSA key that I showed you, the gray colored key? Now you can link that Gemalto token with the account. U2F security key is browser based. U2F devices, it's not that much used. It's mainly browser based. Or the more convenient and the easy way to use is the virtual MFA. Virtual MFA means that you can use an authenticator app installed on your mobile device or the computer. Of course, we don't not use computer in that case. Of course, these devices are the computers only. They have the RAM, CPU, everything. So a mobile device, install an app on it, which will generate the pins for you. So I've already have the Google Authenticator pre-installed on this iPad. I click on continue. Fine. Now it gives me a list of steps that I can follow along. One is that install a compatible app on your mobile device or computer, which I did. Then it says use your device camera to scan this QR code. So through the camera of this device, I'll scan the QR code. So I go to show QR code and I scan it now. So how to scan it? I just open my authenticator app on this device, click on get started. You can see the very first option on the top. It says scan a QR code. Scan a QR code. Done. Now I will just scan this QR code and immediately it detects that this activation is for IAM user named as Chris. So Chris @root account ID. Now you're going to see that there will be new pins generated and every 30 seconds a new pin shows up. Now I need 2 pins to complete the activation. The first pin is 372413. So I just go down and just type in 372413, right? I need one more pin or the code to complete the activation. Let's wait. 027813. I click on assign MFA. Now you're going to be seeing that this is being done. Now this device is the virtual MFA device. Now as an administrator, I'll perform the activation and hand over this device to the user, saying, now this is your MFA device. Now in the future, if this user wants to sign in, of course, he's going to be using the console link, the IAM user link. So let's log in on behalf of this user, Chris. So the scenario would be that Chris will use the sign-in URL as usual. So he's going to be using the sign-in URL to sign in. And once you put the password, immediately this will prompt him for the MFA code because the MFA is activated under his account. And the iPad is the MFA device. So he'll pick his MFA device, check what the code is. Now, before this code expires, it needs to be accepted. So 958902. So 958902. Click on submit. And if the code or the pin is correct, then I need to just put in the password one more time. I think the password that I put was incorrect. Okay, I just need to check the new pin now. The new pin is 149164. 149164. Click on submit, and this completes the sign-in process. So every time this user signs in, a new code will be used. So if someone guesses his password or hacks his password, the user has access to the device. So it's another barrier that we're adding on to the account, saying that okay, every time the user signs in, a new pin will be used. It is useful in those scenarios if the password is being guessed or hacked. So to prevent your account from unauthorized access, this is one of the add-on features. Fine. That's why it's called the multi-factor authentication or MFA. Now, what if, because all of our working from home nowadays, what if Chris is let's suppose in Hong Kong, I'm in India, he's staying in US or he stays in, for example, Stockholm, he's very far away from me. So it is impossible that I can physically access his device to scan the QR code through the camera just for a few seconds. Fine. So in those cases, if any of the users is far away from you, you cannot get the physical access to his device to scan the QR code. You can go to the username. I'll show you the process now. Then you just go to the security credentials, assign MFA, click on manage. choose virtual MFA device. Now, instead of scanning the QR code, because this this user is far away from me, instead of show QR code, can you see that? Alternatively, you can type the secret key. Click on show secret key and you email this entire key to the user. You email the entire key to the user. So for example, this user named as Davik is in Germany. I'm in India, so it is impossible. I would say it is senseless saying Davik, come to India because I want to use your device for a few seconds to perform the activation. Either I can just send the QR code via WhatsApp, or I can say I go to manage under his account and I do one thing. I just say alternatively you can type the secret key, show secret key, and email this key to him. Now this user can perform the activation by himself without handing the device to you. How he can do it? He can just simply click on. So he will just click. Can you see that it says enter a setup key? Can you see that the last option at the extreme right hand side, just down below, right corner, right hand side corner at the bottom, enter a setup key. I click on this option. So this user will type in his account ID and the entire key. He will just copy and paste the entire key, this key. So he can perform the activation by himself. Just in case if you're unable to get the physical access to the user's device, you can email this activation key to him and he can activate the MFA by himself or by herself. Fine. This answers your question. So this is where of course, we are working from home nowadays. This is one of these scenarios where we can just ensure that the user can perform the activation by himself. We can send him the key. No need for the third step, right? That third step is not needed. Okay, done. That's the stuff. Now, the next thing that I'm going to discuss with you is a bit, I would say it is not complicated, but it's off the charts. It is a very different concept right now. That concept is called IAM roles. What's that? So the next thing that we're going to discuss is the roles. Now, don't stress too much upon it right as of now, because we're going to be using roles a lot in the upcoming classes. But let's see that. Let's see that. So roles, let's discuss it. So IAM roles is an IAM identity you create in an account that has specific permissions. Now, basically, it is used to delegate access to external users, application services that generally don't have access to the resources. So maybe you want to allow an external user to get access to resources temporarily or some applications. For that, you're going to be using roles. Okay, I'll give you a few examples over here. This is a bit confusing concept, but I'll try to make sure that I simplify it for you. What are roles? Okay, what exactly the roles are? See, basically the purpose of roles is simple. So I'll just try to make sure that I can simplify it to understand. See, IAM roles have two main features or two main benefits. What are those benefits? The first benefit is that it allows resource to resource interaction. I'll give you a few examples to justify this functionality. Resource to resource interaction. The practical side of it, we're going to see some other time because it will confuse you. Well, I'll show you right now, but let's understand the concept first. The very first feature, the benefit of IAM role is that it allows resource to resource interaction. And the second benefit of this feature is that it allows something called cross account access. Now this is the advanced feature which we don't discuss in this curriculum, but I'll give you the concept of it. Not show you the practical side of it, but I'll show you the conceptual understanding of it. Cross account access. What is this? What exactly these two things are all about? I'll give you a few examples to help you better understand these two different benefits. For example, let's take the very first example. Let's imagine we have the EC2 instance. An EC2 instance is nothing but it's a virtual machine. What's that? It is a virtual machine, right? An EC2 instance is nothing but it's a virtual machine. Now, what you do is that you deploy your web applications, your database applications, your scripts, your programs, your programming language runtime, all the things you run upon the virtual machine only. For example, upon this instance, you have deployed a WordPress site. Now, your internet users, they browse this website. You have a bunch. So you have a very popular WordPress blog, and the internet users, they access your WordPress site. So they send the HTTP request to your instance and browse your website. Okay. Now what these users do is that they put their photographs, their images to the instance. They put the images to this instance. Like for example, you upload your images to Instagram, to Facebook, right? The same kind of stuff. The users upload their images. Now, this instance automatically needs to store these images or put these images to one of the S3 buckets at the backend. This is the S3 bucket. Now, generally what happens is that this type of interaction between the instance and the S3 bucket is not allowed. Or I would say it doesn't happen by itself. An instance cannot communicate with S3 bucket automatically and put the images into it. For this, you have to create an IAM role, attach a policy to it. For example, the policy is Amazon S3 full access. Fine. And link this role with instance. Now, if you attach this role with instance can put or get the images out of the bucket. So this is resource to resource interaction. One resource is able to communicate with another component in the same account or in the same environment. Maybe this S3 bucket needs to communicate with another S3 bucket to duplicate the data. There is a secondary bucket, okay, and this data needs to be backed up, and you need to create a backup of your data in the secondary bucket. You need to create the backup of so you need to sync the data in a secondary bucket. Even in this case, this bucket needs an I with a policy attached to it. Any policy, for example, S3 full access or whatever the policy would be, maybe your application access. So the policy needs to be linked with the role. You understand the point? Over here, two buckets are communicating with each other. The first bucket is pushing or backing up the data to the secondary bucket. Resource to resource interaction is only facilitated using the concept of roles. Okay, what is a policy? A policy is nothing but it's a JSON document which defines the permissions of all the three entities. What are they? What are these three entities? Users, IAM users, IAM groups, and IAM roles. Policy is nothing but it's a JSON document that defines the permissions of all the three entities. Even for the role to function, a policy needs to be attached to it. So for resource to resource interaction, a role is created. You link a policy to it which defines the permissions, and that role is linked with that resource. Fine. Why? See, basically, you have to see the scenario. Why you're going to be assigning the role to the user. The second scenario that I'm talking about is called the cross-account access. Roles can be assigned to the user as well, but in very special cases. That special case is, for example, cross-account access. Try to get the concept of it. Let's imagine there's a company named as SpaceX who has this company which has two root accounts. Company can have multiple root accounts. For example, this root account belongs to production environment. This is for prod. There's another root account for the dev account, development account. Fine. Two root accounts that this company has. One is for the production, another one is for the dev development. Now, the companies sometimes they keep the environments separate. Let's imagine that under the prod account, there's a bucket. There's an Amazon S3 bucket, right? There's an Amazon S3 bucket. Fine. Now, under the dev account, I have an IAM user. His name is, for example, Steve. Fine. Now, this user on temporary basis, for example, he needs to push the code to update my applications in the prod environment into the S3 bucket. Now, from AWS perspective, this is cross-account access. This is happening across two accounts. Fine. So basically, this cannot be achieved automatically. So remember, even though the two root accounts, they fall under the same business, but from AWS perspective, this is happening across accounts from dev to prod. Now to enable this feature under the prod account, I have to create an IAM role, fine, with a policy attached to it, fine. And this user will be using this role to get access to the bucket. This user will be using this role. He'll be issue a command switch role from his end, okay, and he'll be able to access the bucket in a different account, in a product account, and push the code to it. So basically, this concept is called cross account access, where one user from a different account, even though it belongs to a same business, but he's an IAM user of a different account. He wants to get temporary access to your resources. You need to create a role inside your environment in your own account, and that role would be used by that external user to get access to your resources. If you just go to the IAM user, let me show you that. This is the IAM user account. If you go over there, if you click on the IAM user account details, you can see that there's something called switch role. This is my IAM account. Just underneath it says switch role at the top right hand corner. If you click on switch role, then I can click on switch role one more time, define the account ID of the other root account, the name of the role, and click on switch role. Based on the policies assigned, the user can get the temporary access to your account, to the resources of your account. This feature is called cross account access, right? So in the cross account access, there are two root accounts under the same company. One is prod, another is dev. The user under the dev account wants to get a temporary access to bucket to push the code on frequently basis, on daily basis, or maybe weekly basis. So you create a role inside your prod account, attach a policy, and the user can use that role to get the temporary access to bucket from his end. This is about the roles. Now the thing is, as we proceed further, we'll see that how we can use roles for resource interaction. Under account settings, you can see that you can enforce upon some password policies. You click on change password policy and you can enforce, for example, the password length. For example, sometimes whenever you change the password of Facebook or maybe your business applications, you're being prompted, for example, the password should be 8 characters long. It should have at least one uppercase, at least one lowercase, at least one number, at least one non-alphanumeric character. You can enforce a password expiration after 90 days. So as a admin, as a root account owner, you can enforce a password policy so that when the IAM users get to change their passwords, they need to choose a complex password for themselves. This comes under the account settings. Having said that, this completes the IAM. Okay. Now, Elastic Compute Cloud or the EC2 is one of the most basic services of AWS, but the most important because the applications, the databases, the services that you're going to be launching upon would be deployed upon which component? A virtual machine. Now, what's a virtual machine in AWS? It's an EC2 instance. Okay. Now, to deploy this EC2 instance, we need to look into a lot of configuration parameters. We need to check out exactly that how to deploy an instance, how to connect to it, what are the different configuration parameters. So we're going to be discussing all those things in detail. But let's get started with the very first slide, that is the EC2. Introduction to EC2, the definition. What is EC2? First thing first, the full form of EC2 is Elastic Compute Cloud, right? It's a level at which a system is able to adapt to a workload changes by provisioning and deprovisioning resources such that the resources meet the current demand as closely as possible. So the purpose of Elastic Compute Cloud is, or what do you mean by Elastic? First thing first, Elastic means that anything that can increase in size or decrease in size, grow or shrink. I would say you can change its number of resources or decrease the number of resources. You have the bandwidth or you have the privilege to increase the number of resources or decrease the number of resources on demand. Okay. For example, today I need 100 virtual machines. I get it. Tomorrow I get 1,000. I need 1,000 virtual machines. I get 1,000. The day after, I need to switch back to 100 virtual machines. Right. So you can grow or shrink, or you can increase or decrease the number of virtual machines on the fly. Okay. So Elastic means that it's a system which can adapt to the workload requirements by increasing or decreasing the number of resources based on your business requirement or the demand. Fine. For example, let's imagine if you see on the slide right now, we have a bunch of users who are trying to access your web application through an EC2 instance. Okay, let's understand what's an EC2 instance. Even though it's a very basic thing, let's try to get to know the basic stuff. What's an EC2 instance? What's the relevance of it, and how it operates? So the service that we're going to discuss right now, it's called the EC2, which stands for Elastic Compute Cloud. Let's try to understand this. Now, we'll discuss different topics under Elastic Compute Cloud. That's called let's, for example, security groups, EBS, EFS, fine, CloudWatch monitoring, basic stuff, the types of virtual machines that you can deploy. It's called instance types, the AMI. So we discuss all those different parameters. So let's imagine that this cloud that you can see right now, this basic cloud, it's nothing but it is the AWS cloud that you have. Now you have a small virtual machine running. Now, as we know, a virtual machine is a small machine which is running on a physical server. We discussed the concept of this virtualization, right? And if you discover the concept of virtualization, on the same physical server, we have different virtual machines running. Each of these virtual machines it will support a different operating system. It may support a different operating system, and basically at the back end, of course, you can't see that because it's running in AWS data centers, but they use Xen hypervisor. It's XEN, Xen hypervisor. Install that upon their physical servers and install the virtual machines upon them. Each of these virtual machines may have different OS, applications, and services running upon them. Now, what exactly we are trying to achieve in this case or trying to understand is that in terms of AWS, in context of AWS, any virtual machine that you deploy in the premises of AWS, any virtual machine or VM, it's labeled as an EC2 instance, right? It's labeled as an EC2 instance. It's called an EC2 instance. If you deploy a virtual machine in AWS, it's called an EC2 instance, right? Now, an EC2 instance, which is a virtual machine in AWS, has some compute capacity. What do you mean by compute capacity? For example, if you're using laptop, desktop, any physical machine, a smartphone, smart devices, anything that needs to process some data or anything that needs some compute capacity will have some amount of RAM, CPU, and storage, right? So this instance will offer me something called some compute capacity, resizable some compute capacity, which means that you can change it if you want. Resizable compute capacity. Resizable means that it can be increased or decreased. Okay. Now this compute capacity, what do you mean by this compute capacity? This means that I'm talking about the RAM. What's the amount of RAM you want to allocate or to get from that specific virtual machine? What's the amount of CPU? Now in AWS we call it as virtual CPU. Okay, fine. And also storage. Generally, storage is determined by EBS volumes. We're going to discuss that afterwards. It's a kind of a virtual hard disk link with the instance. But what I want to emphasize in this case is that, over here is, that a virtual machine that you deploy in the confinement of Amazon's cloud is called an EC2 instance, which has some resizable compute capacity like RAM, CPU, storage, etc. Fine. Now, in terms of the compute capacity, especially in terms of the compute capacity, this is determined by a concept or a component that's called instance type. Fine. What's instance type? It's a virtual representation of underlying physical resources, of underlying compute resources, of underlying physical resources. If I talk about physical resources, I'm talking about the compute resources only, right? What do you mean by physical resources in this case? Is the same thing that we discuss about, the compute capacity. What's the amount of compute capacity that an instance offers to you? Okay, because based on your business needs and requirements, the types of workloads that you'll be running upon the instances, you need to determine that what's the amount of CPU and RAM you need. Okay, I'm giving you a very common example, a very day-to-day example. For example, I'm fond of playing games on computers, right? So in this case, I look for the computer or a laptop which will give me higher graphical processing units or GPUs. In context of business, if you're running some graphic intensive applications or for video games, you need servers with more GPUs. If I'm as an end user want to play the video games, I need to have a very high number of GPUs or dedicated graphical card, which is linked with the computer. I need to run a lot of applications at the same time. For example, Zoom itself, it consumes a lot of CPU, right? At least 4 gig of RAM is needed for Zoom to run. So based on the type of workloads, type of applications, business applications, day-to-day common applications that I run on my smartphone, my smart devices, my computers, my laptops, I will pick the exact physical configuration of my device. It's the same with the business use case. Based on the types of workloads, the business applications that you're going to be running upon these instances, you carefully choose that which instance type is the best for you. Okay. For example, there is something called, I'll let you know what exactly that's all about. There's an example which we'll use right now. That's the instance type that you commonly use is T2.micro. Okay. Now T2.micro gives you 1 gig of RAM in general, and it gives you, I think, one virtual CPUs or two virtual CPU, one virtual CPU or one virtual core. It's talking about the physical core or number of compute units. So this is what exactly it offers to you. One virtual CPU, two virtual CPU, very decent specs. Fine. Let's just give it a second over here. So this is exactly the instance type is all about. That you need to ensure that every instance type that you choose, it suits your business requirement. Okay. So how the physical attributes of the instance are determined? How the physical attributes of the instance are determined by the instance type. Right? Like you go to a store, you want to buy a laptop. with 32 gig of RAM, 1 terabyte of SSD storage, and maybe M1 Pro architecture or Intel i9 architecture. So basically, the thing is that based on your requirement, you choose instance type, which determines the RAM and the CPU that it gives to you, the processing that it can do. So that's about the stuff. So I think T-Road Micro gives you 2.5 gigahertz of Intel Xeon processor. Fine. Okay, so that's about the stuff. This is about the hardware specs of the instance. Now, what about the software specs? What do you mean by software? If I'm talking about the software specifications, the main thing that I'm talking about is the operating system. See, no machine can operate without an OS. Fine. So the main thing that you need is the OS, the operating system. Whether it is Linux, whether it's Windows, whether it is Mac OS, right? Linux, Windows, or Mac OS, you need to have an OS installed upon your virtual server or physical server. That's needed. Now, upon the OS, what you're going to be installing? Your business applications, your services, scripts, software, etc. So once you install the OS upon it, you're going to be installing all the applications, services, scripts, software, etc., programming, language runtime, anything. Fine. Now, these two things are bundled together and they become the part of something called Amazon Machine Image or AMI. Okay, so these are bundled together in the form of Amazon Machine Image or AMI. Fine. Now, so what's an Amazon Machine Image? It's a template which consists of the operating system, the scripts, software, applications that are going to be running upon the instances. Who determines the hardware specs? Instance type. Who determines the software specs? The AMI. What's right? For which thing we're talking about? Virtual machine. So in context of AWS, a virtual machine is nothing but it's it's labeled as an EC2 instance. Fine. So I guess this basic concept is clear to you. What is exactly an EC2 is? What exactly the purpose of it? And why exactly do we need it? So that's what the basic concept is all about. Fine. Now let's imagine that today you have a bunch of users who are trying to access your web application deployed upon the EC2 instance. Okay. For example, okay, let me give you one example over here. In terms of AMI, let me just give you one example. Let's imagine that you want to, upon instance, you want to run Ubuntu 20.04, right? Plus, you want to install upon it the Apache PHP web application, web server, plus MySQL database, plus a WordPress site. This will be bundled together in the form of a template which is called the AMI. Fine. Okay. This is about the stuff. Ravi Kiran is asking what specify hardware? Instance type. Instance type specify hardware. Beneath the answer is no. You don't need to remember the sizes of the instances. There's no need for that. See, regarding the increasing of storage, CPU, and RAM, basically based on how you architect your application, you can allocate more resources to your servers. So based on the geographical expansion or you can allocate different amount of resources for different physical locations. So you can do that. Does AMI also contain instance type? No. Instance type is a different thing, Garage, and AMI is a different thing. AMI does not consist of instance type. Instance type is different, AMI is different. Fine. So that's about the stuff. Okay, let's discuss the other thing. Today, for example, you have a bunch of users who are trying to access your instance through the web application deployed upon it. Maybe you have deployed a WordPress site upon it. Now, the next day you see the increase in the number of users, right? So you have double the amount of users. So based on business requirements, the backend databases or the front-end instances can easily the number of them can be increased. The number of these resources can be increased on the fly. This is called elasticity. Now, the next day, the number of users decrease, then you decrease the number of servers at the backend. So this is the elasticity. You grow or shrink your architecture based on the patterns of the incoming traffic, time of day, and the demand. So when there was a normal demand, you just need one server or database. When there was a high demand, you needed 3. When the demand shrinked, you decrease the number of servers now. For example, you might have seen that during whenever you try to access an e-commerce platform during Christmas sale, during any sale period like Black Friday sale, Thanksgiving Day sale, New Year sale, the amount of users who are trying to access the websites, they grow exponentially at a very fast rate, right? The number of users who want to access the e-commerce platform, the website to make some purchases, they grow to millions every day. To handle that much of traffic, these e-commerce giants like Amazon, Alibaba, Flipkart, Myntra, they use this strategy, right? For example, generally Flipkart or Amazon or any e-commerce platform, they just need one or two servers or maybe 10 servers to process the user's requirements. But during big promotions like Big Billion Day, Christmas sale, New Year sale, Black Friday sale, they see that there's a huge amount of users coming in.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
The traffic volume increases exponentially. So in this case, automatically the servers can increase in size, increase in numbers, not size, in numbers. Fine. In numbers, they will increase automatically. But as after the sale period is over, that sale period is over now, you're back to the normal. You can shrink it back to the normal state. Maybe one server or two servers, because now there's no huge requirement. So this type of concept is called elasticity, where you can increase or decrease the number of resources automatically or manually based upon that how you have set it to take care of your business requirements, demand, traffic demands, and maybe based on the time of day. For example, in morning hours, I need 10 virtual machines, but during offline hours, out of business hours, in night, I just need 2 virtual machines. So based on the requirement, time of day, and the demand, I can increase or decrease the number of instances automatically or manually. Fine. Regions and availability source we have already discussed. Okay. So let's come back to the same topic that we have discussed: EC2 instance types. The EC2 instance type determines the hardware of the underlying host computer on which the EC2 instance are launched. Basically, the number of RAM, the amount of RAM, compute units, and the storage allocated to your instance is determined by the instance type. Right? There are different families of the instance types like general purpose, memory optimized, storage optimized, accelerated computing, compute optimized. So based on your business requirements, you will see that each of these instance types will offer you different types of amount of RAM and CPUs. Okay, let me just show you one thing. For example, you don't have to do it by yourself. Just try to understand exactly that what I'm trying to convey. So let's imagine if you today just try to launch an instance right now. The very first thing, okay, so I go back one more time and show you. So I go to the service called EC2. It's a separate service. You can search it via the search menu, or it's there. So I just go to the EC2 right now, and under EC2, I just go ahead and just try to launch an instance. So I click on launch instance, right? The very first prompt, the very first option that I need to choose from is that I need to select the Amazon machine image or the AMI. Okay, you can see what's an AMI. It is a template that consists of the software configuration, operating system, the most important component, software component to run your server or any machine, application server and applications. They're bundled together in the form of an AMI package, which are needed to launch your instance. If you don't have the AMI, you can't launch an instance. You need an operating system. Now you can see that there's a list of AMIs to choose from. Okay, these are the AMIs that you can test and try. The one that are labeled as free tier eligible, they're free of cost. You don't have to pay for their usage. So if it's labeled as free tier eligible, this means that there's no cost involved in trying them out. You can easily try and test these AMIs even in a business environment. Fine. Now these are called quick start AMIs. You can see there are different categories of AMIs. I'll elaborate on those one by one. So quick start generally are the AMIs that you can generally use for testing purpose, for development purpose, for hands-on purpose. Now we're going to be using these quick start AMIs a lot because we are doing hands-on. Most of these AMIs or the Amazon machine images are free of cost. So we're going to be using this category of AMIs the most. Fine. My AMIs is where your business will have its own repository of its own custom built images. Right? See, every business based on has a special need, a special requirement. Right? Your business, your company will run different type of application services. Another company will run different types of application and services. So basically, every company will have its own custom built images stored in this space, so that whenever they have to launch instances, they can just go to my AMIs. As if I'm not showing in my list, but later on we'll discuss that how a business, a company, an organization can create a complete repository of its own custom built AMIs. So there's an exercise that we'll do collectively, where we're going to discuss that how to create the AMIs based on our business needs. Okay. Marketplace is the AMIs that you can buy from different software vendors like Microsoft, SAP, Zend, Cisco, Juniper, OpenVPN, Splunk. Right? Most of these AMIs are paid. You have to pay for them. So these are the AMIs that you can buy, and this thing comes under SaaS, software as a service. For example, I want to deploy Juniper VSRX next generation firewall in AWS. Fine. Now, what's the cost of it? If I go with on the hourly basis, I need to pay 55 cents per hour. Or I can just buy this software in the form of AMI by paying this amount, $2,280 each year for the software. So I'm buying the software from these vendors in the form of AMIs, right? So this is also a space that you're going to be using a lot in day-to-day business environment. Fine. Community AMIs is the one that generally it is like a GitHub repository. Now, where developers, they publish their code and they share it with the entire audience, with the public users. So it's a developer community where people just create their own AMIs and post it in this community. It's just purely used for testing purpose. I don't think that you're going to be using it. Okay. In a business environment, the one that you're going to be using the most is the My AMIs, where you're going to be using your own custom built images. Later, I'll show you that how you can create that one for you. And the marketplace where you purchase the AMIs from the trusted vendors like SAP, Zend, Microsoft, Oracle, and so on. Right. So what is an AMI? It's nothing but it's a software configuration which consists of the OS, application servers, software, programming language runtime, script software, everything installed. So the software part of the instance is being decided by which component? That is called the AMI or the Amazon Machine Image. Okay. Now let's suppose I pick Amazon Linux 2 AMI and I click on select. Fine. I've chosen the AMI. Now once I choose the AMI, the next thing that it presents on my screen is instance type. What's instance type? It's a virtual representation of the underlying physical resources. Now you can see that T2.micro, it's free tier eligible instance type, which means that if you use it, then there's no charge for it. It gives you one virtual CPU, 2.5 gigahertz of Intel Xeon processor with 1 gig of RAM or the memory. Okay. Now, as you scroll down, based on the different instance type, each instance type will give you a certain amount of RAM, a certain amount of CPU. For example, let's go with this one. M4.4x large. Now M4 means it will give you more memory, more RAM. It gives me 64 gigs of RAM and 16 virtual cores or virtual CPUs. So 64 gig of RAM, if I choose it, you can see that on the top, I think it will show me. So this will give me the same, so it will offer me 16 virtual CPUs, 64 gig of RAM, 2.54 gigahertz of Intel Xeon processor. So based on my business requirements and the needs, I see that what's the amount of virtual CPU this instance type offers, what's the amount of memory, the RAM it offers to me. I carefully choose the instance type. Now the good news is that just in case if you're confused, if you're deploying a new application, then this can be changed afterwards. This attribute can be changed with a little downtime. Okay, you have to stop the instance, stop the virtual machine, and you can change its instance type later on. Okay, so the hardware specifications is being decided upon by which component? Instance type. The software component, software configuration is decided by which component? AMI. Fine. So these are the two things that we have discussed. So each virtual CPU is a hyper-thread of an Intel Xeon core, except T2 or medium and premium services. Basically, each virtual CPU is a virtual core only. Fine. So the number of cores defines the number of virtual CPUs. Okay, fine. That's about the stuff. The next thing that I'm going to discuss with you in brief is called EBS or Elastic Block Store. What's that? See, the thing is, if you deploy any instance right now, so let's imagine that I have this EC2 instance launched. This is my EC2 instance. Fine. Now this EC2 instance needs some storage to store its program files, its documents. For that, we use a virtual hard disk that's called EBS volume. Okay, it's a kind of a virtual hard disk, right? For example, the size of this volume is 30 gigabyte a GB. Basically, the thing is that at a back end, the volume, the storage is linked with the instance. It's being attached, plus it is mounted. Mount means that it can be used by an instance. Fine. At the back end, the instance is linked with the EBS volume, which is storage for the instance. Now, for example, today you log into the instance and you may see that the volume appear to as a C drive, for example, a D drive, right? So you may assume wrongly that the volume and the instance are on the same physical machine, right? But the reality is completely opposite. This instance may run on a separate physical server, for example, HP, IBM, or a Dell physical box, and this is a part of a storage physical server or a storage server, for example, a storage infrastructure. So in this case, a storage servers, or let's suppose network attached storage, storage attached network, disk attached storage. So it comprises of your storage infrastructure. These different components are running on different hardware, right? Even though when you log into the instance, it may appear to you that the volume, the physical storage like C drive or D drive is a part on, it's running on the same physical server, but behind the scenes, it's running somewhere else on a different physical server. And these two different components are running in the same availability zone. Okay. Now your entire data of the instance, okay, plus your image files, your operating system files, if it's a root volume means it's a main volume, is stored upon the volume itself. Now, why AWS has come with this type of architecture? Why the virtual storage, the physical storage is kept separate from the instance? The reason being, what if this instance goes down for any reason? It crashes. Maybe the underlying physical server crashes for any reason. Okay. In this case, this stays unaffected. You can easily take this volume and link it with another EC2 instance and retrieve your data. Another EC2 instance in the same AZ. Fine. Now, what if the EBS volume goes down? You can also back up the EBS volume using the concept called snapshot. That we'll discuss afterwards. But basically, in terms of each instance, we keep the volume separate physically so that if the instance goes down, then the volume can be linked with another instance in the same availability zone. Fine. And also, the EBS volume can be backed up. You can back up the EBS volume in the form of snapshot to save your data further. We'll discuss these concepts in detail afterwards, but right now I'm just giving you a very basic overview. EBS stands for Elastic Block Store. Elastic Block Store, okay? And EBS volume is linked with instance, which is kind of a virtual hard disk for the instance. It stays in the same availability zone. It ensures that so AWS ensures that it's kept separate physically, so that the instance goes down, it crashes, or the underlying physical server crashes, your data is safe. It's not affected. You can take that volume and link it with any other instance in the same availability zone. Also, the EBS volume can be backed up in the form of snapshot to further safeguard your data. Fine. So this is about the basic concept of EBS. EBS we'll discuss in a lot detail. It's just a basic conceptual understanding that I'm giving you right now. Fine. Because when we deploy the instance, EBS is needed. Fine. Okay. That's about the stuff. Now, the next concept that I'll discuss with you is called the security group. Now, I need to create a base first, the foundation first, because if I don't give you the basic principles, then even if you do the hands-on, then you'll not be able to understand exactly that what we are doing. So I'm just creating some basics or giving you some basic idea about some stuff. The next important thing that we'll discuss is called the security group. Okay, very important. It is one of the main security features that we will discuss right now. See, security is a big concern for any organization, especially if you're moving towards cloud. Today, a business says, okay, we want to just scratch off the entire infrastructure that we own, and we need to migrate to a cloud infrastructure. Maybe it's AWS, maybe it's Microsoft, maybe it's Google. Now, the problem is that security is a concern for most of the organizations, I would say every organization. They need to ensure that no outsider can access our servers, that there should be no unauthorized access. To stop it, to limit it, we make use of the concept called security group. Okay, what's that? Let's try to understand that. So a security group is a virtual firewall. It's a virtual firewall, right? It's a virtual firewall that it restricts incoming and outgoing traffic, right? With respect to instances. EC2 instances, yeah, I just typed down instances only because basically it will restrict the incoming and outgoing traffic with respect to the instances. It's a virtual firewall which will enforce restrictions that who can access your instance by sending the incoming traffic. So what do you mean by incoming and outgoing traffic? For example, if this is an AWS cloud, right? Now, and this is an EC2 instance. The traffic that hits the instance from outside, from the instance perspective, what's that? That's incoming. Right? The traffic that leaves the instance and goes outside from the instance perspective, what's that? That's outgoing. Fine. To restrict the incoming and outgoing traffic with respect to instances, we allocate security group. Now, to restrict this traffic, we use three filters. What are those filters? One is the source or destination IP addresses. The second one is protocols. For example, HTTP, RDP, SSH, HTTPS. Fine. And then we have port numbers. For example, HTTP uses port 80, RDP uses port 3389, SSH uses port number 22, HTTPS uses port number 443. Okay. So basically, these are the three filters we use to restrict the incoming and outgoing traffic with respect to the instances. We perform the restriction of the we perform the restriction. We enforce restriction in terms of incoming and outgoing traffic by using these three filters. Why I use source? So if the traffic is incoming towards the instance, then of course we'll filter it using the source IP, from which source the source IP the traffic is coming from. And if the instance is sending the traffic out, then I'll filter it based on the destination IP. So I'm sending it to a destination. Fine. So source or destination IP addresses, protocols. We use different protocols to access our servers, like HTTP. If you want to access a website, use HTTP, HTTPS. We use different ports for them at the back end, the networking ports. For example, HTTP uses port number 80. These are three filters that you're going to be using to enforce restriction that what type of traffic can hit your instance or leave your instance. Okay, what type of traffic can hit your instance or leave your instance. Now, see, let's imagine the 2-3 different scenarios that we'll discuss. Let's assume that this is our AWS cloud. Fine. And upon this instance, this is an EC2 instance that we have, right? Now, upon this instance, I've deployed a Drupal web application or web app or website, right? Now, this website needs to be accessed or browsed by the internet users, like you access Facebook, google.com, Intellipaat.com. So these are the internet users, and these internet users need to access your website. The website is running where? Upon the instance. Now these users will send this traffic. These two type of traffic they can send. For example, they can send HTTP traffic, which uses port 80. Okay, or they can send HTTPS traffic if you have a secure website, which uses port 443. These are static industry standard ports. Fine. So through this we are defining two things over here. What are the two things we're defining? Protocol, which is HTTP, and port. Protocols and ports. Fine. What about the source IP address? Because the traffic is coming from the internet. For the internet traffic, we'll be using this IP address 0.0.0.0/0. This means any IP, or this allows the open internet access. So I'm saying anyone on the internet can browse my website. Today you go to www.intellipaat.com. Anyone can browse this website. You go to facebook.com, google.com, instagram.com, whichever website you access. Basically, at the back end, the administrator has opened the HTTP or HTTPS port from anywhere, so that anyone can browse the website running upon the servers. It's open access. There's no restriction. Fine. This is about the first scenario. Let's discuss the second scenario. The second scenario is that the same instance needs to be accessed. The same instance needs to be accessed. So let's imagine this is a Linux instance. Now this needs to be accessed from your data center. This is your on-premises network, or this is your data center, right? Now you need to access your instance from your data center to perform server management. You need to perform server management. What do you mean by server management? Installing the patches, installing the updates, installing the applications, configuring them, and so on, right? Now the server management is being done by the people that's there in your office, in your branch office, in your corporate office, in your data center. Now, because this is a Linux instance, the SSH traffic needs to be sent. SSH stands for Secure Shell. It uses port number 22, Secure Shell. This is used for Linux servers. Okay, so the administrator from your data center needs to access the Linux server or the Linux system instance to perform the server management. But what about the IP address? Now, your company's network has a specific IP address block assigned to it. For example, 123.78.0.0/20. It's a complete block of, I think, somewhere around 4,096 IP addresses or IPs, somewhere around these many IPs. So I'm saying any machine in my any machine with the IP address. For example, I have a computer in my data center which is managed by my administrator, and its IP address is 123.78.1.1. Okay, because this is falling under that 4096 IPs. Any machine with that IP, anyone can access my Linux or get access to the server or the Linux shell from my data center. So I'm saying I want to allow the SSH from this complete range of IP addresses. So are these two scenarios clear? The HTTP, for example, right now you're running, if you try to access www.intellipaat.com or lms.intellipaat.com, you can access the website, but can you access the server at the backend that's running that website? No. Who's managing the server? The administrators, the server administrators. So they have the SSH access so that they can manage the servers at the backend. We as a front users, we can only see the website. Now, because server management means that installation of the patches, maintenance, upgradation, configuration, that comes under server management. Fine. These are the two scenarios that I want to discuss with you. Now, what if this was a Windows server? Okay, for Windows we use the protocol RDP, that stands for Remote Desktop Protocol. It uses port number 3389. Okay, so for the server management of Windows Server, you use RDP protocol and the port is 3389. Right now, as a thumb rule, the SSH and RDP protocols, because they give the server access, the core access, RDP should only be allowed from known IPs. Okay, you need to make sure that these different protocols should be allowed from known IPs, not from every IP. Okay, because you're giving the server access. Got the point? That's what exactly how you need to filter the stuff. Now, what about outgoing? For example, this instance needs to send back the HTTP response back to the user. I would say HTTP is sent back to the user response. Fine. Or in this case, I would say the instance will send all traffic back to the data center, any type of traffic. So both the incoming and outgoing traffic is restricted based on the concept of security group. Okay, if I want to just break it down in a very simple thing, you ensure that you restrict the incoming and outgoing traffic based on the IP addresses, ports, and protocols. Now, if I just go ahead and show you the configuration, it says create a new security group. So, okay, let me do one thing. Let me just create the security group over here. On the left hand side, we have the security groups page. This one, security groups. Let's go over there. Now, in the security groups, what we can do is it says create security group. Now, you can see that a security group acts as a virtual firewall, for instance, to control inbound and outbound traffic. To control the inbound and outbound traffic. For example, I name it as my Linux web server security group. I assign a name to it. Then it says, can you assign a description? This is just for documentation purpose. It will allow SSH access for my developers and HTTP access for internet users. VPC will not change. VPC is a concept where we create the entire config in a cloud. We'll just keep it as it is. In the inbound, I will add a rule saying this if I just go to the inbound, that it will show in the type, it will show me the list of protocols that I can allow in. Right? This is a list of protocols. You don't have to remember the list. For example, I choose for HTTP because based on the scenario, my users will be sending the HTTP traffic inbound to their Linux instance. So I'm saying HTTP inbound from which source? From, it says anywhere IPv4, anywhere IPv6. So you can choose anything. So for example, I choose anywhere IPv4 0.0.0.0/0. So I'm saying HTTP or HTTP access from the internet users. Okay, what about inbound? Other rule, I would say SSH. SSH stands for secure shell. It uses static port 22. I would say I want to choose a custom source. If I choose my IP, it will automatically pick the IP address of my computer right now, the one that I'm working on. Okay, or else I can say, for example, 103.211.15. So I can choose this IP address, custom IP .0.0/24. This is my data center IP block. So I'm saying that any IP following at this IP address block can get the server access. So SSH access from my data center IP block for server management. Fine. This is about the inbound. What about outbound? Outbound, we can also choose the protocols, but I'm saying outbound, the server can send back any traffic. So open outbound access. Basically, we are more concerned about the inbound, not about the outbound. We can restrict outbound as well, but we are more concerned about the inbound, that who is reaching our instance or server from outside. If you choose all traffic, then it will send any type of traffic of any protocol to any port outbound. But if you want to perform restriction, you can do that. Okay, you can add a tag. Tag is nothing but a key value pair. It's of no use, but let's suppose I name it as, for example, the same thing, my Linux web server security group. Fine. This is how you create the security group to restrict the incoming and the outgoing traffic. And click on create. Okay, this is what the concept is all about. Basically, to enhance the security of your resources and your applications, this is one of the most important things that you have to do. Fine. Okay, so let's discuss next concept. The next concept is tenancy. Okay, what's exactly that's all about, and why exactly we need that? What do you mean by tenancy? What's the purpose of it? So what do you mean by tenancy options? See, basically, it determines that how the instance has occupied the underlying physical server. There are two types of tenancy options that we have. One tenancy option is called shared. What do you mean by shared? It's the same concept. We have a physical server, the same physical server. It is HP, IBM, or it's a Dell physical server. We have installed upon it a hypervisor, right? The same concept of virtualization that we discussed, right? And just copy it and paste it over here. Now, what happens in the shared tenancy is that the instances that you launch upon them, the instances that you have, the virtual machines that you launch upon this physical machine will belong to separate customers. For example, this virtual machine belongs to AIG. This belongs to JP Morgan. This belongs to Accenture. Now, AWS creates a barrier. They provide something called instance isolation for the security reasons. They ensure that the instances are isolated. They ensure that the instances The instances are isolated. They don't interact with each other. They're kept separate. This concept is called shared tenancy. This tenancy option is free of cost. I'm not talking about the instance. I'm talking about the tenancy option. It's free of cost. Fine. Now, sometimes you might be working in a financial institution or a banking organization. In this case, your requirement is, for example, if I want to go with dedicated, in this case, what happens in dedicated is, in dedicated tenancy, this is not free. This is a paid version. I will have the instances running belonging to single customer, right? Basically, you dedicate the entire physical server to you.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Now, of course, instance isolation is also there, but because you own the entire physical server, you can manage it by itself. Basically, if your company has very strict security and compliance requirements, for example, you're working for a bank, they may not allow you to launch the databases or the instances on the same physical server, okay? Or maybe there's a software requirement, software compatibility. I give you the best examples over here. The best example is Oracle enterprise database, which works on the concept of bring your own license, BYOL. It can be only deployed on a dedicated physical server. If you go with the Oracle Enterprise Database Edition and you want to deploy that on AWS by bringing your own license, it can be only deployed on a dedicated physical server. This concept is called BYOL, or bring your own license. You want to bring the Oracle Enterprise Database to be deployed upon AWS. It can be only deployed on a dedicated physical server. Or you're working for a banking organization, for a financial institution. It's a strict compliance requirements that you have to have the instances deployed on a dedicated physical host. You should own the entire physical host. Fine. So all the instances would belong to a single customer. Basically, you own the complete physical server. You own it. Fine. Now this is a paid version of tenancy. This is a paid version of tenancy. Fine. I think this concept is clear. The next option that I'm going to discuss with you is called the CloudWatch and EC2. So basically, the next thing that we're going to discuss is called CloudWatch and EC2. Now, CloudWatch, of course, we'll discuss in detail right now, but because the instance performance is monitored by the CloudWatch, we'll discuss this thing in brief, not in detail, but in brief. See, CloudWatch is nothing but it's a default monitoring tool. It gauges the performance of instance. See, there should be some live monitoring of to better understand that how your instance is performing. Now, let's imagine this is my instance. Let me draw upon an instance right now. Okay, this is my instance. Now, this instance needs to be gauged upon its performance in real time. Now, whenever you want to gauge upon the instance performance or any performance of any resource using CloudWatch, we use a term called metrics or metric. Metric are the parameters against which you gauge a resource performance. I give you a very layman example. I want to gauge upon the performance of a marathon runner. Right? A marathon runner, I want to determine that how he has performed. What are the two metrics I will see? Distance covered and time taken. Distance covered and time taken are the two metrics I'll take into my fact, into my knowledge, before saying that, okay, this is how this marathon runner has performed. Or a weightlifter, this is how much weight he has lifted, this is how many reps he has done. Right? Reps and the amount of weight that was put on, I'll take these two different metrics as the things to analyze the weightlifter's performance. Similarly, to gauge any resource performance, metrics are needed. Without metrics, you cannot gauge the performance. What are some of the examples? For example, CPU utilization. How much CPU is being utilized by the instance? Maybe disk, maybe number of packets coming in, network in bytes. What's the amount of traffic coming in? What's the amount of traffic going out, network out in bytes? Okay, you don't have to learn these things as of now. It's just for the sake of understanding, because as we progress further, you'll automatically remember these things, but this is just for to hone your understanding. Fine. So these are some of the metrics that I take into account before deciding that how an instance is performing right now. We have an external resource that's called CloudWatch, whose responsibility is it's a separate service which does not run on on instance. It's a separate service. This CloudWatch as a service will contact the instance. It will perform the health check. It will perform health check by default every 5 minutes. This is a default parameter, a default timer. Every 5 minutes, the CloudWatch will ping the instance, perform the health check. You can easily log into the CloudWatch dashboard because, for example, you are a server administrator, you're a server admin. You log in to the CloudWatch and you can easily see the exact statistics. For example, right now at 11 a.m. UTC, the CPU utilization of the instance is close to 70%. At 11:05, it will refresh and give you the exact statistics. Every 5 minutes by default, the CloudWatch will ping the instance and get the values out of it. It will see the CPU utilization of the instance and the exact value out of it. Fine. Now this 5 minute frequency is called standard or default monitoring. Standard monitoring, which is free of cost. You don't have to pay for this monitoring option. It's called standard monitoring. But if you change the frequency to 1 minute, which means that every 1 minute the CloudWatch will ping the instance, it's called detailed monitoring, which is a paid version. Basically, you're increasing the amount of traffic because every 1 minute the CloudWatch will ping the instance, it will give you the fresh statistics. Every 1 minute the CloudWatch has to contact the instance and give you the fresh statistics. It increases the bandwidth consumption between the CloudWatch and the instance. So in this case, you have to pay for it. This is used for mission critical applications. If you have some very business critical applications which need to be monitored every 1 minute, then of course you can go for that. But you have to pay extra amount for this type of detailed monitoring. Fine. Let's get started with the next stuff. The next stuff that we're going to discuss is let me just log into the AWS page. I guess to this point, everyone has access to the account because I think previous week some people had some debit card or credit card issues. I think that's been fixed now. So now all of you have access to the account itself because it is extremely important that everyone should have access to the account. Otherwise, you'll not be able to perform the hands-on, right? So because as we proceed further, we'll do more and more hands-on. We'll do a lot of real-time implementations, see that how the things are being deployed and implemented in a business environment. So it is extremely important that each one of you should have access to a free account. Okay, because to practice, this is the only thing that we need to do. We will use root or IAM user for hands-on today. IAM user is there for the explanation. Fine. So you're going to be using a free tier account. If I say free tier account, that's a root account only. Okay, so guys, let's go to the easy right now and let's see. So the very first thing that I shall be discussing would be the types of IP addresses. Fine. What do you mean by types of IP addresses? See, whenever you deploy any resource and it needs to be part of a network, an IP address needs to be linked with it, right? If any machine, any server is deployed and needs to communicate with any machine or any other server on the local area network or maybe on the internet, it needs an IP address. If a machine doesn't get an IP, it cannot form an active part of a network. Your machine is carrying your computer or laptop is carrying an IP address. That's why you're able to join the Zoom call over the internet. So a machine needs to have an IP address so that it can form a part of a small network or local area network or a big network or a wide area network or internet. Okay. Having said that, I should discuss with you two concepts right now. One concept is the IP addresses and the other concept would be the VPC and the subnet. So let me just elaborate those points and then we'll start with the hands-on. Fine. Let's get started with the IP addresses. So any idea that how many IP addresses we use in the business environment or in the industry? What are the two main types of IP addresses we use? Yeah. Okay. I was referring towards public and private IP, right? Yeah. See, basically the thing is that to understand the types of IP addresses and the ranges, because once we proceed to the advanced concepts, we're going to be using these IP addresses to create the complete network. So let's understand the IP addresses in depth, right? I will sketch the different types of IP addresses, the scenarios that you're going to be using. See, the first type of IP address is called the private IP address. You need to have the private IP addresses for this purpose. Internal communication. Internal means local area network or on the same network. If I say this term internal communication, this simply means that the traffic is not leaving the internet. It is not using internet, or there's no internet used in this communication. Internal communication means that it's happening on the same network, in the same network. Okay, it's purely used for internal communication. For example, let's imagine this is AWS cloud, right? And this is your EC2 instance. Let's suppose I have two EC2 instances. This is the first one, and this is the second one, right? This is my instance A. This is my instance B, right? Now they are in the same network, in the same cloud. They have the IP addresses assigned to them, the private IPs. They can easily talk to each other in the same network because they have the private IP addresses assigned to them. Fine. So private IPs are needed so that the resources can communicate internally in the same network. Fine. It's not leaving the network, it's there in the same network. Fine. Now over here, there are some ranges that they fall into. What are those ranges? So ranges means that what types, how you represent them. So this range, for example, 10.x.x.x 172.16.x.x can go up to 172.31.x.x, and the other range is 192.168.x.x, fine, where x denotes any number between 0 to 255. Fine. So these are the ranges that the private IP addresses will fall into. If you see 10.172.16 to 172.31.192.168 IP addresses, these are the private IP address ranges. They denote the private IP address range. Okay, so this is about the private IP addresses that we are talking about, right? It's purely used for internal communication. Now, in terms of AWS, every instance gets a private IP upon launching. So every instance will get a private IP. Fine. And the thing is that they are static. Static means that they don't change, or there's no change in the private IP, no change during instance lifecycle, which means that you stop or restart the instance, they don't change. They remain static. For example, an instance gets a private IP of 10.0.1.1. You stop the instance, you start the instance, it never changes. It remains static. No change during the instance lifecycle, which means that you stop the instance, you restart the instance, they don't change, right? So every instance in AWS should get a private IP, which is static in nature, which never changes even if you stop and start the instance. Is this concept clear? So the private IPs are needed for the instance to communicate with an instance in the same AWS network, right? Now, the second type of IP address that you will be using is called the public IP, or the public IP addresses. What are these and what they're meant for? See, the concept of public IP addresses is quite simple. It is used for external communication. What do you mean by external communication? External communication simply means that it's happening over the internet or across another network. Basically, if you use public IPs, generally used for the internet only. Generally, they're used for internet or internet communication. For example, let's imagine I have this AWS cloud, right? This is my AWS cloud, and this is my EC2 instance, right? This has a private IP of, for example, 10.0.1.1, right? I can also assign it, I can also link it with the public IP. For example, the public IP is 13.16.72.88. Now, if this instance gets a public IP, okay, it can easily access, or it can be accessible from any user or any machine from the biggest public cloud, which is the internet. The users on the internet can easily communicate with that specific server, right? So basically, in this case, if I assign the public IP address to an instance, it can be accessible from the internet. It can communicate with the internet. It can send the two-way traffic towards it. Fine. Is this point clear? So the public IPs need to be assigned to the instance so that it can be publicly accessible, or it can be accessed via the internet two-way. It can send the traffic to the internet, or it can receive the traffic from the internet, right? Now, public IPs are purely optional. You don't need you don't. It's not mandatory that you need to assign the public IP to every instance. It's not mandatory. It's not mandatory that every instance should get a public IP. It's not that you need to have a public IP assigned to every instance. Fine. So they are optional. These are optional resources. So these are purely optional. Now, got the point? So it's not mandatory that every instance should get a public IP, and it is not mandatory. Now, these are the following ranges they fall into. What are the ranges they fall into? They fall in any range except, of course, private IP addresses. And there is something called loopback IP. Loopback IP is this IP, I'm sorry. So it's called, yeah, loopback IP is this one. 127.0.0.1. It's called loopback IP, which is used for troubleshooting and testing purpose. So in networking domain, we don't use these loopback IPs for the public network. It's used for troubleshooting and testing purpose. So your public IPs can fall in any of the ranges except the private IP address ranges or the loopback IPs. Fine. Now, in terms of the public IP addresses, they are not static. If I say not static, this means that they are dynamic in nature. What do you mean by that? They will change upon the instance restart. So they are dynamic in nature. What do you mean by dynamic? They are not static. This means that they are dynamic, which means that the public IP address of an instance will change upon instance restarting. If you stop and start the instance, it gets a new public IP. It will change upon instance restarting, right? So if you stop and start the instance, it will get a new public IP every time. Okay. So this means that the public IPs are not static in nature. They will change upon instance restarting. So they can change during the instance life cycle. So they can change during the instance life cycle. They are not static in nature. They are not static in nature. Now, this can be troublesome for you because public IPs are used for websites as well. Let's imagine today you want to reach a website. How do you do that? For example, this is the AWS cloud. This is the instance running in the confinement of your AWS cloud, right? Now, upon this instance, you have deployed a web application, a website, right? Now, how the users reach your website? Your instance has a public IP, right? So the internet users, what the internet users do, for example, these are my internet users. What these internet users ought to do is that they will type the domain xyz.com, for example, and it gets resolved to the public IP address. So at the back end, whenever you type in, for example, Intellipaat.com, Google.com, Facebook.com, they get converted to the public IP address of the servers that are hosting the websites. You got the point? That's how you're able to reach the websites. So xyz.com will point towards the domain will point towards the public IP address of the instance. Now let's imagine that you restart the instance. Once you restart the instance, then you need to manually link the xyz.com to the new public IP, which is a bit of a hassle because you have every time the instance restarts, it needs to be linked with a new public IP because once the instance gets restarted, it will get a new public IP, which is a bit of a hassle because in this case, every time the instance gets restarted, it needs to be linked with a new public IP. Right? Now, to avoid this type of hassle, we use a third category that's called elastic IP. What is the third category? The third category is called the elastic IP. What is elastic IP? Elastic IP addresses are same as public IPs. I'm not deep diving into details of elastic IPs as if now, but give you a brief overview. They have the same benefits, same properties of the public IPs, but they are static in nature, which means that if you restart the instance, they don't change. Right? This is elastic IP addresses. It is an AWS proprietary public IP. Okay, elastic IP is a public IP only, which is static in nature. It's offered by AWS, saying that okay, the instance restarts, the public IP address changes. Instead, use elastic IPs, the same as public IPs, but they are static in nature. Fine, they don't change upon the instance restart. Same properties of elastic IP, except this one. It is static in nature. Fine. We'll discuss more details of elastic IPs later on. But right now, I just want to discuss the basics so that you don't get confused at this stage. So 3 types of IP addresses we discussed. One is a private IP address, which is purely used for internal communication. The public IP, which is used for external communication towards the internet. But the public IPs has a downside. Public IPs have the downside, which means that they change upon instance restarting. To overcome this issue, we can make use of elastic IP addresses, which is same as public IPs, but they are static in nature. Fine. This is the concept of, these are the concepts of public IPs, elastic IPs, and the private IPs. Fine. Okay, that's about the stuff. The next basic concept I'll discuss with you is a VPC. So what's a VPC? See, let's understand this fact, and that in terms of whenever a company decides that they need to go to AWS, Microsoft Azure, or GCP, that's a Google Cloud Platform. Basically, we are trying to leverage a public cloud. Say AWS, Microsoft Azure, IBM Plumix, any cloud platform that you pick right now and start using it. It's a public cloud platform. It's a public cloud. Why it's called public cloud? Because anyone is welcomed. You, me, any organization without any background checks, we can just simply use a credit card or debit card, and we can start using the Amazon's network. Now, the biggest hurdle for the companies and the organizations is that they're going public and they feel unsecure because they might think that we're going on a public platform. Our data, our resources can be accessed by unauthorized people. So there is a threat to security of the resources and the infrastructure. So what AWS is, what these companies says, and this is whether you go with Microsoft Azure or AWS Cloud or Google Cloud, this is a very common theme. This common theme that we use over here is called the virtual private cloud. Virtual private cloud is nothing but it's a virtual data center that you deploy on a public cloud platform. It's called VPC in the short form. It's a kind of a virtual data center. Virtual data center means that you get the same benefits, the same flexibility, and the same security as you will get in your own in-house environment or your private network. So VPC is a virtual data center that you deploy on a public cloud platform. For example, let's imagine that this boundary, this line represents AWS public cloud. Now on this AWS public cloud, you can create multiple virtual private clouds or the virtual data centers. For example, this cloud, this virtual private cloud VPC belongs to Accenture. So every company will create its own virtual data center on the same public cloud platform and will reap the same benefits, will get the same benefits as if they are running their own data center. So every company, every organization can create its own VPCs or virtual private cloud so that they are able to isolate themselves from the other infrastructures, right? So this gives a kind of isolation. It provides isolation as enhanced security. So every customer will have its own VPC running on the same public cloud platform. They're running on the same platform, but they're able to create their own virtual data centers in the form of VPCs so that they're able to isolate themselves from the other infrastructures. Fine. This is about the VPC. VPC is a complete network. You create a complete virtual data center for yourself, and you're able to isolate yourself from other customers on the same platform. Fine. Now, in terms of VPC, basically what happens is that VPC is created. It is designed using private IPs. How? For example, let's suppose this is my VPC. This is my VPC. Fine. This VPC belongs to or it resides in Mumbai. So VPC is contained in a region. What is Mumbai? It's AP South 1. So if I talk about this VPC, I'm saying that it's AP South 1, that's Mumbai region. Fine. That VPC is located in that region. Now there's a complete a private IP address block, a private IP block assigned to it. For example, in this case, it is 10.0.0.0/16. Now, don't worry about /16. We'll discuss that in the VPC part. Let's imagine there's a complete IP address block assigned to the VPC. Now, in this VPC, I'll start creating the subnet. Subnet means that I'm further dissecting my VPC into multiple small networks. Fine. For example, so what are these? These are the subnets. These are further blocks of private IPs. Subnets are blocks of private IPs, right? For example, this subnet has range 10.0.1.0/24, and this has 10.0.2.0/24. Fine. Now you launch instances inside them. The instances are launched inside. For example, this is my instance launched in this subnet. Now this instance will get the private IP from the subnet range it falls into. For example, this instance will get the IP address of 10.0.1.1. Similarly, if I deploy an instance in this subnet, right, it will get its private IP from the range of the subnet it falls into. For example, this instance will get 10.0.2.2. So the instances get their private IPs from the range of the subnets they launch into. Fine. So I take a VPC, assign it a complete IP address block, further dissect the VPC into multiple subnets, and the instances launched in those subnets will get the private IPs from the depending upon in which subnet they're launched into. Fine. So the private IP addresses of the instances depend upon the subnets and the VPC they're launched into. Fine. Also, if I want the instances to get access to the internet, apart from the private IPs, I can also link the public IPs or the elastic IPs to them so that they can access the internet. I can link them with the public and elastic IPs so that these instances can access the internet. They are fully exposed to the internet. They can send or receive the traffic towards the internet. Fine, you got the point. So basically, just you need to understand this thing, that a VPC is a virtual data center which is designed using the private IP addresses, a complete block of IPs, private IPs. You further dissect it into multiple subnets, which are further blocks of IPs, private IPs. The instances will get the private IPs from the range of the subnets, or depending upon in which subnet they're launched into. Depending upon that, the instance will get its private IP. Fine. You don't have to deep dive further. You don't have to understand it further, because once we discuss the VPC, I will spend 6 hours to explain all this stuff. Fine. Because we have to deploy the instance, and the VPC has to be chosen at the time when the instance is deployed. It was my responsibility to discuss with you that what is a subnet and what's a VPC. And each subnet is linked with a different availability zone. For example, this subnet is linked with AP South 1A availability zone, and this subnet is linked with AP South 1B availability zone. So each subnet is linked with a separate availability zone. Fine. Having said that, this completes the basic theoretical overview of the EC2 before we can get started and start with the instance deployment. Again, the details that I've discussed with you, I've just discussed with you basics. Now we'll start with the, once you go to the home page, you just search for EC2 and you will see that automatically it will pop up on the screen, EC2 virtual servers in the cloud. Okay, you click on EC2 and this will take you to the EC2 dashboard. Okay, now once you go to the EC2 dashboard, you can pick any region of your choice. Now guys, one thing I want to emphasize, the previous hands-on that we did was the identity and access management that does not require you to select any region. But for instance, the region has to be selected. Now, I would highly recommend use North Virginia to perform the hands-on. Don't go with any location. I'm in India. Why are you saying we use North Virginia? It's very far away. There's a latency and so on, blah, blah, blah. Don't worry about the latency issues. You're not deploying anything for a production environment. It's purely for testing and hands-on, right? I would highly recommend switch to North Virginia region, because this region consists of ample resources. Because for example, in Mumbai, if you try to deploy T2.micro instances in AP South 1C, there's a shortage of that. And the second thing I want to emphasize is that stick to one region as if now to perform all your hands-on. Unless you're required to use another region, that will be done afterwards. But till that point, just choose and use only one region to deploy everything. Why am I saying so? I'm saying so because it's easy for you to track your resources and shut them down. Because if you unnecessarily scatter resources in different regions, you get confused at the time when you want to shut down the resources.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
So to make the things very simple and making sure that you don't scatter resources unnecessarily, just use one region to perform majority of your hands-on. We may fall in a situation where we can use 2 regions, 3 regions, but as of now, use only one region, right? So choose North Virginia so that you don't face any scarcity of resources. Once you go to North Virginia, just go to EC2 dashboard. This is your EC2 dashboard. Now, EC2 dashboard will consist of instances, hosts, load balancers, security groups, volumes, snapshots, key pairs, elastic IPs. Now, these things we're going to configure along once we proceed further. On the left-hand side, this is called navigation pane. This is the navigation menu, right? On the left-hand side, you can see that load balancing, auto scaling. We'll discuss all those things in the upcoming lectures, but this is the navigation menu. Now, as of now, we don't have an instance right now. We'll deploy our first instance that would be a Linux-based instance, a Linux-based instance. It says you don't have any instances in this region, so we can just click on launch instance right now. Now, the thing is that some people may get a new dashboard. You can opt out from the new experience. So AWS will continuously release a beta version of their instance or any configuration, and they roll back. If you get a new dashboard, just go on the top and just click opt out from the new experience, because you need to go back to the previous experience, because the opt-in experience right now, it's in beta version. It may not be implemented in the future. Fine. So you have to go, because this is a new experience. And see, the thing is that the selection is same. The configuration parameters in the new version is same, right? Okay. Now some people may get this, some people may not get this. Few people will get the new version, few people will not get the new version. It's a beta version of the instance deployment. So go to this option. If you have this, opt out to the old experience, because new experience is still in beta version. You may not get it. Not all the people will get it. Okay. So this is what exactly the dashboard looks like. Now, the very first thing that you need to select is the AMI, which stands for Amazon Machine Image. Now, we all know what is an AMI. It's a software configuration. It's a software component of the instance. This is operating system, the applications, the software, scripts, programming language runtime, platform, everything. It's bundled together in a package in the form of AMI. Okay. Now, in this hands-on, the AMI that we will select would be this one. Amazon Linux 2 AMI. You can use any kernel version. Now, this is a Linux-based AMI, which is being customized by Amazon Web Services. It consists of some basic latest softwares and scripts, and it does the job. Go ahead and click on select. Okay. Now, the next thing that you ought to do is, the next thing that it shows you is this one, the instance type. Instance type, as we discussed before, it's the virtual representation of the underlying physical resources. So make sure that you choose T2.micro, which is a free tier eligible instance type. Okay. Go ahead and click on next, configure instance details. Now on the third step, once you're on this third step, this script is the bash script that we run upon the instance. It's a bash script which will update my instance, install the HTTP Apache upon it, start that service, go to the HTML folder and create an index.html file with this message into that. So if we try to access a website that we will deploy upon the instance, this is the message that it will display. Now, on the third step, where you are on the configure instance details, you don't have to change any of these parameters. Nothing to change. These are default values most of the times, because right now we're just doing the basics thing. We'll not change any of these parameters. You have to download the script first. Now, please ensure that you don't do this thing. You just open the script on the browser and copy and paste from that. Don't do this. You need to download the script first on a computer, open that on the notepad, copy the script like this. Once you copy the script, on the third step, where you configure the instance details, you just go down below. There's something called user data. Now, this is used for the bootstrapping purpose, where we just put the script in. The script will install the necessary application services at the instance launching process. You need to paste the script as it is in the user data. You need to download the script first, Scroll down on the third step where it says configure instance details. You have the user data. Under advanced details, you need to copy and paste the script as it is. We click on extract storage. Now this is where we add the EBS volume to the instance. We add on the EBS volume to the instance right now. EBS volume is nothing but it's a block level device that will link with the instance. Okay. You don't need to change anything. I'll not explain you everything because once we go to the next step, once we discuss the EBS, I'll discuss all these details in the future. Okay. Right now, you don't need to understand every aspect of EC2. It's not required because most of the things like VPC, EBS we discuss in detail. But I've discussed with the basics of the EBS. It's a 8 GB of volume that we're adding on to the instance. It's a root volume. So the image files, the AMI files, and the necessary scripts will be stored on this root volume, and we don't have to change anything over here. So 8 GB of storage, the block device, the root volume will be linked with the instance. You need to accept the default settings. Click on next add tags. Let me know once you are on the fifth step. Now in the next step, on the fifth step, you have to add a tag. See, what's a tag right now? See, the purpose of tag is that you just assign a key value to the instance for multiple reasons. But the main reason is just for the recognition purpose. Because on a single instance dashboard, you can have hundreds of maybe thousands of instances running. You assign the tag to the instances or a group of instances so that you can recognize the relevance of that instance in your environment, and you can differentiate that this instance belongs to this category. Secondly, the tags are used for billing purpose. If you want to, for example, extract some billing reports, tags are used. Also to automate your software deployments. Those things we discuss afterwards in detail. Right now, we are tagging the instance just for the documentation purpose, just so that we can easily differentiate this instance from other instances if we deploy multiple instances in the future. So I click on add tag. In the key field, just type in name, and in the values type in, for example, demo web server. Now the same will show up once instance is deployed. On the left hand side, this is a kind of a name you assign to it. A name assigned to it, making sure that you can easily differentiate it from other instances. For example, I have 10 instances running. Each instance or a group of instances can have the common tag, so that I can easily differentiate that, okay, these are my instances which host my demo website. These are instances that host my databases. For the tagging purpose, we tag the instance so that we can easily recognize them and differentiate between different instances. In the later stages, I'll explain you how you can use the tagging for billing purpose and for the automating purpose. But right now, just tag the instance and let me know once you're done. Done. Okay, great. Now, the next part is next configure security group. Okay, this is where you have to create a new security group and assign it to the instance. Now, what is a security group? We have discussed that. It's a virtual firewall that will link with the instance, making sure that we can restrict the incoming and the outgoing traffic with respect to the instance or instances. Now, right now, the security group or the rules that we define would affect the incoming traffic. Incoming means that the traffic that the instance will receive from outside. Later on, we can also manipulate its outgoing. So the very first thing is that you need to assign it a name, a special name to it. For example, I name it as a demo web server security group. So you need to just assign a name to it. So you assign a simple name to it, any simple name that you can think of, assign to it. Okay. Description is just for the documentation purpose. For example, this security group, for example, you can say that would be assigned to all my Linux web servers. Fine. So you can assign the same security group to multiple instances. Okay. Just a simple name and a simple description. Once you're done, just let me know. Assign a name to it, assign a description to it. Then I'll help you adding the inbound rules. Done. Okay. Now in the inbound rules, you have to start defining the rules so that you can restrict that what type of traffic can hit your instance. Now, because we are about to deploy a Linux-based instance, the default protocol to access your Linux-based instance or instances is the SSH. SSH stands for Secure Shell. It uses port number 22 to access. We're going to be using that to access our Linux-based instances. Now you have to choose. Now, if you choose 0.0.0.0.0/0, this means that you will give the server access from any IP on the internet, right? Which will expose your instance or the server to unwanted threats. So what you're going to do is that choose my IP. This will automatically pick the IP address of your laptop or the desktop you're working on. Okay, so you're going to type, for example, SSH from my local computer. This will ensure that only your computer IP address can get the server access to the instance. Okay, now let's imagine, because we want to deploy a web application upon this instance, you need to also add another rule, that is you can choose the protocol HTTP, which uses port 80, and choose anywhere. So I'm saying HTTP access from the internet users. Please add these two rules and let me know once you're done. So the server access is given to myself, but the website access is given to any person on the internet, because we're deploying a simple website upon the instance. Let me know once you're done. Are we done with this thing? Simple thing. We are ensuring that we just add on a security group. How do we determine that our local computer is a server? Our local computer is not the server, Ron, in this case. It's a client which is trying to access the server. Server is the one that we're launching, and a local computer is a kind of a client. From client, we're going to be accessing the server in this case. But just in case, if you choose custom IP, then you can, for example, choose an IP address range of your data center. For example, this will consist of, let's suppose I pick this range, right? So this will consist of, let's imagine, few thousands IPs. For example, this complete IP address chunk is assigned to my data center. So I can say SSH from my local data center, or from my on-premises network. So you can also define the complete range of IP addresses. Okay, but in this case, we're going to be using my IP. So SSH from my computer. Fine. So if you choose a complete IP address range of your data center, then you choose custom over here. Shall we proceed to the next step? Now we click on review and launch. Now this is a review page where I can just click on edit on the right hand side and change these parameters. Now 50% of the parameters can be changed, 50% of the parameters cannot be changed. You don't have to understand what you can change, what you can't change. This is the review page. This is the review page. Click on launch. Let me know once you're on this page. Let me know once you're on this page. Select an existing key pair or create a new key pair. Just type in done once you're done. Done. Okay. Now what you need to do is you have to choose this option, create a new key pair. Okay. Choose. Now what is this? Let me explain you. See, key pair is nothing but it is the method of authentication to authenticate to your server. It's like, for example, when you log into your Windows computer, your office laptop or the office computer, you put in the ID and password. You unlock your machine using ID and password. This is a method of authentication to unlock your server. Now you may use the in-house authentication mechanisms, but what AWS proposes is that you use this key pair to authenticate to your AWS servers or instances. Now, why it's called key pair? It consists of two keys. One is the public key that's being stored by AWS. Basically, the public key is embedded into the AMI of the instance. You can't see that. And the private key file is the one that we store on our computer. Now, in the future, if you want to get access to the server, I want to authenticate to it, I'll be uploading the private key file, and if the private key matches the public key, I'm able to get into the server. You might have seen if you own a locker in a bank, right? You have your own key. You go to the bank premises, you sign a register over there, do the entry. You go to the locker room, you put your own key, unlock the locker, and the bank official will use his or its own key, the bank's own key, to unlock. If both the key match, then you're able to open the locker. Right? You need two keys. One is owned by you, another is being kept by bank. Similarly, the public key is being stored by AWS. It's embedded into the AMI of the instance. The private key is being kept by us. We store that on the local computer. When the time comes to open the server, we match the private key with the public key. And if the match is correct, we are able to authenticate and barge into the server, open the server and access it. Now you have to choose create a new key pair. Make sure the key pair type is RSA. Now this is the industry standard. And you have to assign a name to it. So I name it as, for example, demo web server dash KP. Okay, whatever you want to name it, right? And click on download key pair. Now this will download a small private key on your computer automatically. Let me know once you're done. You have to choose create a new key pair. The key pair type, you can see that on the screen, is RSA. Assign a name to the key pair and just type in download key pair so that you download the private key on your computer. Now this mechanism is called public private key cryptography, right? Even when you make backend transactions, the same mechanism is used. Once you download the key pair, you just simply need to click on, okay, I'm just waiting for a few more seconds before I can just get some confirmation. Now you simply need to click on launch instances and your instance will be launched. And the private key will be saved in the downloads folder on your computer. You can see that in the PEM format, PM format. Now, for example, if I open this key, I put, for example, .txt at the end of it, you can see that this is how the key looks like, private key. It's a complete algorithm that we use. The algorithm, it uses the public private key cryptography. This is the contents of the private key. Just for FYI, this private key we shall be using in the future to authenticate and get access to the instance. Are we done launching the instance? Let me know once you're done. Once you're on this page which says your instances are launching, fine. We have launched the instance as of now. Done. Now, guys, if you click on View Instances, the instance will show up like this. This is the first instance that we've deployed, right? With the simple Apache web application or the web server running upon it. Now, this is the public IPv4 address and this is the private IP. Fine. Now, as we have discussed, the private IPs are used for internal communication and the public IPs for the external communication. Now, because we want to browse the website deployed upon the instance, you choose your web server and you can see there's a public IPv4 address. If you click on open address, it will automatically show your website if the deployment has been done successfully. Let's copy this link. You should be able to see a web page within few seconds. Because my instance is still initializing, we need to wait for some time. You can see that it is status check initializing. It takes some time for the instance to deploy. And after that, if I copy and paste the public IP address, I get the website access. Okay. So if I browse, I go to the public IP address under details and click on open address, I should be able to open the website. Or simply what you can do is that copy the public IPv4 address, paste that in another tab, and you should be able to get access to the website. Let me know once you get this output. Fine. So we have deployed a simple web app upon the instance. Simple thing. The script that we use, it installs the Apache PHP web application upon the instance. Simple. This is the website, a simple website, a web application that we have deployed upon the instance. Plain and simple concept. Fine. Nothing much about it. That's about the stuff. Okay, fine. So guys, this is about a simple demo web application to be deployed upon the instance or upon the instances. Now, there's an assignment that I want to give to you. Please, all of you need to log into the AWS management account or the AWS account that you have. Make sure that you just go ahead and you just log into your account. You're in? Okay. Now, what you have to do is, once you just go to the instance dashboard, right? The instance shows up, you have to start it. Now, how to start the instance? You have to check the instance, go to instance state, and then you have to start it, right? So you need to just go select the instance, go ahead and start the instance. Let me know once you're done. So please make sure that you check the instance, go to actions and click on, go to instance state and click on start so that the instance gets started. Done. Okay, now the next thing that you're supposed to do is once you initiate the instance, there's a bigger possibility that your laptop's IP or the desktop IP has changed. Because we want to allow the SSH from the known IPs, you have to select the instance right now. And you select the instance, go to security, and under security, then you have this thing called security groups. Okay, you need to select the instance, go to security, and then you need to go to security groups. If you go over there, you have the inbound rules and outbound rules showing up in the security group or of the. Now we discussed the security group. It's a virtual firewall that you apply to the instance so that you can restrict the incoming and the outgoing traffic with respect to it, right? That's what the purpose of the security group is. Now what we're going to do is you need to click on edit inbound rules. I'll show you one more time. You select the instance, right? Then go to security. Under security, you have the security groups section shows up. The option shows up. Click on that. Then you have the inbound rules. On the right hand side, you have to click on edit inbound rules. Okay, let me know once you're there. Now you have to make sure that in the SSH choose my IP again, right? This will refresh the IP if it has changed after 24 hours. So because this is the next session that we have started, in the meantime, you might have restarted your machine. Choose my IP one more time, or remove the previous IP, choose my IP one more time, so that if a new IP is applied, then it shows up over here. Choose my IP one more time, just to ensure that, just in case if you think, because there's a bigger possibility that your machine is getting a new IP, your computer is getting a new IP, right? So what you can do is choose my IP one more time. It will refresh the new IP and click on save rules. Fine. Yes, changed. Yeah, because it will change. You're coming the next day. You have rebooted the machine. So in this case, you need to click on save rules. This will ensure that now the IP address that your machine has got, your computer is getting. Now in my case, the IP address of a machine didn't change. So I got this message, you have not made any changes. That's absolutely fine. This will remove any scope or any risk in just in case, because if the IP address of my machine might have changed, in that case, I may have got the connection time.error message, or it should have stopped me from getting access to the instance via SSH. Okay, to remove any scope of that error message, we just need to hit refresh and click on save rules. Okay. Now, once you're done, you can exit from here. Just click on EC2 on the top, go to instances, so that you just go back to the instance dashboard. Fine. Now, and the document is that there's a process to connect to the remote Linux instances from the Windows computer. Now, the process is different for the Macintosh people and the people who own Mac, who own Linux, and who own Windows computer. Fine. Now, basically, for the Windows people, you have to just go to this link and install PuTTY, PuTTY and Patient. I hope that most people have done it. This is the link. You have to make sure that you can just go to that, and you need to install these three different softwares, which is PuTTY, PuTTY and Patient. Patient we're not used right now. Patient we're going to be using some other time. Fine. Okay. So now the next thing that we need to understand is that how to connect. Now, to connect to the instance, there are multiple options out. There are multiple options out. What are those options? See, the very first thing is that the options depend upon the operating system that you use. The reason being that every operating system has its own terminal or shell prompt. That shell prompt can be used to connect to your remote Linux instances or Linux instances. Okay. Now, the first way out is, now it is not a very recommended method or very reliable method. That is, we use a browser-based instance connecting feature. We choose the instance that we deploy. Okay. And there's an option which says connect. Can you see that? There's an option which says connect on the top. Now, if you choose it, you just click on connect. Okay. The option that we're talking about is the EC2 instance connect. This is the one, fine. The option that we're talking about is the EC2 instance connect. Now, this shows the username, the default root username of the Linux instance. Okay. And this is if you want, you can change it, but right now we'll use a default one. That's the EC2-user. Now, again, it's browser based. It is not guaranteed that it will work on all the browsers or all the computers, because maybe a pop-up blocker, maybe you're using the Office laptop. Sometimes it works, sometimes it doesn't work. Okay. So I go to instance connect and click on connect. Okay. This will open the browser-based shell prompt. If it works, that I can use to connect to my instance via the browser. Let's say there's a problem while we connect to the instance. Again, I'm saying sometimes it works, sometimes it doesn't work. Okay, so if it's working for you, that's absolutely okay. If it's not working for you, then we don't have to depend upon that, because it's a new type of methodology that's being introduced by AWS. Still, it is not being they have taken it to the level where it can work properly for all of us. But if you're getting that issue, that's absolutely okay. So in this case, we're going to depend upon the PuTTY and PuTTY on Windows computer, so that we can get access to it. Okay. Now, the next thing that we're going to do is how to connect via PuTTY. Actually, I don't have a Windows computer running. It's because I'm using Macintosh. So just to show you the stuff, I've just launched a Windows server. So I'll be treating this Windows server as my Windows computer. I'm going to be using this one, and we'll ensure that we can just connect to it. So just give me a second over here before I can connect. I'm just launching a Windows server just to make sure that I can show you the process to connect to the Linux instances from the Windows machine. Okay, because I'm running Macintosh, I don't have the capability to show you from the Windows computer. So in that case, I just launch a Windows server real quick just to ensure that I can show you the process from the Windows computer. You just allow me a second over here. Okay, so this is my Windows machine, and I'm just doing one setting so that I can open the internet connectivity for it. I can just open the browser and do a few things which are required. Just give me a second over here. So what I'm trying to do is I'll show you the steps right now. First thing first, I'll be going to the browser and installing PuTTY. Okay, first thing first, if you open the document, let's get started. If you open the document right now, the document says connect to your Linux instance from the Windows local machine, right? You need to install PuTTY and PuTTY on your Windows on your local computer, which is Windows, fine. And then once you install it, the very first thing I'm going to show you is the second step. See what I'm doing? Don't be in a rush. Don't be confused right now. Don't just start running in different directions. Stick to the method. The document is there on the Google Drive. I'm in the first step. You have to install PuTTY and PuTTY that you already did. So nothing to worry about. In the second step, that what you have to do is that you have to convert this PEM key to PPK key. See, the keys that gets downloaded by default, it's in PEM format. PEM stands for, or I would say PEM is the format which is not supported by PuTTY. See, the thing is that, okay, let me do one thing. The key that we downloaded, I'm talking about this key, this one. It is in PEM format, .pem, right? PEM keys are not supported by PuTTY because when I'm using PuTTY as a client software to connect to our Linux instance from our Windows computer, PuTTY accepts the PPK key because once you launch the instance, at that time only the PEM keys can be downloaded, not the PPK keys. Fine. So okay, now what I will do is, because I don't have the Windows computer, I am using Macintosh. I am trying to download the PEM key. Now this is the same PEM key which got downloaded at the time when we launched the instance. You check your downloads folder, it should show up. I just download the PEM key, right? Now the PEM key, when we launch instance, by default, it is saved as PEM key, which is not accepted by PuTTY by default. Now this, can you see that it says PEM file? It needs to be converted into the right format so that it can be acceptable by PuTTY, right? Now to convert this key, we're going to be using PuTTY, right? We need to convert that using the PuTTY. Now to connect it via the PuTTY, of course, PuTTY needs to be installed. So I just do that real quick. It's a matter of just a second. Now the font size will be a bit small because I'm in a Windows server right now. I don't have Windows computer. Now you will face some trouble while looking into the fonts. I'm showing you the process. You can see this, the big screenshots. I'm showing the second step on this document. Second step from second step. So the thing that I'm showing you right now is from the step 2 of the document. Now I open PuTTY or install PuTTY. It's a very simple software. It will just install itself very quickly, very light software. Now it gives me the option to convert the key. It's called PuTTY key generator. You have to upload the PEM key and convert it into the right format. That's the PPK. Go to File on the top, right, and click on Load Private Key. So what we have done is that we have loaded the private key. We have to load the private key that's being saved on our computer. I load the private key. Now the thing is that the key will not show up. You need to choose all files and just go to the disk space where the key is being saved. You have to choose the key, the PEM key, press open. Now this will upload the contents of the key or import the key. Okay. Now the steps are well documented. Just see exactly what I'm doing. I'll give you enough time to do it by yourself. Now I get two options: save public key, save private key. Because we are working on the private key, I click on save private key. If you give me a prompt, are you sure you want to save this without a passphrase? I would say yes. And I just assign any random name to this key or the same name, but this time the format of the key would be PPK. PPK stands for PuTTY private key. .ppk. Right? This is accepted by PuTTY. So we're gonna be using PPK key. Right? We're gonna be using PPK key so that we can upload it to PuTTY and connect to our remote Amazon Linux instance. Click save and will be saved. You can see that on my computer, on my Windows machine, this got saved in the PPK format. Okay. I give you some time. Please go to the second step. The document is there. I just copy and paste the link for the document one more time. On the second step, you have to go. You have to make sure that you convert the key from the PEM format to PPK format, right? It's a simple process of key conversion so that PuTTY can accept that key. Because PuTTY accepts only PPK keys, we have to convert it from the PEM to PPK format. It's a simple process of key conversion.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Fine. So now, guys, I think it's done. Let's go to the next step now. The third step. Now, see what I'm doing in the third step. Okay. See what I'm doing. Nothing to be very much. You don't have to be in a hurry. It's because you're doing that for the very first time. Sometimes there's a scope of confusion. That's okay. It's well understood. Basically, what you have to do is that now the key is being converted. The same key would be uploaded to PuTTY client so that you can use that key for the authentication and authenticate and get access to the instance. Fine. So what you have to do next is use PuTTY. So I go back to my Windows machine. I install PuTTY real quick so that I can start the process. It's an extremely simple process to get started. So I go to putty.exe and I just install PuTTY real quick. It's a fairly simple and fast process. And here we go. Now, again, on my, because I'm using Windows Server, I don't have Windows Computer. The font size would be a bit small. But if you just see that on the document itself, you can easily see the exact option on the screenshots or via the screenshots. See, how we connect to the instance is through its public IP. Why are we using public IP in this case? Why are we using public IP? Because we are trying to connect to the instance via the internet. If you go back to the instance and choose the instance that we just deployed or we're working on or we're just trying to connect, we choose the demo web server. And the main thing that we need to select is the public IPv4 address. You can also choose public IPv4 DNS name. This one, you can choose either of these two different options out there. It's purely your choice. So let's choose public IPv4 address. Now, why are we using public IPv4 address? It's a simple reason, because we are using internet as a medium to get connected to these instances or to this instance right now. So I choose the public IPv4 address for simplicity and ease. And of course, it's a logical reason. It's a logical thing to use the public IP if you're using public network to get access to our remote servers. Once I open PuTTY, the very first thing it will ask me is for the host name or the IP address. I paste the IP address that I just copied from the AWS management console. I just did that. I copied and pasted the public IPv4 address. You can also copy and paste the public IPv4 DNS name. Once you do that, you don't have to change anything. By default, the port will be 22. That's a static port that's used by SSH. You don't have to change anything. On the left hand side, you have SSH and AUTH. This exact path is there on the document, right? If you scroll down, it says under correction time, we have to select SSH. Then you have AUTH. So on the screenshot, it's very well documented. I choose AUTH, and under AUTH, I need to browse for the PPK key, not the PEM key. Because if you by mistake choose PPK key, you'll be completely denied the access. You click on browse and you pick the PPK key and press open. So I have just given the exact path of the PPK key to authenticate. Okay, I press open. Now it will give me a prompt. Let's see. Okay, I've done one mistake. It's don't go with that, because I'm using Windows Server. So in this case, I'm not using my computer. So just give me a second over here. You don't have to do it, because I'm using Windows Server to connect. I'll show you one more time. I copy and paste the IP address, SSH, AUTH, and browse for the PPK key. I just do that real quick. Press open one more time. Now it will ask me the prompt to accept it. I press accept and I'm connected. Now what I will do next is that it will show me login as. Once I accept the connection, I have to put in the default username of the Amazon Linux instance. The default username is ec2-user. Press enter and you should be connected. Fine. Let's discuss the EFS file system. See, EFS file system is nothing but it's a file system storage that you can link with multiple instances at the same time. So I am going to open the slide right now and start discussing the theoretical concept behind it, and then we do the hands-on, right? So let's get started with the next stuff. That's the EFS. What is EFS? EFS is a cloud-based file system, cloud-based file storage service for applications and workloads that run in the cloud. Basically, if you are running your instances upon which the applications and workloads are running, for example, you have 20 instances, 30 instances, they need to have a common storage. They need a file system for that. And in that case, you can be using the EFS file system that stands for, or EFS that stands for Elastic File System. So if you have, for example, 10 instances, 20 instances, they need to put their data in a common storage. Then you connect an EFS file system to those 10 instances or 20 instances. Fine. Now, what are the benefits you get out of this file system? It's highly available. Highly available means that if you there's very less chance that you will lose any data that you put in this file system. Elastic, now it can grow in size exponentially. You can put as much data as you can in this file system. You don't have to choose a limit of the file system. It will grow based on your consumption. It is a shared file system. Shared file system means that this storage can be linked with multiple instances at the same time. And it gives you very high performance because it uses a lot of components which makes the storage access much faster. Fine. So basically, if you have 20 instances, 30 instances, they have to have a common storage. They link to the same file system. Okay. Now I'll show you. There will be a demonstration that we're going to be doing right now to create and mount an EFS file system. Okay. Now what you can do is, before we can get started, please either stop or terminate the previous instance because we don't need it anymore. See, you get 750 hours of running Linux instance for free of cost each month and 750 hours for Windows. Now, to avoid the unexpected charges, either you can choose the instance, go to actions, either you can stop them, instance state and stop them. Stop means that you can come back and restart them. The binning stops even if you stop them. And if you come back and restart them, the binning resumes. If you don't want to access these instances anymore, please go ahead and terminate this instance or terminate the instance that we have launched. This will ensure that you permanently get rid of the instance. Okay, either you stop them or you terminate them. It's purely your choice. In either of these two cases, the billing will stop immediately. There's no billing, but the the calculation would stop because it's kind of a meter. It's running. You get 750 hours free for Linux, 750 hours free for Windows. To stop that running cycle, you can either stop or terminate the instances. It's purely your choice. Fine. Okay, now the process that I'm going to show you right now is that you need to create an EFS file system and connect to the file system through two Linux instances. Fine, because EFS is a common storage for workloads and applications running upon multiple instances. Okay, now I'll show you the step number 1, 2. Now this is free of cost. There will be no charge whatsoever in terms of the deployment process. I'll show you the steps number 1 to 6. See what I'm doing, because in the process I'll explain you a few things and then I'll give you some time to do it by yourself. So I'm showing you the steps number 1 to 6 and see what I'm doing. So what I'm doing right now is that I just go back to the my AWS management console and I search for EFS. Fine. Now once I just go to the EFS, it says EFS managed file storage for EC2. Click on the EFS. Now it will straight away take you to the EFS file system dashboard. Let's go over there. Now, once we just go to the EFS file system, the very first thing that we're going to be doing is to create a file system. Now you can see that EFS provides a simple, scalable, elastic file system because it can grow in size for general purpose workloads to be used in the cloud. Also, it can be used with the on-premises resources. This is the cost of the storage. Now, of course, this is free of cost because we don't have to consume the storage as of now. So I'll create, now it says NFS. NFS stands for Network File System. It's a protocol that we use to access the file systems. I'll come to that later on. I click on create file system. Now, the very first thing is that I assign a name to it. I name it as demo file system. You just assign a very simple name to it. Okay, a simple name assignation so that you can recognize this EFS file system at the time when you link it with your instances. Now, the file system and the instances that need to be interconnected, they need to be cocooned or included in the same VPC, same virtual private cloud, right? You don't have to change the VPC, keep it to default. Now, in the availability and durability, you get two options, regional and one zone. What are the key differences? See, your data will be stored in this file system, any data, your application data. Now, if you want to create multiple copies of that data and store that data redundantly across all the availability zones in the region this file system will be contained in, you choose regional. Okay. For example, the region we're working in right now, it is North Virginia. How many AZs are there in North Virginia? 6. So it will create multiple copies of my data and scatter and distribute that data across all the 6 AZs in North Virginia, right? But if you want to make it a lot cheaper and bring down the cost of my storage, I choose one zone and I pick only one availability zone where my data will be duplicated and stored and made redundant. So in the rest 5 availability zones, my data would not be stored or made redundant. This will bring down the cost of the storage. Okay. Now, because we're doing for just purely for the hands-on, choose regional because we don't have to put any huge amounts of data. Fine. So for the business use case, this is exactly what you do. Go ahead and click on create and it will create a file system for you. Okay, great. So we create the EFS file system. Now, what we're going to do next is, that's great, that will connect to this file system to 2 instances right now at the time of launching those instances. So the steps I'm going to show you from 7 to 19. See what I'm doing, and I give you enough time to do it by yourself because I want to make sure that you don't make any mistake at the time when you do this process by yourself. See, what I'm going to do next is that it's a success. My EFS file system is available. I search for EC2 on the top of the search menu and just open the EC2 in a different tab. Okay, let's do that. Let's go to the EC2 management console. Let's go there. Now, even if you have terminated the instances, it will take one or 2 hours for these instances to be removed permanently, but your billing has stopped. So nothing to worry about. So now I will launch 2 instances right now in front of you. See what I'm doing? And I'll give you enough time to do it by yourself. I click on launch instances, and for this hands-on, make sure you're going to be using the same Amazon machine image. That's the Amazon Linux 2 AMI. The same AMI ought to be used. Okay, you don't have to choose anything else. You need to click on select. Once you click on select, the next thing is that you have to choose the instance type. Of course, we're going to be using the T2.micro instance type because it's free of cost. We click on next configure instance details and then we go to the next step. Now over here, you need to ensure that now you includes a few details. The very first thing is that you have to put the number of instances over here. Make sure that you choose number 2 because we want to deploy 2 instances in one single shot. So I'll be launching 2 instances in one single shot right now. Okay, 2 instances right now I want to just deploy. Once I put number 2, just write to the number of instances. I simply need to scroll down, okay? And it says, do you want to add a file system? So I click on add file system and automatically it adds a file system, or I can choose it in the drop-down menu. It will include the file system automatically. So what I'm doing is that I'm linking this file system with these 2 instances that I'm just going to launch right now. Okay, now just pay proper attention what I'm saying right now. When you choose a file system, it will add on the security groups to your instance. 2 security groups. Now, just try to understand what it's doing right now. Okay, I need to explain you something. So what we're trying to just try to understand what exactly I'm just trying to elaborate some concepts. See over here, let's imagine I have these 2 instances running. Or let's suppose this is my EFS file system, right? Okay. And this is my EC2 instance, or these are my 2 EC2 instances that I'm just going to launch right now. Now, what I'm trying to do is right now is, so these are my EC2 instances. Okay. Now, there will be a security group assigned to both instances and a security group assigned to the EFS file system. For the EFS file system, for example, the security group is EFS-SG, and for the instances, the security group is EC2-SG. There will be 2 security groups linked with instances by default. The first one is the one that allows me to gain the SSH access to the instance. The same thing that we have seen. We need to allow the SSH from the IP addresses so that we can SSH to the instance or instances. Now, there will be another security group. So for example, this is the EC2 security group number 1. There will be another security group, which is, for example, EC2-SG v2 or number 2. This will allow the instance to access the EFS file system using the protocol NFS 2049. NFS stands for Network File System. It uses port 2049. This is a default protocol to access the file systems. It's industry standard to access the file system. The NFS and Network File System, which uses the port 2049. So this is the protocol, this is the port. We need to allow this from the instance. So instance should have this outbound towards the EFS security group so that it can access the file system. It can access the file system and it can put the files into that, right? So I'm saying from EC2-SG security group number 2, I need to allow the NFS 2049 towards the EFS-SG security group. Sometimes you can allow the inbound and the outbound rules between the two different security groups as well. So the first security group will allow the SSH from the IP addresses. For example, I can say my IP. And the second security group will allow the NFS 2049 outbound towards the security group linked with the file system. Fine. This is what will happen at the behind the scenes. So it says additional security groups required. To enable access to the file system, the required security groups will be automatically created and attached to this instance, and the selected file system mount targets. Okay, so I'm saying automatically create the required security groups. Fine. I choose a file system. It will link two security groups with this instance. The first one will allow the open SSH access, and the second one will allow the outbound NFS 2049 access towards the EFS file system security group. I'll show you. Now, automatically under user data, it puts a script so that my file system can be mounted upon the instance or instances. This user data is automatically generated. These are the commands needed to mount the file system upon it needs to be mounted or connected with instances. Fine. So basically on the third step, you have to add two instances, add the file system, and that's it. You click on Extract Storage. Now this is the EBS volume linked with instance. You don't have to change them. Click on Extract Tags. You can add a tag. For example, you can name it as EFS demo instance. Click on Next, Configure Security Group. Now this security group would be created automatically, which will allow the SSH from custom source anywhere. You can choose my IP if you want, or keep it as it is. And the second security group will allow the outbound NFS 2049 access towards the EFS file system. You can see that. The instance security group include no inbound rules, the second one, but it will allow the outbound rule towards which allows the traffic over NFS 2049 port. Okay. You click on Review and Launch. Click on Launch. Now you can create a new key pair. As per the document, you can create a new key pair, or you wish to choose or say choose an existing key pair and choose the same key pair that you launched for the previous Linux instance, or you create a new key pair. It's purely your choice. Hit Acknowledge and launch your instance. Step 7 to 19, let me know once you're done. I hope that made it clear that what's the process, how the instances or how the file system gets mounted upon the instance, because you have to open the NFS 2049 port between the instance and the file system. Okay, once the instance gets launched, I will show you how those two security groups are being linked automatically. All right, now guys, if I just go and just check view instances or I click on the instance right now, any of the instances right now, I choose instance, let me show you the security group. Then I go to the security part. I'll show you one thing. You will see that there will be two security groups linked with the instance or instances. If I click on the first one will allow the open SSH based upon the source I selected. Okay, and the second one is this one instance SG4, or in case it will be SG1, SG2, whichever is that. It will allow the outbound NFS 2049 traffic towards the security group of the EFS file system. Can you see that? This is the security group ID of the EFS file system. SG072 in my case, if I show you the file system, let me show you. If I go to the file system right now, there will be a security group showing up. I think it should be under network. I think so. Yeah, here we go. See, in my case, SG072, this one. So I'm saying that instances can access the file system NFS 2049 towards the security group of the EFS file system. You got the point? Okay. Now, guys, the next thing that comes up is that you have to SSH to one of the instance. Please SSH to any one of the instance and let me know once you're done. I don't have to tell you again how to SSH to the instance. Choose any one of the instances and SSH to that instance. Let me know once you're done. So I've initiated the SSH connection to one of the instances. Are you in? Let me know once you're done. Done? Okay, great. Yes, in this case, if you want to use EC2 instance connect, you can use that one as well. it may work for you because we didn't use any script on this instance. You use the instance like this, choose instance, on the top click on connect. Under EC2 instance connect, click on connect one more time and it will open the browser based session. Just great. Now, if you go to your instance right now, just type in df. Now I'm showing the step number from 21 to 27. So the steps that I'm showing you right now is I just type in, I've SSH to the instance, just type in df hyphen capital T. Guys, please use PuTTY, don't use EC2 instance connect. It will further confuse you without unnecessarily. Use PuTTY. df hyphen T, right? And it will show me the list. This is the file system that I have. Now I need to go to the file system. Okay, first thing first, you have to, this is the file system. This is the one. Now you have to change yourself to the root user, sudo su, so that you upgrade your privileges and you can create some document. Now just type in cd, change directory and copy and paste the complete path to access the file system on the Linux system or through this instance. Now I just run the touch command. Touch will create a document, for example, touch intel.txt. This will create a text document, intel.txt, in the file system. Now I want to put some text in this file system. Let's type in echo or echo, whichever word you think it's right way to pronounce, echo, and I just type in, for example, this is my EFS demo. I close it, the statement, and include two arrows and put that in the text document. So this is my EFS demo. This statement will be put in the text document. Now, if I want to see it, just type in cat intel.txt. Cat command will just show me the statement in this text document. Okay, please go ahead and do that and let me know once you're done. And please use PuTTY to connect to the instance and create a text document using a touch command. Use echo command to put some text in the text document and run the cat command to show you the output of the text document. Done? Okay. Once you have done, then the next step that you, in the meantime, you can do is that you can SSH to the second instance now. Okay. So I'm showing the last step now. The last step is you need to go to the second instance and SSH to the second instance via PuTTY. So because I'm using Mac terminal, I'm not using PuTTY, but you have to use PuTTY. I've already shown you the process how to use PuTTY to connect. So I connect to the second instance, right? Now I just type in df hyphen capital T. I can see the same file system. Okay. Now I just type in cd and just type the complete path name to access my file system, cd mnt fsfs1, and just type in, for example, ls. The same file system, the same text document shows up. I'm trying to retrieve the same text document that I created on the first instance. Now let's type in cat inter.txt, the same text shows up. So this means that this file system is a common storage for both instances. The document that I created and configured through the first instance shows up. I'm able to retrieve the same document through the second instance. This proves that the EFS is a common storage and it's linked with both instances. Fine, guys, done? Is it clear now? You're using the file system to link the file system with both instances at the same time. So the main output is the 28th step, right? This means that you're able to retrieve the same document from the second instance. Done? Great, wonderful, fine. And guys, once you're done, then you can terminate your instance, and also you can go to the EFS like this. Go to the EFS file system and choose it and click on delete. Then you can choose the name of the file system, copy and paste from here like this. For example, I'm copying the file system ID. If it doesn't shows me, I can copy the file system ID from here, click on delete, enter the file system ID, click on confirm. And after that, guys, you can just choose your instances and go to instance state and terminate. Fine. Okay. That's about the stuff. Let's get started with the load balancer now. What's a load balancer? What's the purpose of it? See, load balancer is a service that uniformly distributes the network traffic and workloads across multiple servers or a cluster of servers. So the purpose of the load balancer is very simple. It's quite simple. It ensures that it takes the incoming traffic from the front-end users and distributes that traffic evenly and equally across all the instances that may be running in different availability zones at the backend. Okay. Now, why we depend upon multiple instances? See, in AWS, we use a concept called horizontal scaling. What do you mean by horizontal scaling? Horizontal scaling simply means that instead of depending upon just one instance, we have multiple instances with the same software and hardware configuration. You understand the point? Instead of depending upon just one instance, we have multiple instances with the same software and hardware specs. That's what the purpose of the load balancer is. Now, it ensures that it takes the traffic from the front end users request. For example, you have deployed a website at the back end. That website is clustered and that you have a copy of web application running upon every instance. The load balancer takes the incoming traffic and ensures that it does the traffic management and evenly distribution of the traffic across the multiple instances running behind the scenes. So how it increases the availability and fault tolerance. For example, in this PPT, you have 3 instances. What if one goes down? You have 2. What if the second goes down? You still have 1 left. What if the third one also goes down? Then in that case, we can use auto scaling to fix that. Basically, load balancer means that it manages multiple instances, bind it together, and it performs an evenly distribution of the traffic across all those instances. Okay. Now, ELB is a load balancing service for AWS deployments. It scales itself. Now, why it's called elastic? Because it will scale itself as necessary to handle the load. So the purpose of elastic, why we use the term elastic, based on the amount of load coming in. So one must see the things that when we use the term load, we're talking about traffic load. What exactly we are referring to? We're referring to traffic load. So the ELB will scale itself. It will expand itself automatically or it will shrink. It has a capability to take care of any amount of load. The incoming traffic is distributed across instances in multiple availability zones. And one thing that's it only takes care of the incoming traffic, not outgoing. Outgoing is being sent back by the instances. See that the incoming traffic is being distributed evenly across multiple instances in multiple availability zones, right? You intentionally scatter your resources, your instances across multiple AZs. Now, in this case, load balancer is a single point of contact. It will take the traffic from the users and perform the equal distribution of the traffic among the instances that may be scattered and that should be scattered across multiple instances that running on data running in different availability zones. So that's what the purpose of the load balancer is. Fine. So that's about the load balancer. Now, I guess you understood what's the purpose of the load balancer is. Now, the thing is, the load balancer entertains the incoming traffic only. For example, in this PPT, you have 3 instances. Whichever instance gets the request from the load balancer, that specific instance will respond back to the user. Right. So whichever instance out of these 3 will get a request, that instance will get back to the user. Right. So the load balancer just performs an incoming traffic distribution. Once the traffic hits the instance or instances, the instances will get back to the user with the web page. Okay. So the load balancer it's not designed to handle the outgoing traffic. Okay. So let's get started let's discuss some basic concepts on the load balancer. Basically, you have to understand that how the ELB functions and what are the 2 main functions of the load balancer. Okay, so let's imagine that this circle represents your ELB. ELB stands for Elastic Load Balancer. We'll discuss the types of them afterwards. Right now, you just understand the basic stuff. And on the right side, we have, for example, a bunch of EC2 instances. For example, these are 2 instances bundled together, right? This is instance A, this is instance B. These are my EC2 instances. They're clustered together in same or different availability zones. Generally, we scatter them in different AZs. That's what our strategy is. Okay. Now, how the ELB works. For example, you have a website. So these instances have the web app running upon them. For example, you're running a simple WordPress site. Okay. Now, so let's imagine this is the internet user. He wants to browse your website. He will type in, for example, xyz.com. What's that? It's the domain of your website. Okay. Now, this xyz.com will translate it will get converted to the DNS name of load balancer, which is this one. Every load balancer has a DNS name, a special DNS name. I'll show you. It will get converted to the DNS name of the load balancer, right? So user types in xyz.com, Intellipaat.com, Facebook.com, Google.com. Behind the scenes, this will get converted to the DNS name of the load balancer. Now, for example, this request hits instance A, okay? right? Now, instance A will get back to the user with a web page. Fine. This is how the request is distributed. Let's suppose the next request goes to instance B, and the request is being sent by one user or a bunch of users. Then instance B will get back to the user. Okay. So in this case, a single user types xyz.com. The load balancer takes the incoming request, forwards it to one of the instances, and that instance will get back to the user with the response traffic or the web page. Okay. Now, apart from this type of normal type of request being forwarded by the load balancer, the other type of request that the load balancer entertains or initiates is the health check. See, the load balancer also performs a health check of the instances or instance, making sure that the health of the instance or instances I would say they're working to the.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Best of their potential, and if there's anything wrong with an instance, that instance is being removed from the group itself. For example, let's imagine. Okay, so what happens is load balancer initiates a health check. Okay, before we initiate the health check, this web application, it has different web pages. For example, index.html. The default page is the home page of this website is index.html. Okay, default web page of this web application. Now the load balancer will send the health check to this instance. Okay, it will ping the instance. So this is the health check traffic, right? And it will send it to a ping path. Now in this case, what's a ping path? We use a page that's running upon the instance, and we'll just use a ping path, this one, /index.html. Because for example, you just type in ping google.com, ping yahoo.com. After ping, you're using a website address. So I'm saying that this instance should ping the index.html page of the website or the web application running upon the instance, so that it can ping it and get the response out of it. Okay, now this health check frequency is 30 seconds by default. Every 30 seconds this health check would be repeated for every instance. Whether it's random or it is simultaneous, you don't have to worry about that. Basically, you have to understand that every 30 seconds the health of every instance is being gauged upon. Now, if the instance is healthy, what do you mean by healthy instance? Let's understand the definition of a healthy instance. What do you mean by healthy instance? First thing first, anything that's running, it's a running state, it's in healthy state. If an instance is stopped or terminated, can it be healthy? No, it's not fit to get back to the user with the response. It's running. The main thing is that it's running. The very first, if it's running, it's not stopped. It's a very first sign that it is healthy. Second thing is that the applications and services of that instance are responding. That's why we ping the index.html page, because it's the part of the website or the web application running upon instances. If the website is not running properly, then it's quite obvious that the index.html, if you ping the index.html page, it will not give any response. And it's running, the apps and services are responding. Yeah. And yes, of course, the another thing can be easy is up. The availability zone that is supporting that instance is up and running. It's not down. Fine. It's running. Apps and services are responding. The easy is up. And yeah, and it has passed 2x2 checks. Whenever you deploy an instance, you might have seen this thing. In the status check, it gets 2x2 checks. 2x2 checks means that the instance has passed some backend health checks to ensure that it's healthy. Okay. Now, if the instance is healthy, what it will do is, for example, this instance A will respond back to the user saying, I'm healthy. That's why I'm sending you this acknowledgement. 200 okay. So if the load balancer gets this response, it will say, okay, instance, you are healthy. So it will declare instance A as healthy because you are responding to me. Okay, you're responding to me. This means that you're healthy. You're running. The apps and services running upon you are responding. The easy is up, and you have passed 2x2 checks. So everything is good. So I will keep on sending the user's traffic to you because you're fit enough to get back to the user with the web page. Is this clear? So if the instance is healthy, it will get back to the user, and instance can respond back to the user. And if the instance is healthy, it will send back 200 okay acknowledgement back to the load balancer. Fine. Now, what if the instance is not healthy? Let's take another scenario. That instance is unhealthy. What if the instance is unhealthy? How you state an instance is unhealthy? It's opposite to the above points. The very first thing is that it is stopped or terminated. Anything that is stopped or terminated, how it can fulfill it, how it can respond to the user. It is terminated or it is stopped. Very obvious. If it is stopped or terminated, it is not in a state to take care of the web requests. It cannot process any of the requests. Fine. Then is that the apps and services are not responding. So the apps and services running upon the instance are not responding. Simple fact. The AZ, which is supporting the instance, is down. AZ is down. It is quite obvious that the instance is also down. Also, the instance has not passed 2x2 checks. If the instance doesn't get 2x2 checks, that state is called impaired. What's that? It is called impaired. If instance is impaired, this means that it is unfit. Fine. Sometimes if the instance is not, there's something wrong with the instance, it will show the instance as impaired. It will show the instance as impaired. Now, in this case, what if the instance is unhealthy? If the instance, for example, the instance A goes down, it's unhealthy. Might be it is stopped. Now, can you expect it to get back with this 200 OK message? The answer is no. If it's unfit, it's not running, it is stopped, it's terminated, the apps and services upon it are not responding, the AZ is down, it's impaired state. Will it get back to the load balancer with the 200 OK acknowledgement? The answer is no, because it's not in a state to respond back to the load balancer. How can it? How it can just go get back to the user with a web page? Because it's not responding to a simple health check. In this case, the load balancer will say, okay, instance A, you are unhealthy because you are not responding to my simple ping message, the health check message. This means that I should not send the traffic towards you. I should divert the entire traffic to another healthy instance, which is so I should be sending all the traffic to instance B only, not to you, because you're not responding. Basically, if both the instances are healthy, every instance will get the equal chunk of traffic. So if A and B are healthy, 50% of the traffic will be sent to A and 50% of the traffic will be sent to B. But because the instance A is, let's suppose, unhealthy, then it's the chunk of traffic that should go to instance A will now go to instance B. Right? So the chunk of traffic that the instance A was getting, that will be diverted to instance B now, because instance A is unfit. It cannot get back to the user with a web page. It does not respond to the health check messages. If instance B is healthy, okay, of course, instance B will get back to the load balancer with a 200 OK message. If instance B is healthy, it will get the entire amount of traffic. Okay, this is what's the crux of the basics or the functionality of the load balancer is. It performs an equal distribution of the traffic among the different instances that may be scattered, that should be scattered in different availability zones. If any one of this instance or instances go down, then it ensures that the other health instance or instances get that traffic distribution is done among other health instances, making sure that there's a continuity of your business applications. Fine. So it promotes high availability in this case. Fine. If you're getting 404 page not found, this means that all instances are not healthy. Maybe the configuration of the load balancer and the instance, it's not appropriate, or maybe there's a restriction in terms of the security group. So you have to look into the entire configuration. Maybe the applications or the website that you've deployed upon the instance, they're not responding properly. So you have to exactly find out that what is wrong. Some troubleshooting steps are needed, and based on that, you have to see exactly why you're getting the 404. So basically in that case, you have to look at all the levels: instance level, load balancer level, application level, security group. Everything needs to be checked upon. Maybe there's a problem with the DNS service. Your domain is not responding, so everything needs to be checked. If both are healthy, Yusuf, then we use auto scaling to deploy duplicate instances. That advanced concept we'll discuss afterwards. Now the thing is that if you see this diagram that we discussed with you, can you see this one? I discussed with you the basic concepts of VPC, where you have in a VPC you have different subnets. Each subnet is linked with different availability zone. Can you see that? This subnet on the left-hand side is linked with AP South 1A, and the second subnet is linked with AP South 1B. Now, different subnets linked with different availability zones, right? And these tests are deployed where? Inside the subnets. Now, where the load balancer resides? On the top. This is the load balancer, right? It receives the traffic from the internet and performs an equal distribution of the traffic among the instances running in different availability zones or subnets. So load balancer is free from availability zone selection. Basically, the right question should be, or the right approach is to understand this thing is that the ELB and the instances are in the same VPC. Okay. That's the stuff. That's about the basics of the load balancer. Now we'll discuss more theoretical concepts as we proceed further. But right now we need to understand three different types of load balancers, and we need to understand that what's the purpose of each one of them. Fine. Let's understand the types of load balancers and let's understand what exactly it's all about. See, there are three types of load balancers that we have: classic, network, and application. Fine. Now classic is now there's the fourth one that's added on, that's called a gateway load balancer. It's new in the list. Now the thing is that let's start with the classic. Classic load balancer is kind of discontinued. I think from 15th of August this year, this would no longer serve us. It will be discontinued very soon. Next few months. Basically, it's a previous generation load balancer. It does a basic job, takes the incoming traffic and route the traffic to healthy instances. Simple, right? But as I said before, it is kind of discontinued. It's not recommended that you use it. Even if you use it, then it can be migrated to advanced load balancers or new load balancers. So classic is a previous generation load balancer, not recommended now. It does the job, takes the incoming request and forwards those requests evenly to the instances running in the background in different availability zones. Fine. Now, the next level is the application. Now, application will work at the 7th layer of the OSI model. Now, what is this OSI model? Now, in networking, we use the term OSI. OSI stands for Open System Interconnection, right? OSI model consists of different layers. The last layer is the application layer. So in networking, we use this term called, so these are the 7 layers: physical, data link, network, transport, session, presentation, application, right? Now, the application load balancer works at the application layer. Okay, this means that it only entertains two protocols: incoming, HTTP and HTTPS. HTTP and HTTPS. So only two types of requests it can handle: HTTP and HTTPS. Fine. Now the application load balancer also has the capability to understand the content of the request and accordingly send it to a group of instances. Okay, it's called content-based routing. It's called path-based routing. So based on the content of the request, this load balancer is designed to route the traffic to a group of instances. For example, let's imagine if the users are sending the request to browse the documents, then the request for the documents should be sent to this instance or these instances or a group of instances running in this subnet or a group of instances. If the users are requesting for let's suppose JPEG images, then the request should always be forwarded to the JPEG or instances that will serve or get back to the user with the JPEG images. So if the user request contains .docs keyword, so it will look for the keywords. So in the URL or based upon the content of the request, if the user is asking for the documents, the request is sent to a group of instances. But if a user is asking for JPEG images, it's being sent to another group of instances. This is called content-based routing or the path-based routing. So based on the content of the request, it can divert the traffic. So the application load balancer is designed for these type of capabilities. It also works for microservices like containers. It also works for Lambda functions. Lambda we'll discuss afterwards. So it's a very advanced load balancer. Fine. The third type of load balancer is network. Now network you'll not use everywhere. It's a very robust load balancer. It's the fastest, very high performant. It's kind of a Ferrari of the entire load balancer fleet. Give you the fastest performance, best performance. It has a capability to handle millions of requests each second with ultra low latencies. It can handle millions of requests per second and it can maintain ultra low latencies. Fastest of the entire lot. If anything that you get for fastest, or it is the costest of the entire lot, right? Now this works to the fourth layer. Fourth layer is a transport layer. If you see the OSI model, fourth layer is the transport layer. This layer, fourth layer. Fourth layer is a transport layer. Okay. Now this is the only load balancer that supports static IP or elastic IP. This is the only load balancer that supports static IP or the elastic IP. Fine. So that's the purpose of the load balancer. It ensures that the network load balancer, it ensures that in any case, if you need to handle millions of requests each second, for example, let's imagine you have an e-commerce platform on Big Billion Day sale, Independence sale, Black Friday sale, Christmas, New Year sale. Let's imagine that You expect millions of users browsing your e-commerce website every second. Maybe you have ran big promotions. You're offering huge discounts on your products. So in those cases, for example, there's a live match between India and Pakistan. Hotstar is expecting millions of users coming in or accessing or live streaming the match per second. So millions of users are coming in, or they're trying to access the or stream the video, and the Hotstar, being an OTT platform, need to keep up. So in that case, they'll be using the network load balancer. Fine. So that's what the purpose of the network load balancer is. If there's a requirement where there's an expectation of millions of requests being established per second, this is the best one. Okay, so it can handle that type of load while maintaining very less latency. Right? So you not use that in every use case. Why there's a need of a manager on the top of a team of 10 people? For example, I work in a team of 10 people and I have a manager on the top. Right? The main job is done by the engineers or the IT people in that group of in a team of those. So all the 10 people, they do the job. Why the companies hire manager on the top of us? Because to manage and distribute the work, ensuring that we work in collaboration, the work is distributed evenly, and according to our skill set and job profile, we get the amount of work that we have to do on daily basis, and that work is collaborated and coordinated properly by the manager. Right? That's why he's paid for. He does the management of the work across a team. Fine. Similarly, a load balancer is a traffic manager. If you have multiple instances running behind the scenes, who will manage them? Who will manage the traffic distribution between them? The manager does the delegation of the work for the people under him. Similarly, load balancer will do the delegation of the traffic, equal distribution of the traffic across multiple instances at the backend. It is not just for the lessening the load on one instance. It is to promote high availability. Let's suppose on a PPT you have 6 instances. 3 instances are in availability zone A and 3 instances in availability zone B. Let's suppose the availability zone A goes down. You lose all the 3 instances. Now, the entire traffic should be sent towards the 3 instances in availability zone B. Now, who will do that? Load balancer. The traffic rerouting, traffic distribution, traffic management, health check is done by the load balancer. It does the job of a manager, making sure, okay, let's suppose that you have a traffic police, right? You have a very congestion of the traffic across the different roads nearby. What a traffic police does, he ensures that he clears a traffic jam, making sure that the vehicles are not being stuck on the road itself. And in this case, he ensures that the cars they run properly on the roads. There is no traffic jam. Similarly, load balancers ensures that there is no stacking of the load somewhere. The traffic is distributed evenly, making sure that every instance gets an equal chunk of traffic. If any instance goes down for any reason, it performs a rerouting of the traffic to other healthy instances automatically without you doing that, and ensures that every instance gets an equal chunk of traffic. It can function properly, it can work properly. If a chunk of instances or the availability zone goes down, it reroutes the traffic to another group of instances or availability zone which is healthy. Fine. Okay, you understand the point. Because in a robust architecture, you not okay. Let's suppose if you don't use load balancer, use only one instance. Now, what if that one instance goes down? Your entire application goes down. So in this case, we use multiple instances with the same applications running upon them. We don't depend on just one instance. We depend upon, for example, 10 instances, 20 instances, 100, or even thousands. For the traffic management, the ELB is needed. There has to be some authority on the top who does the traffic management. Fine. That's about the stuff. Okay. That's about the theory behind the ELB. Okay, so let's start with the next stuff. That's the auto scaling. Let's get started with that one. See, what is auto scaling? What's that all about? Let's understand that concept. Because auto scaling is an add-on feature compared to, or I would say, if you add-on feature of the ELP or the load balancer. What's auto scaling? Auto scaling is a process of adding or removing the capacity or the resources as needed. Okay, before I just go to the slide itself, let's understand this thing. The ELP performs the health check, and based upon that, it performs the traffic distribution. Okay, we discussed that. We understood that concept properly. Now, let's understand this fact that before A went down, A was getting 50% of the traffic and B was getting 50% of the traffic. But after A was completely down, the entire traffic load is sent to just one instance, that's instance B. We have lost half of the capacity. We had two instances before. Now we have one instance. We have just 50% of the capacity. So with just 50% of the capacity, the entire traffic management is done. Traffic load is being put on just one instance, entire load. So one instance is doing the work of two instances. One instance is doing the work of two instances. In this case, what will gonna happen? Maybe the instance B will stop responding after some time. Maybe the application will run slower now, right? Because if one instance is doing the work of two instances, either it will go down after a few minutes, or it will respond slowly to the web traffic coming in. So basically, this is a kind of a situation where even after the load balancer has performed the high availability, making sure that the request goes to the healthiest is only, we are still stuck in the situation where we need some solution to ensure that if we are left with very less capacity, how to take care of that. In this case, I don't want to ensure that instance B is over exhausted and it will shut down after some time, or it will stop responding. Okay. As a fix, we use something called auto scaling. Auto scaling has a capability to automatically deploy the instance or instances if there's a requirement, or there's a need. So auto scaling, for example, will launch a duplicate instance A, and the load balancer will start sending 50% of the traffic to it automatically if we link the auto scaling with the load balancer. So basically what auto scaling does is that it ensures that you always have the right capacity up and running or available to take care of the entire traffic load, or to take care of the requests. It always ensures that there's always the right capacity to in your architecture to support your application. So auto scaling will deploy the instance A or a duplicate instance with the same software and hardware specifications, while making sure that you always have the full capacity. Your resources run on the full capacity without compromising in terms of the quantity of servers that you need. So in this case, scaling is a process of adding, auto scaling is a process of adding or remove the resources as needed. It can also add the resources, it can also remove the resources, right? Now, for example, let's imagine if I go back to the same page, the same diagram, because we need two instances, the auto scaling will deploy instance A or a duplicate instance to make sure that we always have the right capacity. What if we don't have that amount of traffic coming in? In that case, auto scaling can shut down one of the instances. For example, let's suppose from 9 a.m. to 6 p.m. you need two instances, but after 6 p.m. you just need one instance. So auto scaling ensures that it can also remove the resource or the instance if there's no requirement for that. We'll discuss that. So auto scaling can easily increase the number of instances or decrease. Now, if the auto scaling, okay, so we use two terms over here. One is scale out. What do you mean by scale out? So the first term that I'm going to use is called scale out, right? So we are discussing the next concept that's called auto scaling, right? Let's try to understand this concept. Fine. So I'll discuss with you different use cases. What's auto scaling? Auto scaling is a feature which is based on the principle of elasticity. What is elasticity? Elasticity means that you can increase or decrease the number of instances based on the patterns of the incoming traffic, time of day, and the demand. Okay, so elasticity is a principle which helps you to scale out. What do you mean by scale out? Scale out means increasing the resources. Or in context of AWS, it's launching your instances, launching additional EC2 instances because there's a high demand. Maybe, for example, if we deploy the number of instances, so it's called scale out action, which means that there's a need to increase the number of instances. Then the next thing that you can do is scale in. Scale in means that removing unwanted resources. In this case, it will be terminating the instance if there's no requirement of extra instances. Fine. So auto scaling works on the principle of elasticity. It can scale out or scale in based on three main criteria. What's the criteria? One is patterns of the incoming traffic. I'll give you some examples on all the three criterias. So patterns of the incoming traffic. The second one is time of day, right? And it's called scheduled actions. Sometimes you call it based on the schedule, or there's a high demand, or low demand. Based on that, it can scale out, it can grow or shrink the number of resources, it can grow or shrink your architecture. So auto scaling is the concept based, it's a service based on the concept of elasticity. It can scale out or scale in, increase or decrease the number of resources based on the patterns of the incoming traffic, time of day, and the demand. Okay, so let's try to understand that how this functions. Let's imagine that. So let's take few examples over here to better understand it. Let's take the first example. The first example is very simple. Let's imagine that you have a bunch of users coming in. These are your users who are trying to access your application. Fine. Now you group the instances in a container. You group the instances in a container that's called auto scaling group. Auto scaling group we'll discuss in detail afterward, but it's a collection of identical instances, right? So it is, for example, my auto scaling. Okay, let's imagine it consists of two instances as of now, instance 1 and instance 2. Fine. Now the users will send the request to the auto scaling group or auto instances. Now what happens behind the scenes is that we can say that based on the number of requests coming in, these instances will process the request. Now I would say if the collective CPU utilization of the entire group, or on an average of both instances, is less than equal to 30%, in that case I'm completely happy with just two instances. I don't need more than that, which means that there's a less amount of traffic, less amount of processing. By the instances, the CPU utilization is kept to minimal. In this case, I don't need more than two instances. But what if the users grow in size? They start sending a lot of traffic to my auto scaling group. Now, these two instances have to process a lot of traffic. So in this case, the CPU usage, for example, in this case, the CPU utilization has gone up 70%. So I would say, okay, I need 6 instances now. And auto scaling in this case will add 4 more to make it 6. This is the demand. Based on the demand, then it will increase the number of instances. Now, once the CPU utilization dips down, it will come back to 2 instances. If the CPU usage comes down less than 30%, it will terminate 4 instances and get back to the original size. Fine. It can grow or shrink the number of resources based on the patterns of the incoming traffic and the demand. Next example, I can take some more examples. For example, I would say, let's imagine I'm running an e-commerce site. Okay. Now, during normal days, normal means that there's no big promotions going on, no sales going on. I'm happy with 50 EC2 instances. Okay, it's more than sufficient for supporting my e-commerce platform. But during, for example, let's imagine Christmas sale, which, for example, I start from 20th to 25th of December every year. Because I run big promotions, big advertisements, and because people are in holiday mood, they make a lot of purchases. For example, I need 500 instances now to support that requirement. Because there's a huge amount of traffic coming in, the number of users will grow, the traffic will grow. I need more instances to support that. Once the sale is over, it will shrink back. Fine. This type of capabilities can be only achieved by the auto scaling. Fine. Or for example, I can say example 3. Let's suppose we're running in-house business applications. In-house business applications means that your ticketing tools, your internal content management system you're running in-house business applications. Fine. Now I can say from 9 a.m. to 6 p.m. UTC, I need to have 100 EC2 instances because my employees will be accessing my resource, my business applications. I need these many instances to support my business applications, my business requirements. Okay. Now after 6 p.m., people will leave the office. 6 p.m. to 9 a.m. next day, because there will be very few people accessing the business applications, I can say I just need 10 EC2 instances. And once the next day starts, add 90 more so that I have a fleet of 90 instances. And once you come back, initiate a scale in event and subtract 90 instances. So based on your requirement or the time of day, it can grow or shrink the number of instances automatically. You understood these 3 different examples. So these are the three examples that I've given to you to better understand that the first example I've given to you, if there's a less capacity, it will deploy another instance to make sure that you always have the right capacity of the instances. Second scenario is that, for example, if the CPU utilization of the instances go up, it will increase the number of instances. If it goes down or kept to a minimal level, it will maintain the healthy number of instances, for example, two in our case. E-commerce site, in-house business applications. So based on the needs and the requirement, the demand and the patterns of the incoming traffic, it can increase or decrease the number of instances automatically. Increase means scale out, decrease means scale in. Is the concept clear? Because once the concept is clear, then I'll discuss with you the concept of the components of the auto scaling. Fine. So now let's discuss the auto scaling components. Very important. Let's discuss the components now. I think components are there in this slide itself. I don't have to draw them out. Okay. The very first component of the auto scaling is called the auto scaling group. What's auto scaling group? Auto scaling group is nothing but it's the collection of identical instances. You need to group them together in an auto scaling group, right? You need to group them together in an auto scaling group. They're exactly the same.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
They have the same hardware specifications, same instance type, they have the same AMI, same operating system, same platform, same applications running upon them. So the identical instances in the form of hardware and software specifications, you group them together in the form of an auto scaling group. So the simple definition of the auto scaling group is it's a collection of instances that are exactly the same in the form of hardware and software specs. Fine. Now, the next thing that comes into the picture is that the instances are launched in the auto scaling group, but who decides that what should be the hardware and software specifications? See, for example, let's imagine that you're a cook. You're a cook and you want to prepare red sauce pasta. Okay, you haven't prepared that before. You open a recipe book, or for example, you browse YouTube and see and want to just go to the videos that how to cook or prepare a red sauce pasta. So in this case, the very first thing that you will, if you book a recipe book, the very first thing that it will show is the list of ingredients, the spices, the vegetables, the ingredients that you need to create that, to prepare that. If you don't have the list of ingredients with you, then how you can make pasta? Similarly, auto scaling, how it will get to know. For example, auto scaling wants to scale out. What's auto scaling is a service, right? It doesn't have the brain of its own. You have to give it a set of instructions. It wants to scale out. What do you mean by scale out? Launch the instances. Now, basically, we have to give it a list of items saying, okay, auto scaling, this is the AMI of our instance. This should be the AMI of the instance. So you give it an AMI ID. This should be the instance type of all the instances. Now, of course, AMI includes everything. OS. So if I talk about AI, it includes OS, apps, services, etc., etc. The software configuration has to be mentioned by AMI only, right? OS, app, services, instance type, security group. It's a list of ingredients that we give it to it. EBS volume settings, maybe key pair. Fine. Now, basically, we are saying that so auto scaling wants to scale out, take this scale out action. It wants to initiate the scale out action. What do you mean by scale out? It needs to launch the extra instances. Launch additional EC2 instances. Now in that case, it needs the AMI, the instance type, the security group, the EBS volume settings, and the key pair, right? What is this? This is the list of ingredients saying, okay, auto scaling, you want to increase the number of instances. This is the list of ingredients. Now, these ingredients are being taken into account and the instances are being launched where? In an auto scaling group, which is nothing but it's a collection of identical instances. This is my auto scaling group, a collection of identical EC2 instances. They have the same AMI, same instance type, same key pair, same security group. So my instances are collaborated or they're collected in the same auto scaling group. So these are my identical instances with the same hardware and software specs. Do you understand this point? Without the launch configuration, So this entire configuration is done by which component? We templatize it. We create a template that's called launch configuration. We need to create a template first before auto scaling can decide that what should be the hardware and software specification of the instances to be launched in the auto scaling group. So a launch configuration is needed to create a template based on which auto scaling can decide that what should be the hardware and software specifications of the instances. Fine, without which it will not function. You have to list of ingredients. If you don't have the ingredients, how exactly the auto scaling will understand that what should be the AMI, the instance type, the security group, the key pair, the EBS volume settings. See, the services that we're working on right now, they don't have the intelligence on their own. We have to give them the list of clear instructions. This is the automation only. But before the automation happens, we have to say them, okay, this is what you have to do. This is what you have to apply. And these are the conditions. You have to set the prior conditions. Based upon that, you automate the things. The same stuff applies over here. Okay, fine. So the launch configuration is a template that's used to launch instances for the auto scaling purpose. And you need to define the image ID, the AMI ID, instance type, storage devices, everything. Fine. Now this is the same thing I've discussed with you. For example, scaling policy. Okay, for example, scaling based on the CPU usage. If the CPU utilization is more than 80%, increase the number of instances. And for example, based on the schedule, based on the time of day, you can increase or decrease the number of instances based on the schedule or the demand. Fine, that's already discussed with you. So if the CPU usage is high, I need more instances. If the CPU usage is less, I need less instances. Based on the time of day, I also decide that how many instances I need. Fine. As of now, this is all about the auto scaling theory that I want to discuss with you. The more concepts will come forward once we start doing the implementation. If you work in a company, there's nothing called out of anything that's happening unexpectedly. See, if you work with a closely with the software architects and the people who are experienced working in this industry, they have the rough estimate that okay, what's the maximum number we can reach. It never happens that you're expecting 1,000 and next day you need 1,000,000 instances. It never happens. Based on your business requirements, you have the rough estimate that what's the maximum number you can reach. Okay. For example, if there's a high traffic demand, high traffic load, let's suppose I expect 100 instances. At the max, it will go to 200, 300. It will not go up to 1,000,000 instances. So in any business use case, the things are done in a very planned way. If you think that, again, I'm saying there's a high load than expected, I'm again putting the same answer forward. The maximum number can be increased. You can tweak those settings. So for example, I set 100 as a maximum instances I need where there's a high demand. But when I monitor my incoming traffic, then I think that 100 are very less. I need to make it as 200. So I just need to change the number in the configuration. It's just a matter of just 1 second only. It takes 1 second to change the number. I change it to 200 and then it can be done. So in the first few weeks of your business deployment, you have to do the close monitoring and understand your business requirements and needs, right? Again, I'm saying if you're working in a company, nothing happens by chance. Very proper planning is done. And if there's a variations in terms of expectations, those can be changed on the fly. So your maximum number of instances can be increased in just a matter of 1 second only. That's it. So guys, the thing is that if you open this document, this is a kind of a case study and a project. Depending upon that, we need to scale up or scale out the number of instances based on the a lot of demand that's coming in. So, for example, Hotstar is a streaming service. Yeah, it's an OTT platform. Now, let's suppose there's a match between India and Pakistan, or there's a football match or FIFA match. Now, the thing is that because millions of users will join and access the Hotstar platform, they want to deliver the jitter-free experience or latency-free experience for their users. Fine. So in this case, they can be using the concept of auto scaling to ensure that based on the number of users joining or accessing the Hotstar platform and streaming the match, they need to increase or bump up the number of instances if there's a high peak in the demand. Okay. Now, the tools that we need to perform this hands-on are the following: CloudWatch, auto scaling, EC2, and ELB. Okay. These are the 4 tools that we need to perform this hands-on. And what's the first step? See, the very first step is one thing I want to apprise you of, that everything in this hands-on will be free of cost except one thing. That is, you have to create an AMI, right? So in this process, I also let you know that how you create a customized AMI, right? So because when you create the AMI, an 8 GB of snapshot would be created. I think you have to pay 20 or 30 cents for that. So the total cost of this hands-on would be somewhere around 30 cents, right? You can convert that into Indian national rupees. So it's less than $1 because you have to create a snapshot of 8 GB at the time when you create an AMI, a customized AMI. There's a small charge appended, somewhere around 20 cents maximum, not more than that. So 20 cents or maximum 30 cents would be the cost of this hands-on. Fine. So it was my responsibility to make you familiar with the expected charges. Rest, all the pieces or all the components that you're going to be deploying are absolutely free. Okay. So what's the first step? So the first step is that you have to deploy a demo web application on an Amazon EC2 instance using the script that's been given to you. Okay. The process will be the same as we have already seen in the IAM. I'll just walk you through a few steps. Then I'll give you enough time to do it by yourself. You see what I'm doing? Get the knack of the concepts, understand what exactly I'm explaining at the time when I'm doing some hands-on. Once I'm through with few steps, for example, first to 10 steps, first to 8 steps, then I'll give you sufficient time to do it by yourself. Okay. So why we want to deploy demo web application? Because generally the applications are deployed by the auto scaling, because we want to carve out or create a custom image first. If you remember, we discussed the customized image. It shows, if I go to EC2, let me show you that. If I go to EC2, and at the time when we deploy the instance, we choose the AMI. For example, if I just go back to instances right now. If I go to launch instance, on the left-hand side where it says step 1, choose an Amazon machine image or the AMI, you have the My AMI section on the left-hand side. Can you see that? This is the My AMI section. Now, this is where a business or a business organization will maintain a complete repository of its own business applications AMI or its own customized images, right? Now, what's the process to create the customized image? You choose a raw image. These are raw images only. Now, these are not customized. You install something upon it, configure a few things. If there's a lot of configuration needed, if you install software, scripts, everything upon a single instance, and then you create the image out of that instance. That image would show up under the My AMIs that you can use as a custom AMI. So the process first one would be to deploy a demo web application. Now, to deploy a demo web application, there's a bootstrap script. Okay. Either you can just download from the link provided, you can see that, or if you just go to the folder, there's a script showing up. Now, it is extremely important. Now, this is where the people make this blunder. Don't copy and paste the script from the browser. Don't do like this. Open this like this, because I think because we are quite lazy, we say, okay, let's open the browser and let's copy and paste from here. No, because if you copy and paste it from browser, it would include some extra spaces. The script will not run properly. You have to right click on the script and click on download. So you're going to be using the script to install a demo web application upon the instance, so that from that instance you can create a custom image. Fine. So to create the custom image, what you do, you take the raw AMI, quick start AMI, install everything upon that instance. So you deploy the instance using a quick start AMI, install everything upon it, and then create the image out of it. See what I'm doing? So I copy the script like this. I've downloaded the script. I just copy it, go back to the instance dashboard. So let me just turn off the instance or terminate that instance that I don't need. So I need to search for EC2 service. Yeah, you need to just go to EC2. So I'm just showing from the very beginning. Once I just go to the EC2, I click on launch instance. Fine. Now, if you see a different dashboard, you have to check mark opt out of the new experience, right? It's a beta version of the dashboard. I'm not sure whether they will push it or not. So this is the dashboard. This is how the dashboard should look like. Now, you're going to be picking the Amazon Linux 2 AMI. Click on select. The same instance type that we choose, t2.micro. And then on the third step, you don't have to do anything, just paste the script. That's it. On the third step, under the user data, we have performed this step when we perform the EC2 lab. You have to copy and paste the script. Make sure that you download the script first. You open that via the notepad or any text editor on your computer. You copy from the text editor, and paste it in the user data. Please don't copy and paste directly from the browser. Fine. Now you just click on the review and launch. You can proceed without a key pair. Now, why we're proceeding without the key pair? We don't need to SSH to this instance. Pure purpose is just to install the Apache web application upon it using the script. So this script will install the Apache web application upon the instance. Okay, I click on launch instance, and that would be done. Fine. So the steps that you have to perform would be from first to 8. Take your time and let me know once you're done. Okay, great, wonderful. Now, see, the thing is that the intent of deploying this instance is purely simple, making sure that you can just deploy a web application. Now, how to test this web application? That's the other stuff that we have to do. We have to just make one tweak into the security group of the instance just to test the web application. I show the step from 11, 17. See what I'm doing? And I give you enough time to do it by yourself. Steps 11 to 17. See what I'm doing? I just go back to the instance page where my instance was launched. Okay, this is my instance. Okay, by mistake I chose Oregon. That's fine. Now you need to choose the instance first. Go to security. Under security, we have this thing called security groups. Remember what is a security group? It's a virtual firewall through which we can restrict the incoming and the outgoing traffic with respect to the instance or instances. So while checking the instance, I go to the security. I just went to the security groups and click on that. Okay. Now in the inbound, it includes SSH from anywhere. We don't have to worry about it. Click on edit inbound rules, and we have to just add on one single rule. So I click on add rule, which is the HTTP from anywhere. You can choose anywhere IPv4, anywhere IPv6. It doesn't make any difference. Okay. Click on save rules. Now, why did we include the HTTP from anywhere? Because then we need to check the website or the web application that we have deployed upon the instance. So how we'll check it? We'll go back to the instance, copy its public IPv4 address, and paste that in the browser. If you get this web page, this means that your demo web application has been deployed successfully upon the instance. The steps are from 11 to 17. Please follow the steps and let me know once you're done. See, we produced this instance. We created this instance with the Apache web application running upon it. The next thing that we did is that we tested it that the web application is being deployed properly, right? Now the time has come to create or manufacture the image out of it. It's a time to create the image out of it. Why it is important to create the image out of it? Because that image will be a custom image now. Fine. So the steps that I'm showing you, it's only 1 or 2 step procedure, 18 to 20. So guys, the next thing is that we have to create an image. Steps number 18 to 20. Guys, please, it's my humble request. Please follow the document. You have 22 hours after this hands-on. Do whatever you want. Okay, at least for this 2 hours, follow the document. Okay. Now we need to create the image out of the instance. How to do that? The instance is running. The web application is deployed successfully. You have to go to instance actions. Go to image and templates. So you have to go to the actions, go to image and templates, and click on create image. Okay. What's the image? It is an image that defines the programs and settings that apply it when you launch the instance. It is a collection of software, scripts, programs, operating system bundled in a single software package. We name it as, for example, Apache HTTPD image. Okay. Now you can put it in the description or you can just leave it as it is. Now, when you create the image, now please understand what I'm trying to convey right now. When you try to create the image from the instance, it also takes the snapshot. Now, snapshot is nothing, it's a backup. We're going to discuss the snapshot in detail. The backup of the EBS volume, the storage linked with the instance. You can see that during the image creation process, the Amazon EC2 creates a snapshot of each of the above volumes. So it creates a backup of the volumes. Okay. So this 8 GB of backup will cost you 20 cents on an average. Okay. Now you don't have to change anything over here. And yes, Ravikran, we're creating a custom image. So an image or AMI, we have discussed that it is a software package that consists of our custom programs, scripts, software, operating system bundled together in a package. Okay, click on create image and this will issue the command to create the image. Now, if you just go to AMIs on the left hand side, you're going to see that it's in the process of, it is pending right now. Okay, and if you just go to the snapshots on the left hand side. Now, if you don't go to the snapshot, that's okay. It will also show you the snapshot in next few seconds. But the main thing is that your AMI process should initiate. Please let me know once you're done with the steps number 18 to 20. 18, 19, 20. Now, the next thing that you're going to do is to create a target group and the application load balancer. Explain you what a target group is, and I'll show you the steps number 21 to 25. See what I'm doing? Don't do it right now because I will explain you few things in the midway. Steps 21 to 25. Okay. So what are the two steps we have done? We deployed a demo web application upon the instance, and we manufactured the image out of it. Okay. Now the image is kept aside. We'll be using it afterwards at the time when we use auto scaling. Okay. Now what you have to do is you have to ensure that you create a target group and an application load balancer. First thing first, we'll create a target group. What's a target group? A target group is nothing but it's a collection of multiple targets. Those targets can be instances, your Lambda functions, your IP addresses, or some other load balancers. We group the identical targets or the instances in our case. So how we do that? On the left hand side in the navigation menu, we have the load balancing. It's been divided into two different chunks, load balancers and target groups. Let's go to the target groups. Let's go there. Now, once we just go to the target groups, the next thing that it asked me that, okay, once you do that, I click on create target group. Fine, I don't have that any as of now in this region. It says your load balancer routes the requests to the targets in a target group and performs health checks upon them. Did you remember we understood the health checks of the load balancer? If I open this document, I guess if you remember, we discussed about, so on the right hand side, if you see, the load balancer, the elastic load balancer performs the health check towards the instances. It will ping the instance or instances every 30 seconds. The elastic load balancer will ping or perform the health check towards the instances every 30 seconds by default. Now, if the instances are healthy, the points are already documented. What do you mean by healthy? What do you mean by unhealthy? If an instance is healthy and the load balancer has sent the health check message to it, the instance will get back to the load balancer. It will acknowledge to the health check with a 200 OK message. If the load balancer gets that message back, it will label the instance as healthy and continue sending the user's traffic to it. Okay. Now, because this health check needs to be performed, it needs to be sent somewhere. In this case, it will be sent to the index.html page of our web application. Because we are using this script, we use this script to install the web application. What's the page, the root document of the web application? Index.html. So we'll be sending the health check message to the index.html page of our website or the web application running upon the instances. Fine. So having said that, I go back to the target group page. It says, what's the target type? In this case, it would be the instances. Okay. Now, this can work with Docker containers, IP addresses, Lambda functions. We'll discuss all these advanced details afterwards. But as of now, the targets that we should be working on would be the instances. It says, could you please assign a name to it? I name it as HTTPD target group. Okay. Now it says, what's a port and protocol you want to allow to hit your targets? It's HTTP port 80 because this is the default port to access our websites. You don't have to change them. Don't change the VPC. Don't change the protocol version. So guys, whichever step is not mentioned in the document, you have to skip that because I would say 50% of the things that we go through, they're default settings. We don't have to change them. So whatever is default, I've skipped that on the document. Okay. You don't have to change the VPC. You don't have to change the protocol version. There's no need for that. Even in the business use case, the main thing that you ought to change is the health check path. We choose a protocol to perform the health check towards the instance. You always use HTTP, and the health check part would be /index.html. So I'm saying ping the home page of my website running upon the instances. Fine. Okay. You can tweak the advanced health check settings, but you don't have to change them. Basically, just in case you want to change anything, you can change the health check interval. This means that what's the default timer or default time frame after which the load balancer will perform or repeat the health check towards instances. By default, it's 30 seconds. You can bring it to minimum 5 seconds or 300 seconds. If you want, just in case in a business environment you want to change it, you can, or you can keep it to default. This is the time value, or this is a time frame. So by default, every 30 seconds, the load balancer will perform the health check towards the instances. Generally, you don't change them. The maximum thing that you can change is the health check interval. Rest all the things are it's of not that much of importance. So we not change the advanced health check settings. The main thing that we have to put in is the health check path. Click on next. You don't have to do anything over here. Okay, click on create target group and please let me know once your target group gets created. Just type it down. I hope that I've explained you that exactly what is this all about. Fine. And I guess someone was asking for me to explain this stuff. I've already explained you now. Okay. So we have created this target group. It has been done successfully. Guys, one thing you can do is that you can terminate that instance now. Okay, one thing. Please go back to the EC2 dash instances and terminate that instance now. You don't need it anymore because the purpose of that instance is to create the image out of it. Okay, you can choose that instance, go to instance state, and please terminate that instance. You don't need that instance anymore. Please terminate that instance from which you created the image out of it. That instance is no longer needed. Please terminate that instance now. I want to make sure that you don't leave anything running, adding the cost to you. Please terminate the instance. You don't need that now. Please go ahead and terminate that instance now. Okay. Now, guys, the next thing that we're going to be doing would be we shall be moving on to the next step, creating a load balancer and linking this target group to the load balancer. Now, creating a load balancer is a bit complex. I'll show you the first few steps, step number 26 to 29. Okay, steps 26 to 29, steps 26 to, okay, so what I'm doing is I go to the load balancers on the left hand side. I don't have any load balancer as of now. I click on create load balancer. What I do is that I click on create load balancer. Now, once I hit create, it says what type of load balancer that you'll deploy. We have 4 load balancers at our disposal: application, network, gateway. Classic one is the previous generation. You can see that it will be retiring this thing from 15th of August this year only. So generally, it's not recommended that you use classic. Use either of these 3. The one that we're going to be using for this hands-on would be the application load balancer. This is the one that we shall be using. Okay, so I click on create under the application load balancer. Let's go there. Now, once we hit create under the application load balancer, the very first thing it will ask you is the name to be assigned to it. I name it as HTTBD ELB, anything you want to just put in. Then it says, what's the scheme? Will it face the internet or it's purely used for internal purposes? Sometimes you don't expose your load balancer to the internet users. You just use it for the internal operations. I would say in 95% of the cases, your load balancer would be internet facing, where it will receive the traffic from the internet and distribute that traffic to the instances at the backend. So we keep it to internet facing. IP address type. So it's saying, are you using the IPv4 address? IPv4 addresses are out of 32 bits. Dual stack means IPv4 and IPv6. Now, IPv6 addresses are out of 128 bits. It's in hexadecimal format, right? So the IP addresses that we're using right now is the IPv4, right? We're playing around with the IPv4 addresses. So you can choose either of these two. It will not make any difference. We'll stick to IPv4 because we're using the IPv4 addresses as of now. Okay, so it is a load balancer with a scheme internet facing. IP address type that we want to entertain. So because the subnets that we are using, they're using IPv4 addresses only. Okay. Then as we proceed down below, it says, do you want to choose a VPC? We will not choose any VPC as of now. We just stick to default because everything is contained in the default VPC. So there's no need for change it. The main thing that you have to change is the mappings. Mappings means that you choose at least 2 availability zones under the load balancer. For this hands-on, please select all the availability zones /subnets. What we're doing is we are saying we want the load balancer to route the requests or the traffic to any instance deployed in any one of these 4 or 6 availability zones that you have. Okay, please select all the availability zones. Okay, and these are the subnets linked with those availability zones. Subnets are linked with availability zones at the backend. If you remember, we discussed that in the notes itself. Can you see on the left hand side there's a diagram? This is the VPC on the left hand side. VPC consists of the subnets. Subnets are linked with the availability zones, and you have the load balancer sitting on the top of them. So the load balancer, the instances, the subnets are cocooned in a single VPC, a virtual private cloud. Fine. So going back to the same page, yeah, steps. So this is what we have to do. Steps number 26 to 29. Yeah, please let me know once you're done. Now, what's the next step? Now, this step is step number 30. Now, this is, even though this step is simple, this is where 50% of the people get confused. I'm not sure why. Basically, you have to create a new security group for the load balancer. Now, the problem in this case is that it opens a new tab for you. See what I'm doing? Don't get confused. I'm showing the step number 30 to 35. See what I'm doing? Because this is where people start making the mistakes. See, because the load balancer is exposed to the internet, it is very important that it should be assigned a security group. Okay. What you're going to do is you need to go back to the security groups page. This is called security groups underneath. Click on create new security group. Now see what happens. Once you click on that, it opens a new tab on your browser.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
This is where people confuse. They start saying, okay, where's the load balancer page? It opens a new page for you, a new tab for you. This security group will be assigned to your load balancer. So you name it as, for example, ELB or Elastic Load Balancer Security Group. You assign a name to it. Okay. And you just mention something in the description. Don't change the VPC. Please add a new rule where you allow the HTTP from anywhere IPv4, anywhere IPv6. Don't change the outbound. So this is a security group that you have to create for the load balancer, making sure that you allow the HTTP access from anywhere. Now you add a tag over here, and the tag would be the same name that you assign to the load balancer. Fine. Now click on create. Now this will create the security group. Now this is what you have to do. You have to switch back to the load balancer tab. Okay. Remove the default security group like this. There's a refresh button you can see on the right hand side. Hit refresh, and this is where you need to select the security group that you just got created. Okay. Half of the people get confused over here because the new tab opens up. They're stuck between two tabs where I have to create, where I have to apply it, where I have to create it. It opens a new tab. You create this security group, come back to the previous tab and apply it. Now I'll show you steps number 36 to 38. 3 steps. To complete this, we just go back. Okay. Scroll down. Under the security group, it says listener routing. Listener is a process of listening to the request. So I'm saying, please use this protocol and port to listen to the traffic and forward it to the target group that we created in the previous step. So this target group is created beforehand. It will consist of my targets or the instances. Okay. You're going to scroll down and click on create load balancer. Let me know once you're done. You simply need to select the target group, scroll down and click on create load balancer. Click on view load balancer and your load balancer would be created. It would be, the state would be provisioning. Done. So let's start with the next step now. Now the next 2 or 3 steps that we follow along are the main steps, because now we have to start configuring the auto scaling. So we've discussed auto scaling in the previous class. It's a process of automating, of launching and terminating the instances based on the patterns of the incoming traffic, time of day, and the demand. Now, in this case, we're going to be using a scaling policy. That's the number of requests per instance that I'll show you afterwards. So the very first thing for the auto scaling to be put into action is we have to create a launch configuration. So the step that I'm going to show you now, what's the launch configuration? If you remember, see, launch configuration is a list of components or the list of ingredients that an auto scaling needs to perform the scale out action. What do we mean by scale out action? Scale out means to increase or to launch more instances because of there's a high requirement or there's a high demand. So auto scaling needs to initiate a scale out action. It needs to launch extra instances or additional instances. Now, how on earth auto scaling will get to know that what should be the AMI RD? What should be the instance type? What should be the security group? What should be the EBS volume settings? What should be the key pair? All these things are included in a template. We can use launch template, or for simplicity we can use launch configuration. Okay, this launch configuration as a template will be picked by the auto scaling, and the identical instances will be deployed using this template. So the very first thing before we can manufacture or we can create an auto scaling group is to create a launch configuration. Now, what's the process? The process remains fairly simple right now. We need to go back to this EC2 dashboard. On the left hand side, we have auto scaling, which is being divided into two parts: launch configurations and the groups. We just go to the launch configurations first and click on create. See what I'm doing? Because in the midway, I'll explain you something. The very first thing is that I just assign a name to it, and it as HTTPT launch configuration. So simple name is being assigned to it, HTTPT launch configuration. Done. Now once I assign a name to it, the main thing that you ought to do is to choose an Amazon machine image or the AMI. So I choose the which AMI? My AMI. And I will be choosing the custom image that we created in the very first step or the second step. We deploy the demo web application and we created a custom image out of it. We're going to be using the custom image. We're going to be using the custom image. Fine. Then it says, could you please choose instance type? Now I click on choose instance type, and the one that I'm going to be choosing would be T2.micro, which is free of cost. Fine. So I'm saying this should be the software specification. This should be the hardware. The image specifies the software config, and the instance type specifies the hardware config. Fine. Because the CPU RAM is being determined by the instance type. You don't have to change the additional parameters. Scroll down. Don't change the EBS volume. Scroll down. It says, could you please assign the security group to be assigned to the instance? I will click on select and select the same one that I'll be linking with the load balancer. So I'm saying the same security group will be assigned to my instances as well. Because I want to open the HTTP port from anywhere, the same one will be assigned to the instances as well. Okay, and I would choose proceed without a key pair because we don't need to SSH to this to these instances in this hands-on. And I acknowledge that I will not be able to connect to these instances because I don't have any key pair. Now, again, I'm showing you what exactly I did. In the launch configuration, I assign a name to it, pick the image, custom image, the instance type. You need to skip the additional configuration. Volume, this is the volume configuration or the amount of volume attached with every instance. And please assign the same security group that you assigned to the load balancer. And when you scroll down, please proceed without a key pair because we don't need to SSH to the instances to be launched in the future. Okay, click on create launch configuration and let me know what's done. Now I will show you the step number 43 to 45. I'll show you the steps 43 to 45 and see what I'm doing. See, what I'm going to do right now is I go back to the launch configuration page, select it. Now from this template, I will just deploy or manufacture a new auto scaling group. So how will I achieve that? I will select the launch configuration that you can see on my screen. Once I select it, I go to actions and click on create auto scaling group like this. Now, the very first thing it will ask me for a name. I name it as HTTPT ASG. ASG stands for auto scaling group. This is a name that I want to assign to the group. Now, what's an auto scaling group? It's a logical collection of identical instances. You group the instances together because they have the same software and hardware specification. Basically, an auto scaling group has the same launch config applied to it. So it's a collection of identical EC2 instances. You group the instances together. You click on next. Then the same thing that we're going to do is that we choose all the availability zones in our region. Okay, so please do that. Let me know once you're done till step number 45. I'm going slow on this step because this is where the people can make some mistake. Just to ensure that there's no scope of mistake, that's why I'm going very slow on this last step. On the previous step, you have to, once you select the launch configuration, you assign a name to the auto scaling group, click on next. Please ensure that you pick all the availability zones / subnets in the region we're working in. Whether 6 availability zones, what's the number, how many number they're showing, you have to select all of them. Okay, let me show you the next step now. The next step is from 46 to 48. Once I choose this, I click on next. Now, basically, this is a robust architecture where we're going to be attaching the load balancer with the auto scaling group. You can see that it's an advanced option. We will choose the load balancer to distribute the incoming traffic for your application across instances to make it more reliable and easily scalable. So to go more deep and more advanced, we'll link with the load balancer. We'll choose attach an existing load balancer, and we choose the target group of the load balancer automatically. So it will automatically show you. You have to select the target group of the load balancer. Okay. Under health check, choose ELB because we want the load balancer to actively gauge the health of the instances. Then it will ask you that what's a health check grace period. Now understand what I'm trying to convey this concept. It's a buffer time that we give to the newly launched instances so that they get enough time to boot and get ready before they can be put into service. See, for example, a very layman, it's a silly example, but a very layman example. When a baby is born, you can't expect that baby to just get up and start running. Now, once a baby is born, he or she takes few steps and start walking and then start running gradually after 1 year, 2 or 3 years, or she starts running gradually after. So you can't expect a new baby to respond to start running. Similarly, if an instance is deployed, you can't expect it to be in service immediately. Today, if I deploy any instance, it takes on an average 5 minutes to boot, to install script, software, OS upon it, and then it's in service, right? You can't expect an instance to be launched immediately. Within a second, it starts taking the traffic. It needs some time to install every software component upon it, and then it can take on the traffic. Now we give a buffer time of 300 seconds, which is equal to 5 minutes, saying that, okay, we give it a buffer time of 5 minutes. In that time frame, the ELB or auto scaling will perform the health check after 300 seconds. Because if the load balancer performs a health check just in a second when instance is deployed, it is initializing. It's not in the process to respond back to the load balancer with a 200 OK message. Eventually, the instance will fail the health check. You understand the point? See, for example, I'm just giving you a very simple thing. I just launched instance right now in front of you. Okay. I just launched a new instance in front of you. Okay. Now this instance will install the OS script software. Right now, if you see it is pending, the status check will be initializing. Now, if I send the health check to this instance, will it respond? No, because it's still booting up. The same thing we are saying over here is that if auto scaling launches any new instance, please don't send the health check towards it in next 300 seconds because we wanted to give it a buffer time before it can be put into service, and then you can perform the health check. Fine. Now you click on next. Now the next step that you have to perform, you need to allow is the group size. Basically, you define the group size of the auto scaling group. See, the desired capacity and the minimum capacity is same. What's the minimum capacity that you need? Maximum is the rooftop capacity. Capacity means the number of instances. We're going to choose 4. So 2 is the minimum capacity. So every time you should have 2 health instances running and maximum 4. This will ensure that the number of instances will not go below 2 and will not go above 4. Fine. This will make sure that it complies with that. Fine. Please go to the group size. Let me know once you're done. Thereafter, I'll explain the scaling policies. Steps 46 to 49. We're almost at the end of this hands-on. I'm going a bit slow because I want to explain you a few things. Don't want to hurry about at the last step when a few things need to be explained. Done? Okay, great. Now, the next thing that you have to configure is a scaling policy. Now, I'll show you the step right now. See what I'm doing. In the midway, I'll also explain you a few steps. Steps I'm going to show you is step number 50 to 56. See what I'm doing. Now, the next thing that we ought to configure is the scaling policy. What's a scaling policy? It's a condition that we enforce based on which the auto scaling will increase or decrease the number of instances. See, there's some conditions need to be put in. So the policy that we're using is the target tracking policy. What's that? Basically, it works like a thermostat. You set the room temperature, and it will adjust itself accordingly. Basically, in target tracking policy, it's using CloudWatch behind the scenes. These are the metrics that we use: average of the CPU utilization, number of packets coming in, number of packets going out, or the request count per target or the per instance. These are the metrics that we used as a scaling policy to determine that what are the situations during which the auto scaling will initiate the scale out event, which means that it will launch more instances, or auto scaling will initiate a scale in event, which means that it will terminate few instances. Fine. I choose application load balancer request count per target. So I'm saying I want to ensure that I specify the number of requests per instance in my target group, and I choose my target group for the load balancer. Now, by default, the target value is 50. Because we just do the hands-on and we want to see the quick result, I'll make it as 2. What I mean by that? If there are more than 2 requests per instance at any moment, then auto scaling should increase my number of instances because there's a high volume of traffic coming in. See, basically, what's the minimum capacity we have? 2, right? It will start with 2 instances. Now, at any moment, if I get 2 requests per instance, which means in total 4, right? If I get 4 requests at any moment, this means that there's a high volume of traffic. Please gradually increase to 4 instances. Fine, you can make it a 4, 5, just make it as 2, so that you can just getting a very fast output. So I'm saying the target value is 2. So if the request per instance is 2 requests of the requests coming from the user per instance is more than 2, then make it to 4. Deploy 4 instances. Is this point understood? Okay, let me explain that. I think guys, is this clear? I'm saying that I will start with 2 instances. If the number of requests per instance is more than 2, then please increase the number of instances up to 4. So application request count per target is value 2. Fine. 300 seconds means that I'm giving 300 seconds, for instance, to boot up and install everything before it can be put into the service. So if the number of request count per target is more than 2, then it will increase the number of instances. You don't have to enable scale and protection. Click on next. Now, the next thing that will come on your page is the notifications. You can skip the notifications for this hands-on. Click on next, and click on create auto scaling group. Scaling protection means that you don't want the instances to be terminated, which we generally we don't select it. It's an immunity we are giving to them, that we don't want them to be terminated, but we want them to be terminated just in case if their demand is low. Okay, so guys, please perform the steps 50 to 56. Let me know once you're done. Thereafter, we're going to do the testing. Guys, is the point clear regarding the scaling policy? If you have even the slightest doubt, just let me know, because I'll explain you again. We are saying that if the number of requests per instance is 2, then there's a need to initiate a scale out event to increase the number of instances. Done? 50 to 56. Yes. Now guys, if you go to the auto scaling group and go to activity, under activity, it has just launched 2 instances. Can you see that? Because the minimum capacity is 2. The minimum capacity is 2, it will start with 2 instances. Now, if the number of requests per instance is more than 2, then it will increase up to 4 maximum instances. Great. Now, the next step is testing phase. Okay, so if you go with the next step, that is 57 to 59, or 57 and beyond, I'll show you what we're going to do is that steps 57 and beyond, or afterwards, what you're going to do is, see what I'm doing. See, basically, auto scaling is just managing the instances, making sure that based on the demand, it increases or decreases the number of instances, it maintains the right capacity. But who will take care of the application's traffic and the traffic management? Load balancer. I go to the load balancer on the left hand side. Okay. I go to the load balancer and pick the DNS name of the load balancer. This is my DNS name of the application. Now I can link it with my own domain. For example, Intellipaat.com, Google.com, xyz.com. For that we use Route 53 that we discuss afterwards. But to test an application, we're going to be using the load balancer's DNS name. I copy the load balancer's DNS name and paste that in the browser, and basically it is sending my traffic to the instances at the backend behind the scenes to both instances. Now what you have to do is you keep on hitting few refreshes. Hit refresh, hit refresh, hit few refreshes, so that the number of request count per instance per target is more than 2. Hit few refreshes. You have to be patient for next 5 minutes. Hit refresh, and it will bump up the number of instances up to 2, number of requests up to 2 for every instance. You keep on hitting refresh on your browser so that the number of requests are increased. To see that in real time, if you go to the load balancer, go to monitoring, and you go to requests, you can see that the number of requests is increasing now. As I hit refresh in real time, can you see that? I go back to the load balancer's request monitoring, it will eventually bump up. I want to increase the request eventually, right? Now, once I increase the request, the number of request count per instance per target is more than 2. In this case, what's gonna happen is, fine. Now please hit refreshes, and eventually it will increase the number of instances. It will take 4 to 5 minutes. It will take eventually 5 minutes for this to come back up. Please hit few refreshes, 30 to 50 refreshes, and let's wait. It will take up to 5 minutes. What you have to do is, guys, if it's not, you just go to the load balancer. Okay, just go to the load balancer. Wait a few refreshes real quick. Go back to the load balancer, go to description, scroll down, and there's a security group showing up, right? You need to click on edit, or I would say click on the security group, and you need to ensure that the HTTP is allowed from anywhere in the inbound. Go to inbound, make sure that the HTTP is allowed from anywhere. And you can try different browser if you want, because sometimes it is a browser related issue. Yeah, 2 instances are starting. Great. So in next 5 minutes, you're going to be seeing that 2 instances will launch. So I need to go to the auto-scaling groups real quick. Guys, if the link is not working for you, please try a different browser if you can do that. Now, in my case, you can see that my 2 instances are launched. Can you see that? There was a failure in between, but I can see that now 1 instance is launched successfully. So if I go to the instance management, you can see that I have 4 instances deployed. You can see that I have 4 instances deployed automatically. If I go to activity, I can see exactly the log, right? It was successful because it changed the desired capacity from 3 to 4. If I go to the instance management, I can easily see 4 instances. If I go to the number of instances, if I go to the instance dashboard, I can see 4 instances being deployed. 2 are running, 2 are just initializing. Fine. So based on the number of request count per target, going more than 2, it deployed up to maximum number of instances. Okay, it's working for you guys. Okay, this is what the purpose of the auto scaling is. Auto scaling takes care of the capacity concerns. Auto scaling takes care of the capacity concerns, and the traffic management is done by which component? The load balancer. The 2 work hand in hand in collaboration to ensure that the continuity and high availability of your services and applications. Great, wonderful. Now, for those people for which the load balancer's DNS name is not working, you can try a different browser, or else I've shown you need to select the load balancer like this. Go to description, go to security group, click on the security group, and please ensure that you allow the HTTP from anywhere. Fine. Is this concept clear now? Auto scaling will take care of the capacity concerns, the capacity issues. but the traffic management is the in-house or the internal traffic management and traffic distribution is done by the load balancer, right? Now, if I keep on hitting refreshes, the load balancer will divert equal chunk of traffic to each of the 4 instances. So every instance will get the 25% of the overall traffic. And guys, the second thing, even if even for those people for whom the load balancer is not responding properly, there's another, even after manipulating the inbound rule, the other possibility of you doing the mistake is that you might not have included /index.html in the health check. So even after editing the security group, if it's not working for you, you go to the load balancer target group, choose a target group, okay, and go to health checks, click on edit. You have to make sure that the health check path is /index.html. You have to go to the load balancer target group, go to health checks, click on edit, and make sure that the health check the path is /index.html. If these 2 steps are completed, then there's no reason why your load balancer is not responding. Fine. Now the very first thing is that you have to go to the auto scaling groups. Please see what I'm doing. It's my humble request. You have to choose the auto scaling group, right? Click on delete. Just type in delete one more time, and please delete the auto scaling group. It will automatically terminate the instances. Please just type in done once you're done. Once you have initiated deleted or deletion process, it will start with the termination of the instances. Fine. Please remove that. It's my humble request. Please remove the resources. Don't do it further now. You have 3 days ahead of you. Please, if you're not able to get the result, you have the document. Please redo the steps by yourself in your free time. Done? Okay, great. The next thing is that you have to go to auto scaling launch configurations. Now, launch configuration is free of cost, but if you want to remove it, you may do so. Go to auto scaling launch configuration, choose it, go to actions and click on delete launch configuration and click on delete. Done. Now you have to go to the load balancer, go to the load balancers on the top, choose the load balancer, go to actions and click on delete. Please delete the load balancer. Then you have to go to the load balancer target group, choose it, go to actions and click on delete, and let me know once you're done. Please delete the load balancer first and delete its target group. Now you have to go to AMIs, choose your AMI, go to AMIs, choose your AMI, go to actions and click on deregister AMI. Okay. Now, one thing I want to tell you, if you want to perform this hands-on again in the next 3 days ahead of you, then don't remove the AMI. You can reuse it. Okay. But if you don't have to perform the same steps again, because AMI is a one-time charge in the month, it's a month of April. Before 30th of April, this AMI needs to be removed. But if you want to keep it and use it in the month of April, then you can keep it or click on deregister and click on, it says delete associated snapshot. Now, basically snapshot, I'll let you know how to delete it. Please, first thing first, deregister the AMI. That's fine. The next thing is that once you deregister the AMI, then under the images, you have the Elastic Block Store snapshots. You have to choose the snapshot like this, go to actions and click on delete snapshot and click on delete. And this will remove everything. Instances, auto scaling configuration, load balancer configuration, image and snapshots. Fine, that's about the stuff. Now, the next topic that we discussed, we'll pick it up, is the VPC. Now, VPC is an advanced topic, right? It's an advanced topic. It is a topic that takes time to understand. Now, I would say it is a topic that includes a lot of concepts, and it includes the concepts of networking, right? So if you guys are not coming from networking background, and of course not all of us are coming from networking background, so it will take some time for you to understand the concepts of VPC. I'll try to make sure that I make it very clear that what's a VPC. I make you understand different components of it, and there's some additional things that we discussed in the VPC, like VPC peering, endpoints, And also we discuss, for example, access control list, how to secure the VPC. So VPC also comes under the security infrastructure, but basically it is a networking component. So guys, one more thing I want to just add on. Whenever you guys practice any free time and you're using the AWS Management Console, please make sure that you keep a track on the billing part, right? So make it a practice that whenever you get some free time, whenever you think that okay, you have deployed some components, the very first thing that you need to make sure is that you wipe out the resources immediately before you hit sign out. It's a very common mistake that people do. Even I did that at the initial stage. 8 years back when I started working on AWS, and I used to have AWS free tier account 8 years back, and start practicing. I start getting unexpected charges. So at that time, even I didn't have the understanding that why exactly I'm being charged. So the very first thing that you need to be aware of as a thumb rule is that whatever you deploy, please stop or remove these resources before you hit sign out, right? Sometimes, yeah, of course, we make the mistake and we just simply sign out, and the instances will be.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
We keep these tests up and running at the back end, right? So make sure that before you hit sign out, you wipe out the resources or stop the resources so that you don't get any further charges. See, if you go at the top right hand corner, you have this thing called at the top right hand corner where it shows you the display name. In my case, it's JP Morgan. So if I just go to billing dashboard, the billing dashboard is where you're going to be seeing the bill on the bill that you'll be paying in the next month. Fine. So the billing dashboard shows you the complete summary of the bill that you have to pay, right? Now, the thing is that if you practice a lot, there will be some charge being added to your bill, right? Now, even though I spend almost 8 hours every day on AWS console, I don't think I've paid more than $5 on an average each month. I take 3 batches. I also do my research. I also need to use this as a test environment to test few things before I can implement the same thing on the client's infrastructure. So it is a kind of a sandbox for me. So I use it a lot. Okay. Even in that case, I don't get more than $5 on an average each month. Sometimes I get so 6, 7, 10. Sometimes I get $2. So on an average, it's not more than $5, right? $5 each month. So please make sure that you view your bill on monthly basis. See that where you're being charged, because based on your charges being the charges that you have got, you understand that what's your usage, and if something is running in the background, you wipe out the resources, right? Super important, because I've seen people getting 10,000 bill, 15,000 bill, because they just keep the resources running without shutting them down. And for the free tier limits, you have because you're using free tier account, just go to aws.amazon.com/free. You can easily see that what are the free tier limits, because if you use a free tier account, you're being subsidized for the usage, right? So you are being subsidized for the usage. So make sure that you go through the free tier limits and see that the things that you're deploying, whether they're free. If they're free, then what is the limit that you get? If you have any confusion regarding the free tier limits, you can ask me anytime. But make sure that you always stop the resources before you hit sign out. Okay. All right. So let's get started with the stuff now. So let's start with the VPC. What's a VPC? Any idea what's a VPC? I discussed that VPC stuff in one of the sessions, especially in EC2. Any idea about it? What's a VPC? See, basically a VPC is nothing but it's a virtual data center that you deploy in the confinement of a public cloud platform. If I go back, yeah, this is what I discussed with you, right? So what's a VPC? See, any cloud infrastructure that you pick up, you go with Microsoft Azure, you go with Amazon Web Services, AWS, that we're studying right now. You go with Google Cloud Platform, whichever cloud infrastructure that you pick up, it's a public cloud platform. Why it's a public infrastructure? Because anyone, you, me, any business, any organization, any individual is welcomed. He or she can easily sign up for their services and start using them. So it's a public platform because anyone can join. Now there's no background check. If you sign up for a free tier account, was any background check? No, you just use a credit card or debit card and you signed up. Now, this is a kind of a threat for most of the organizations who are concerned about security, because they if they go to cloud, they will be running their services on a public platform which is being used by millions of users. See, AWS has millions of customers right now, more than 2 or 3 million customers at this stage. So startup companies, big organizations, individuals, so 2 to 3 million customers as of now. So if a company is signing up for AWS, they're sharing the same platform which is being used by millions of customers nowadays. So this is kind of a concern. This raises the concern for any organization that how they can isolate themselves from other infrastructures. So in this case, VPC comes out as a solution. VPC is nothing but or a virtual private cloud. It's a virtual data center that you deploy on a public cloud platform. It gives you isolation and enhanced security. For example, on an AWS public cloud platform, there are 3 VPCs. One is owned by Accenture, then the other is owned by Wipro, and the third one is owned by JP Morgan. Each of these organizations are able to isolate themselves from other infrastructures. So you get a kind of privacy. To give you a very layman example, let's suppose that there's an apartment, right? In the apartment, there are multiple walls. Why there are multiple walls? To create rooms, right? So VPC is a kind of an apartment with 4 walls, and then you further dissect it and create rooms within, so that every person is able to isolate himself or herself, and you give separate rooms for separate individuals. So basically you get privacy and you're able to isolate yourself from other customers on the same platform. Okay. Now, apart from the security and isolation, there are other benefits that you get from the VPC. What are those benefits? Let me just make a note of them. The other benefits that you get from the VPC are the following. The very first benefit, or I would say the other benefit is, yes, it gives you security, enhanced security. The benefit that you get from the other benefit is that it gives you flexibility in terms of resource management, right? Because you create and manage the entire infrastructure, you get a lot of flexibility in terms of resources management. It offers you a lot of flexibility. Plus, it gives you transparency. You can look into the networking components and you can arrange them according to your business requirements or business needs. Flexibility, transparency are the other benefits of owning a VPC on AWS. Okay. Now, this VPC is, of course, it's a very old concept, but basically prior December 2013, there was another concept which was called EC2 Classic. So there were 2 options that were given to the customers of AWS. One was EC2 Classic, which means that you can deploy resources outside VPC, and the other one was EC2 VPC, which means that you can deploy your instances, your databases inside the VPC. Right? This concept existed almost 9 years back. Then it was discontinued. Now, this is no longer valid. AWS says that you need to deploy your resources inside the VPC. You don't have any option to deploy outside it. So the concept of EC2 Classic is being discontinued. It's obsolete now. Okay. So they're saying that, okay, you need to deploy your resources inside the VPC, and we give you default VPC. Default VPC means that this is the VPC that you can easily use on the fly. You don't need to create it. But if you want to create your own VPC, then you also have the ability to create your custom VPC, which gives you a lot of flexibility options to configure your network by yourself, right? So they structure the VPC in 2 different parts: default and custom. Default is there by default, you start using it, and custom is the one that we create by yourself. Now we are going towards a direction, or once we start understanding the VPC concepts in detail, we'll move in a direction where we'll understand the process to create a custom VPC from scratch. Okay, it's a very interesting part. You're gonna love it. So this is what about the basics of, or the introduction to VPC. Now, once we discuss the VPC basics, the features and the benefits, let's understand the components. See, the components are multiple components. So basically, when you create a VPC, it's designed using IPs, private IPs. I've jotted down. It's designed using private IPs. See, whenever you create an entire networking infrastructure by yourself, you need to take the building blocks, the components, and you need to join them together. So let's understand the components of the VPC so that you can understand that how you can join these different components together and create the complete networking infrastructure. So let's understand the components of the VPC and then we'll understand how to implement them. So let's understand the components of VPC. Fine, let's try to understand that. The very first component is the IP addresses. You need to have the IP addresses to structure the VPC and its components. Without the IP addresses, you cannot create a network. The network is created using the IP addresses. Now, there are three types of IP addresses that we already discussed. I'll walk you through them one more time. One is the private IP addresses. Second is public IP. And the third one is the elastic IPs. Okay, now these are the three types of IP addresses that we have. Now, if you scroll up, I discussed with you the types of IP addresses at the time when we discussed the EC2, right? So these are the same IP addresses we use. Private IP address. What's a private IP address? It's purely used for internal communication. What do you mean by internal communication? Which means that two instances want to communicate with each other. If they want to talk to, if two instances on AWS, they want to communicate and have an internal dialogue with each other. They want to send or receive the traffic, send some data, some traffic to each one of these instances internally. Then the private IPs are used. Private IPs are used purely for internal communication. These are three ranges that you ought to pick to design your private network, because virtual private network. So to create a private network, you need to use the private IPs. These are the three ranges that represent the private IP address: 10.x.x.x, 172.16.x.x to 172.31.x.x, 192.168.x.x. Okay. Now, whenever you deploy any instance in AWS, every instance gets a private IP. It does not change whether you stop or restart the instance. It is there intact. Public IP address, on the other hand, it's used for external communication. What if I say external communication? What do you mean by that? External communication simply means that the instance in the AWS cloud wants to communicate with the internet. For example, you have deployed a website or a web application upon the instance. In this case, because the internet traffic has to be welcomed or it needs to be initiated, so there's an open communication that needs to be initiated towards the internet. The public IP addresses would be added on to the instance apart from the private IP. Private IPs should be assigned to every instance. Optionally, if that instance needs to communicate on the internet, the public IP should be assigned to that instance. So public IPs are not mandatory. You may or you may not assign them to the instance depending upon the use case. So if that instance need to have a communication on the internet, then of course the public IPs are used. Ranges, they can fall into any range except the private IP address, right? So a private IP address cannot be used as a public IP. The range, I'm talking about the range. Plus the loopback IP 127.0.0.1, it's used for troubleshooting and testing purpose. Okay. The downside of the private IP is that if you stop and start the instance, it will change. Okay. Now this is jotted down over here. It is not dynamic. So the public IPs are not dynamic. They will change upon instance restarting. So this may be a big problem for you just in case if you have deployed a web application upon the instance. See, today you type in google.com, facebook.com, instagram.com, Intellipaat.com, whatever website that you browse on daily basis. When you type that domain name, xyz.com, for example, it gets converted into the public IP address of that server that will serve you the content or the web pages. Now, if in this case, if the instance restarts, every time the instance restarts, the instance will get a new public IP. Okay? This means that you need to map your domain to a public IP every time. You need to map the domain to the public IP every time the instance restarts, right? So it's a manual effort that you have to do every time the instance restarts. See, instance can be restarted for multiple reasons. Maybe you're doing some backups, you're doing some patching, there's some issue with the instance. Maybe it got restarted by itself. Okay, so every instance restart means that you have to map your IP, your new public IP to the domain. Your domain needs to be linked with the new public IP every time the instance restarts. Okay, so public IPs in this case they create issues. They are problematic. To solve this problem, we use elastic IP. It is same as public IP, but it is static in nature. It behaves same as public IP, same functions, same natures, but it never changes no matter how many times you restart the instance. Fine. So it overcomes the challenge that you face with the public IP. Okay. So I guess this is clear, but I didn't deep dive into the difference between the public and the elastic IPs. Let's do that. So let's imagine I just go ahead and deploy an instance. Let's do that. So I just go ahead and deploy the instance real quick. I just go to the instances. Okay, let me switch to North Virginia just to make sure that I stay into this into one region. Okay, guys. One thing I think I discussed this thing with you, that whenever you deploy something, make sure that you stick to only one region so that you can easily track and monitor your resources, and you can remove them just after you're done. So sticking to one region helps you to easily track the resources. So I click on launch instances right now, and I just quickly launch the instance real quick in front of you without giving a much thought about it. So I will just quickly deploy the instance, right? So I just launched one instance in front of you. The instance is being launched. Fine. So the instance is launched. Now, if I go to the instance right now, and if you see that this instance has got the private IP, this is the one, fine, and this is the public IP. Now let me make note of this public IP, and I just put that in the notepad or the text editor. Fine. So this is my public IP. Now let's do one thing. Let me go to instance state, stop the instance, right? So I have just stopped the instance in front of you. See what happens. So the instance is stopping right now, and instance is stopped right now. If you see the private IP, there's no change. It is there. But can you see the public IP? It's completely lost now. There's no sign of public IP. Now, if I stop, I've already stopped the instance. Now I need to restart the instance now. And you're going to see that within few seconds, the instance will get restarted. Let's wait. Okay. Now I just restarted the instance. What about the public IP? I just copy it and paste that in the browser. I'm sorry, in the on the notepad. And you can easily see the difference between these two. The top one is the previous public IP, okay? And this is the new one, fine. So what we conclusion is that every time an instance restarts, it gets a new public IP. What happens is when we stop the instance, the usage of the public IP is no longer valid, right? You see, what's the purpose of the public IP? The purpose of the public IP is that you use internet to get access to the instance by SSH or RDP or HTTP. Okay, but if a machine is stopped, if a server is stopped, even though it is assigned a public IP, it's useless because no one can connect to a stopped instance. Now there's already a scarcity of public IPs. AWS at the backend maintains a complete pool of public IPs. So once instance stops, AWS says, okay, the instance is stopped. It doesn't need a public IP. Let it take it back and reserve it for the future purpose. Because I may have the instance stop for, let's suppose, 10 days. So there's already a shortage of public IPs across the networking domain. So because there's a shortage of the public IPs, these are scarce resources. So they say that okay, if you have stopped the instance, this means that you don't need to connect to it. You can't connect to it over the internet. Let's take off the public IP and take it back to the pool of public IPs that they maintain at the backend. Okay, so that's the reason why they do that. Now, how to fix it? To use a static public IP, you use a concept called elastic IP. Okay, so what you do in this case is you just go on the left hand side where it's called navigation pane or the navigation menu. You scroll down and you can see that just there we have this thing called elastic IPs. I click on that. Fine. So I have the elastic IPs page or the dashboard showing up. Now elastic IPs are allocated to your account. So you can see that it says allocate elastic IP. I click on allocate. You don't have to change any setting over here. There's no need to change anything. Click on allocate. So what I've done is that I've allocated a single elastic IP to my account in the region of North Virginia or Northern Virginia. Okay. So I've allocated a simple elastic IP. But is it associated or linked with an instance as of now? If I just go to the right hand side, the associated instance ID is completely blank, right? Which means that even though you allocate an elastic IP to your account, the elastic IP needs to be associated with the instance. So to do that, you go to actions and you get the third option on the extreme right hand side. It says associate elastic IP address. Okay. Now, if I do that, public IP address that's linked with instance will be completely removed automatically. So I click on associate elastic IP address. You can see that. So it says what's the resource type? Instance. I choose the instance that's running in the background. I choose its private IP. So what I'm trying to do is that I'm trying to link or associate this elastic IP with the instance that's running. Now, the previous public IP address of the instance will be wiped out. The previous public IP address, this one now. This public IP will be gone forever because this elastic IP. So let me just copy and paste this thing on the So this elastic IP will become the public IP, and the previous public IP would be detached forever. Fine. So I go back and I scroll down and click on associate. Done. I go back to the instances now, and you will see that I think I need to hit refresh. Yeah, I hit refresh. You're gonna see that the elastic IP has now become the public IP 34.206.0.181. What about the previous one? It's gone now. AWS take it back to its pool of public IPs it maintains. So this elastic IP has become the new static public IP address of the instance. I'll go back one more time. You're going to see that the elastic IP is the public IP address of the instance. Now, to prove this that it is a static public IP, I'm going to stop and start the instance in front of you, and you're going to observe that there's no change. Regarding the charge, Banu, I'm just about to come to that. I'll just discuss it. Fine. So you're going to see that the instance is stopping. Let's wait for some time. Stopped. Instance is stopped. You will see that the public IP address or the elastic IP, there's no change. There's no change. Now, if I go to instance state and start the instance, you're going to see that even after starting the instance, there would be no change. Even after restarting the instance, there was no change in terms of public IP or it's elastic IP now. Elastic IP is a static public IP only. There's no change in the public IP / elastic IP even after restarting the instance. So in those cases where you need a static public IP, what are you going to be using? Elastic IP. Simple. Fine. For static public IP, what are you going to be using? Elastic IPs. Okay. Now, elastic IPs are there are few limitations that I'll discuss with you in terms of the elastic IPs because the billing part needs to be discussed, right? The billing part needs to be discussed as well. So let me discuss with you the billing part. Okay. Now, coming back to the next stuff, that is the usage of, or I would say, after we discuss the usage of the elastic IPs, let's discuss the billing part and some limitations. See, elastic IP comes with some limitations and see one thing, elastic IPs are limited in terms of usage. First thing first, let's understand that there's a scarcity of public or elastic IPs. These are scarce resources. Scarce means that there's a shortage of them. So AWS makes sure that they are being preserved and there's no wastage of them. So whatever is scarce in nature, we try to preserve it, right? And it's not with AWS, it's across the entire networking infrastructure. Or in the networking world, public IPs or elastic IPs or public IPs, I would say that they are scarce resources. Now, elastic IPs regarding the pricing. So right now I'm trying to discuss with you the billing part, how you're being charged for the usage of the elastic IPs. See, you get 5 elastic IPs. So in the short form, instead of writing elastic IPs, I write it down as EIPs. For free of cost, you don't have to pay for them. 5 elastic IPs per region for free of cost. Also, this is the maximum limit you can reach. So at any given point of time, you can't have more than 5 elastic IPs staying in a region. So you can use up to 5 elastic IPs in each region. That's a maximum limit, and it's free of cost. Now the thing is that if you need more than 5 elastic IPs, then you have to pay a small charge, and you get a package of 20 elastic IPs per region. Now, even though it is free, there are some conditions applied. There's a terms and conditions applied. What are those? First thing first, you need to make sure that elastic IPs are assigned to running instances only. Okay, so never assign the elastic IPs to stopped instances. And also, they should be in associated state, which means that they should be linked with the instance. They should not be sitting idle for a longer duration. If you don't comply with these 2 rules, then elastic IPs, AWS will start charging you for their elastic IPs usage. even though they should be free of cost. See, why they impose this thing to you that they should be assigned to running instances only? Because as I said before, so because there is a scarcity of the elastic IPs, they ensure that you assign them to running instances only. If you assign them to stopped instance, they're being wasted. Assigning an elastic IP or the public IP to a stopped instance doesn't make any sense, because if it is stopped, you can't connect to it over the internet. And they should be in associated state. What do you mean by that? For example, if I go back to the elastic IPs right now in front of you, let me just go do that. If I go back to the elastic IP, right now it is in associated state. It is associated to instance right now. Okay. If I go to actions and click on disassociate, right? Now if I disassociate the elastic IP from the instance, that instance will get a new public IP. Okay. I just disassociated the elastic IP in front of you. This is in unassociated state right now. If I keep it like this for more than an hour, then AWS will start imposing few cents per hour on me. So they say that don't keep the elastic IPs disassociated for a longer duration, more than 60 minutes, more than an hour. Don't do that, right? Also, they should be assigned to running instances only, because if you assign them to stopped instance, they're being wasted around. So if you assign an elastic IP to a stopped instance for more than an hour, they will start charging you. So if you think that elastic IPs are being unused and you may get some unexpected charges for their usage, you can release them from your account. How you can do that? Go to actions, and there's an option which says release elastic IP address. If you click on release, they will no longer be associated with your account. You just release them from your account. So if you think that you don't have any scope of assigning the elastic IPs to running instances, then please release them to avoid any unexpected charges. Clear? This completes the concept, the difference between the public and the elastic IPs. Super important. I thought that I should discuss with you, because the difference is to understand the difference is extremely useful for you in the future. Okay, that's about the stuff. 5 elastic IPs per region. It's not user per region, it's 5 elastic IPs per region. For example, North Virginia, 5 elastic IPs, California 5, Singapore 5, right? So each region I can have up to 5 elastic IPs. So on this dashboard, I can only have up to 5. Okay, for example, right now, the region I'm in is in North Virginia. If I try to allocate more than 5 elastic IPs, you will see that I will get the error message. So I'm trying to allocate 2 elastic IPs right now. So I've already allocated how many? 4. I will allocate the last one, fifth elastic IP in the region of North Virginia. 1, 2, 3, 4, 5, right? As soon as I try to allocate the 6th one, I will get the error message. The maximum number of addresses has been reached. So in any region, so you get 5 elastic IPs per region. So if you're using 10 regions, you're getting 50. Okay. So maximum number of addresses has been reached. So at any given point of time, you cannot have more than 5 elastic IPs linked with a single region. Okay, that's about the stuff. The next thing that we ought to discuss is the usage of the private IPs in constructing or building the VPC. See, you need to understand this thing, that because we are creating a virtual private cloud, we're going to be using the private IPs. We're going to be using private IPs to create the entire VPC first. Okay, so how this works? Let's understand this thing. So right now, I'm going to discuss with you the concept of subnets. I had already discussed with you this thing in brief, but didn't manage to discuss that in detail. So we'll discuss the subnets, how they're created, what's the type of the subnets, public and private subnets, what the usage of them, and what's the use cases that you're going to be using. Or we also discuss the use cases where we also understand that in which of the use cases the private subnets are used, the public subnets are used. We discuss all of them. So the next thing that I'm going to discuss with you is called the subnets. Okay, what are the subnets? See, whenever you create a VPC, okay, let me draw a VPC first and then I'll explain you. Let's imagine this is my VPC. This big structure that I've created, it is the VPC. Fine. Now VPC is contained in a region. Whenever you use any VPC is a region specific resource. So for example, this is my VPC in Mumbai. Okay, let's do one thing. Let's go to the VPC in Mumbai. Let's switch to Mumbai region and I show you something. So I just went to the VPC in Mumbai. Okay, so I just go to the VPC dashboard and I go to VPCs right now, and every region will have a default VPC, right? For example, the one that we are picking up is the default VPC in Mumbai. Now, a VPC is designed using a private IP address block. It's called CRDR block. There's a CRDR block assigned to the VPC. For example, in this case, it's 172.31.0.0/16, right? Now, what this /16 means? See, basically, we use this thing called subnetting. If I take an IPv4 address, it's of 32 bits. What do you mean by that? For example, if I take this IP address, it consists of 32 bits because it consists of 4 octets. 4 octets. What do you mean by 4 octets? This is my first octet, which consists of 8 bits plus 8 bits, second octet plus 8 bits plus 8 bits. 8 plus 8 plus 8 plus 8, which comes down to 32 bits. Fine. Now, if I take /16, I'm saying that the first 2 bits, I'll be using it to design my entire, to mention my.
Just a quick info, guys. If you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Network. So I'm saying the first 16 bits is used for networking purpose to define my network. And the rest one, the leftover would be assigned to the hosts or the machines in the network, or hosting, or for hosts. So the first 16 bits I'm using for pure networking, and the leftover bits. So first 16 bits is used for pure networking, and the leftover bits I'm using for hosting. Okay, now you don't have to deep dive into the details of it. Basically, you have to pick a range at the end, right? Now, let's do one thing. There is a website that I'm going to tell you that you're going to be using to perform the subnetting. Let me just show you the website address. Just give me a second over here. This is the subnet calculator. Very good subnet calculator that I can use to do the subnetting. Subnetting, if I just break it down to into a simple terminology, you are breaking down your network in such a way that you can, in terms of AWS, you create an entire VPC and create subnets out of it. See, if once the VPC is created, inside the VPC, it needs to be further broken down into multiple networks. VPC is a huge data center. It needs to be further broken down into small chunks or small networks. So in this case, what we do is we start adding the subnets into the VPC. So Mumbai is AP South 1 region. Fine. Now inside the VPC, we further create more networking blocks. These are called subnets. What are these called? Subnets. So let me just copy it and paste it over. So right now, these are my 2 subnets. What are these? These are my subnets, which are blocks of private IPs. So what are the subnets? Blocks of private IPs. What are these? These are blocks of private IPs. So what you do is you add 8, for example, you need to add some more bits. For example, in this case, I'll add 4 more bits to make /20 subnets. You can add up to 32 bits, but in this case, I need to make /20 subnets. So to further dissect the network, you add more bits afterwards. So for example, 172.31.0.0/16, and for the subnet, I pick /20. So this means that these many subnets, 16 subnets I can create, and this is the complete host range I can use for my instances for each subnet. Fine. Now, if I show you this VPC subnets, I go to the subnets on the left hand side. What is the subnet IP address range? 172.31.0.0/20. The same one that shows up over here. So what's the range of this subnet? 172.31.0.0/20. What about other one? 172.31.16.0/20. Okay. So I'm not taking the third subnet now, right? So these subnets are nothing but I further dissect my VPC into multiple subnets. Slash 20 means, Ravi, because I'm saying I'm taking first 20 bits for the networking purpose. Like we have slash 16, I'm saying the first 16 bits is used for networking to design my network. I pick slash 20, I'm saying the first 20 bits of my IP address will be purely used for networking reasons, or to create my entire network, or to measure this network, right? So slash 20 means that the first 20 bits are used for networking purposes or to define my network. And the leftover bits, the leftover 12 bits will be used for defining my hosts. Host means instances. Now inside these, so first thing first, these subnets are linked with availability zones, and you launch your instances inside them. You launch instances inside them. So the instances are launched inside them. Fine. Now once you launch instances inside them, the instances will pick any of the host range assigned to the subnet range. This subnet, each subnet will give me 4096 IP addresses. This consists of 4096 IP addresses. For example, I pick 172.31.0.1, first IP address range. Okay, so 172.31.0.1. Fine. So this is the IP address, private IP address assigned to the instance. What about the second subnet? I'll pick 172.31.16.1, 172.31.16.1. So what I'm trying to do is that I'm picking the private IP address of the range of each subnet. So what's the conclusion? The conclusion is you take the VPC, it has a complete CID range, you further break it down into multiple subnets. Subnet will have its own ranges. You add some more bits afterwards. You further dissect it, and inside the subnets you deploy the instances. Instances will get the private IPs depending upon the instances that are launched in the subnet will get the private IPs depending upon the subnets they're launched into. Fine. Now this is just for your understanding. You don't have to learn it, or you don't have to deep dive into it. It's a concept of networking. Basically use these calculators to understand that how many IPs you get. So it says number of hosts, number of instances per subnet, 4096, and how many subnets I'm getting from the VPC? 16 subnets. I can see the list of 16 subnets over here. Fine. Again, I'm saying you don't have to deep dive in. You don't have to do these type of stuff. This is just for the sake of understanding. We take a CID block. We take the first, for example, 16 bits in this case to define our network, and the rest of bits will be used for they're left over for hosts. Fine. Then we add 4 more bits to define our subnet, right? And each subnet in this case will consist of 4096 IPs, right? Which will be used for the resources in that subnet. So up to these many instances I can deploy in each subnet. Yeah, that's right. Basically, it's not 4096, it's 4091 because 5 are used for internal usage. If you see the usable IPs, it's 4091. So 5 IPs are used by AWS for internal usage. So 4091 into 16 subnets. Again, I'm saying you don't have to deep dive in. This is not that much important, just for the sake of understanding. Fine. So if you want to create more than 16 subnets, then in this case, what you can do is that you can add more bits. For example, instead of /20, use /24. The more bits you add, the more subnets you will get. Right? /24. If I make it /26, I'm getting these many subnets, 1024, right? If I make it /27, I get 2048 subnets. So the more bits I add for the subnets. So I pick /20. In /20, I get number of subnets 16. What if I make it /24? The number of subnets I get 256. So basically, if you add some more bits for the subnets, see you're picking /16. What you're doing is that in this case, we are picking /16 for the VPC, right? We are picking /16 for the VPC. Now, if we add 4 more bits, we get /20 for the subnets. In this, how many subnets we were getting? 256, right? But if you add 24 more bits, okay, in this, we're getting 16 subnets, right? In /24, how many subnets will get? 256. So basically, the more numbers you add at the end, the more subnets you will get. But it will reduce the number of hosts. Yes, you're right. So basically, depending upon your requirement, you design the network. Okay, so let's suppose if you pick a 31 range, right? So in this case, the number of subnets that you get is 1, right? And number of hosts per subnet that you get is 4 only. Now I say, why is it so? Because if you do the math, basically there's a complete mathematical calculation is being done. So if you reduce the number of bits, you just have only few bits to spare, right? Because you get 32 bits, out of which 30 bits are used for the networking purpose. Fine. So you just have 2 bits to spare to create this one subnet only, right? You just have 2 bits to spare. And if you see the range of this subnet, and because you have those 2 bits, in this case, you just get only one subnet, out of which you get 4, or I would say not 4, only 2 usable IPs, right? So if you're using 30 bits only to design that entire network, you just are left with only 2 bits only. Now, for those 2 bits, what it has done is, if I use a subnet mask of 31, right? So in this case, what happens is it says, okay, this is 31 only, and I pick a subnet mask of, now if I pick this one, let's suppose, then basically it doesn't allows me to create a entire VPC because I'm consuming a lot of bits for the networking purposes only. You can see that the network has become too large to manage, right? Basically, you have to see that you can easily adjust some subnets and the instances in those subnets, right? So because if you're consuming the entire 32 bits or 30 bits just to define the network, then you don't have the leftover bits, the spare bits to create the subnets and define the instances in those subnets. Fine. So you have to have a scope so that you can have spare bits to create the entire network. Fine. So that's about the stuff. Now the thing is, this is the VPC. This is the complete. This VPC is a complete isolated network. Why it's called an isolated network? Because it has no access to the internet. This VPC has no access to the internet. It is completely isolated. It has no access to the internet whatsoever. It is completely devoid of the internet access. It's complete. It is completely cut off from the internet. It has no relationship with the internet as of now. It's completely cut off. It's a private network. Use a private IPs to create a private network. Now, what if there are few instances that needs to communicate with the internet? So internet is the biggest public cloud that we have, and this internet, okay, this is the internet. Now, I want to ensure that the instance inside our subnet, for example, this instance wants to talk to the internet. How it can do so? Basically, there's a gateway, a virtual gateway that we place at the edge of it. It's called internet gateway. What's that? It's called internet gateway. In the short form, it's called IGW. So it's called internet gateway. It is called as IGW. Okay. Now the purpose of the internet gateway is very simple. Basically, it adjoins your subnet and its resources to the internet. So if any one of the subnets in your VPC wants to, or I would say the instances in those subnet, for example, I want to make this subnet as a public subnet. Public subnet is a subnet that has access to the internet, right? If you adjoin the internet gateway to any subnet, it becomes public. Otherwise, it remains private subnet. Now, whenever you adjoin what is internet gateway? It's a virtual gateway that you place at the edge of the VPC that allows the instance inside that subnet to access the internet. It's kind of a virtual router, right? Fine. So an internet gateway is a component that gives you subnet and the instances within that to access the internet. Fine. You need the internet gateway. Now, this internet gateway is of no use if you don't know how to link it with the subnet. Basically, with each subnet, you assign something called route tables or route table. What do you mean by that? See, basically, route table is nothing but it's a set of routes, okay, which determines the internal and external traffic flow. It's kind of a GPS for the traffic that flows internally and externally. So, for example, you have a public subnet. You will assign it a route. You will assign it a route table. So this table looks like this. Let me draw this table. This is a route table assigned to the public subnet, right? Now this route table consists of 2 columns. One column is target and the other one is the destination. So basically it will consist of 2 routes. And I will show you on the AWS Management Console. It consists of 2 routes. The first route, the target would be the VPC CIDR range only, which is 172.31.0.0/16. And the destination would be local. What do you mean by local? Local means the instances in the same VPC can easily talk to each other, even though they belong to the different subnets. This is the local traffic within the same network. So I'm saying in this VPC, irrespective of the subnets the instances are launched into, they can easily talk to each other. Okay. The next target is the internet. So 0.0.0.0/0 is internet IP. It's an internet access. So in this case, what should be the destination? Internet gateway, or IGW in the short form. Okay, let me write it down. Internet gateway. So I'm saying that if the internal access is used, use a local network. But if you want to reach the internet, please make use of internet gateway. See, basically what I'm saying is that it's a kind of a GPS, right? If any traffic wants to flow internally, you give it a local route, saying use local network to talk to communicate each other internally. But if you want to reach the internet, this should be your target. This is the way out. If internet is your target, then you need to reach it through internet gateway as the destination. It's like if I want to get out of the room, I'll be using the door. So getting out of the room is my target, but what's my destination? The door. I need to reach the door to get out of the room. So if instance want to talk to the internet, it has to access the internet gateway first. It's the entry point or the exit point towards the internet. Fine. So these are the two routes that I will assign to my public subnet. So this route is used for the public subnet only. Okay. Now let me show you this thing. If I go back to the VPC, these are my subnets in my VPC in Mumbai, right? I pick the first subnet and go to the route table of it. Now, can you see this thing? Destination, the CIDR range of the VPC, and the target is local. Now, this allows internal access within. If instances in the same subnet or different subnets, but in the same VPC want to communicate with each other, they can be using the local route. And what if if the instances in the subnet wants to talk to the internet? The internet gateway is used. If I click on this internet gateway, this is the internet gateway which is attached to my VPC. Can you see that? Internet gateway, state attached, and this is the VPC. Fine. So I'm saying that if I go to the route table, this route table is linked with all the subnets of my default VPC. It ensures that the internal local access between the instances in the same VPC is done smoothly, and the access to the internet is done through the internet gateway. It's kind of a GPS. We're giving a set of instructions to the data flowing in and out. See, the machines that we are talking with, they're not intelligent machines. You need to give them set of instructions. Do this, do that. So this is a set of instructions given to them that if you want to talk to each other internally, use the local route. If you want to talk to each other externally, use this route. Fine. So a route table needs to be assigned to the subnet. If I include this route in the route table and link it with any subnet, it becomes a public subnet because it can access the internet via the internet gateway. Yeah, I need to do that. I did that by mistake. So this is my destination and this is my target. So if I need to reach the destination, that's the internet. My target, that it should hit the internet gateway. If I want to reach the destination that's internal to an instance internally, then the target should be local. Fine. So that's about the stuff. Okay. So a route table should be assigned to every subnet. Now, if this route is missing, and I assign the route table to any subnet, it remains private. So the private subnet consists of the route table, which consists of the local route only. Okay, that's it. Okay, so that's about the stuff. All right. Okay. The last thing that I'm going to discuss with you is an NAT gateway. This will complete the theory of the VPC. Tomorrow we'll do the hands-on. There's one last thing. Just bear with me for next 3 or 4 minutes, and then we can wind up. Okay. So guys, the next thing that I'm going to discuss with you is called the NAT. NAT stands for Network Address Translation or Translator. Network Address Translation. Basically, we make use of the NAT devices. We make use of NAT devices for a sole reason. What's the reason? The reason being that you need to allow the instances inside the private subnet to download some patches or to do some updates. Okay, let's do one thing. let's imagine this is my VPC. I just really quickly draw VPC for you, like make it fast. So this is the VPC in Mumbai. Okay, this is my public subnet, and this is my private subnet. I just make it quick, right? So this is my public subnet, and this is my private subnet. Now let's imagine this is my internet cloud, and I have an internet gateway at the edge or at the border of the VPC, so that the internet can be accessed by the public subnet resources. Now let's imagine in the private subnet I deploy a database. Now in the private subnet, generally you deploy your databases, which should be completely devoid of the internet access. This is a MySQL database. So in the public subnet, you deploy your web application, your resources that should be exposed to the internet. Okay, so in the public subnet, you deploy your web apps, anything that should be exposed to the internet, your web apps, your web applications. In the private subnet, you deploy your databases. You not expose your database to the internet, right? Your databases, your database is being launched, your backend application servers. So anything that should be hidden from the internet should be launched in which subnet? Private subnet. Okay. So in the public subnet, you deploy anything that should be exposed to the internet, your web applications, your websites. The backend operations, the backend databases, the backend application servers are hidden and kept in the private subnet because they don't have internet access. Let's suppose in the private subnet, I deployed a MySQL database instance. The version of this MySQL database is version 5.7.1. Now it needs to be upgraded to 8.0.28. You need to upgrade your database, right? Now, because there's no internet access, it is impossible for me to upgrade this database. Which subnet has a public access? The internet access, public subnet. But this database needs to be upgraded. So on temporary basis, it needs access to the internet. Now let's imagine this MySQL database has a private IP of 10.0.1.1, right? I want this database to access the internet, but without revealing or exposing its private IP. So in this case, I deploy something called NAT gateway, right? The sole purpose of the NAT gateway is simple. NAT gateway is launched in the public subnet with the elastic IP linked with it. So basically what will happen is that if the MySQL database needs to access the NAT gateway, it will contact, if the MySQL database needs to access the internet, it will contact the NAT gateway, because I'll assign a route table saying, if you want to reach the internet, please go to the NAT gateway. This is the route I'll be adding. Based on the route, the database will access the NAT gateway. The NAT gateway will take this request and forward it to the internet. But okay, why it is doing so? Because we need to hide this private IP. We don't want to expose it on the internet. So in this case, NAT gateway will change the source IP. Source IP means that from where the traffic request is being generated to its own elastic IP, saying I'm making the request. Okay, because if someone wants to hack into my database, the IP address should be exposed. So I'm creating an envelope, and the NAT gateway says I'm making the request. Okay, so we intentionally envelope or conceal or hide the private IP address of the instance, the database instance that's making the request. It's not broadcasted on the internet, right? Now, once it's being done, or once the traffic goes to the internet, the response comes back to the NAT gateway, and NAT gateway will point the traffic to the exact IP address of the database instance. So the purpose of the NAT gateway is that your databases can download the patches or upgrade themselves, or you want to upgrade the database, you want to do some downloading, some patching. It can be done without compromising the security, without exposing the private IP addresses on the internet. Okay, that's what the purpose is. Yeah, for security purpose. Guys, this completes our theoretical overview. Okay, so let's get started now. So guys, the next thing that the very first thing that I'll do is that I'll discuss with you the blueprint. So blueprint architecture is the one that I've showed you. Let me show you that. If you just open the Google Drive, you will see that in the Google Drive folder, this is the other document that you have. It's a JPEG image, and this document is the one that is there. you're going to be using this document as this picture as a reference architecture. I'll briefly explain you this diagram, because based on this diagram, you're going to be performing the deployment process. See, basically, you're going to be creating a VPC with a CIDR range 10.0.0.0.0.0/16. This one, right? 10.0.0.0.0.0/16. Right? Why are we using 10 dot? Because 10.172.192.168. These are the private IP address ranges, right? So I'm picking one of the private IP address range and taking first 16 bits for networking purpose or to create the entire network. Now the thing is that in this VPC CIDR range, I add 8 more bits to make it /24, and I start creating 2/24 subnets. The first subnet would be 10.0.1.0/24, fine, and the other one would be 10.0.2.0/24, fine. So in this case, I will make sure that once I pick /16 CIDR range, I will start adding 8 more bits and start mentioning /24 subnets. Okay, let me show you that on the calculator. There's a subnet calculator that we discussed or that we managed to go through. Fine. So let me show you that thing. This is a subnet calculator that we used, right? Now let's imagine if you just put the values in the calculator, let's see what happens. You'll pick /16 network address block for the VPC, right? For the subnet, you add 8 more bits. 16 plus 8, 24. Okay. So this means these many subnets you can create out of this VPC. How many subnets? 256. This is the list of 256 subnets. You can see that it will start from 10.0.0.0.0, 10.0.1.0, 10.0.2.0, and it will go down up to 10.0.255.0. Fine. So if you put that in the same value, you're going to be seeing the same output at your end. Fine. Now, how many hosts per subnet? Host means how many instances you can deploy or the usable private IPs. It is 256. So if, for example, if I pick the first subnet, this is the range of IP addresses, right, that I get, right? And this is the broadcast is used for internal purposes. But basically what I'm doing is these many IPs I get, and this is the range I can pick to define the IP addresses of my instances. Fine. So basically I'm getting 254 because 2 IP addresses are taken out. One is broadcast IP address. We don't take the initial of that. So basically 254 IP addresses we are getting. And what we're trying to achieve is that in AWS, if you have 256 IPs per subnet, we are able to use 251 because 5 are used for internal usage. So this is the complete list you will get. Now, in this case, I'll pick these 2 different subnet ranges, 10.0.1.0, 10.0.2.0, right? So if I go back to the diagram, this is what I've picked, 10.0.1.0, 10.0.2.0. Fine. These are the 2 subnets that I've picked in my VPC. So the range of the VPC is 10.0.0.0.0/16. I add 8 more bits and create 2/24 subnets out of it. Right? Now, these subnets would be linked to the availability zones. They can be linked with the same availability zones or different availability zones. It's purely based on your business needs. Okay. Now, what we deploy in the public subnet? We deploy those resources that should be exposed to the internet. For example, the web servers. Fine. So we deploy the web server or the website based applications or instances inside the public subnet. Now, inside the public subnet, it is mandatory that if you want to, there are 2 main things to make your instance fully publicly accessible or full access to the internet. What are those 2 things? One is that the instance should be launched inside a public subnet. The instance should be launched inside the public subnet. How the public subnet is defined? You attach the internet gateway to the VPC and then create a route table saying that if you want to reach the internet, then please use the internet gateway. So if you have that route linked with the subnet that gives access to the internet via the internet gateway, that becomes a public subnet. And the second thing is that the public IP or the elastic IP, EIP, write it down in the short form, should be assigned to the instance. If you miss any one of these 2 different conditions, your instance cannot get access to the internet. If you leave out any one of these two conditions, your instance cannot access the internet. So to complete those two requirements, I deploy my web server inside with subnet, public subnet, because it has access to the internet gateway. Plus, the next thing that I will do is that I'll make sure that I also link the elastic IP or the public IPs with the resources deployed in the public subnet. Fine. Internet gateway is available for the subnet, plus the elastic IPs or the public IPs are assigned to the resources inside the public subnet. This means that these resources should be fully exposed to the internet. Now, let's draw our attention to the private subnet. Now, what is a private subnet? A private subnet is a private space which consists of only the databases or the backend application servers that should be completely hidden from the internet. Hence, you will see that we don't link it with the internet gateway. IGW internet gateway is not linked with it. Plus, no public or EIP elastic IP is attached to any one of these instances. The things that are mandatory for the public subnet resources, we devoid them or we just remove them from the private subnet. We ensure that no internet gateway is linked with the private subnet. No public IP or elastic IP is assigned to any one of these instances. No public IP, no elastic IP, because it should be completely hidden or devoid of the internet access. Now, what if any one of these instances want to access the internet for temporary reasons? For example, there's a MySQL database.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
We want to upgrade its version from 5.7 to 8.0. In that case, we will create a route saying that if you want to reach the internet, please make use of the NAT device. NAT device is a special device that's deployed in the public subnet with the elastic IP linked with it. The NAT device will forward the request to the internet. In that process, it will advertise the source IP as its own elastic IP, because we don't want to put the database onto the risk, because if the traffic goes out from the database directly via the internet gateway or to the internet, its IP address, for example, there's one IP address 10.0.2.2. We want to completely conceal it or hide it or envelope it. So the NAT gateway will broadcast its own IP as a source IP, so that if there's a hacker sitting over here, he'll not be able to see what exactly from where the traffic is coming from. And the beauty about the NAT gateway is that no one can access it from outside. It's completely locked. Once the traffic comes back, the NAT will forward it to the exact database. Fine. This is the blueprint that we will follow along. This is the complete architecture that we'll go through. See, the thing is that all the things are free of cost in VPC except this guy, NAT gateway. The cost of the NAT gateway is it is 64 cents per hour, right? So we'll deploy that less than an hour. So 64 cents is the one that will show up in your bill. But we're going to remove it after we test it, right? So the cost of this entire deployment is almost 64 cents, not more than that. So the only cost that you'll bear is the 64 cents for the NAT gateway. Otherwise, every single component of the VPC is free of cost. So is this thing clear? Any questions you have from these things that I've explained to you? Are we all set? Great. So let's get started with the next stuff now. Let's start with the deployment process. See, basically, this is the document that I've already put. Now, this document, I'll show you the first few steps. In the very first step, I'll create a VPC with the default tenancy. Now, one thing, try to make sure that you choose the region of North Virginia to perform the hands-on, so that we are on the same page. So in the step one, we'll create a VPC with the range 10.0.0.0.0/16. I'll show you first few steps, and I'll show you the first 6 steps. See what I'm doing, and I'll give you enough time to do it by yourself. Okay. So what exactly you're supposed to do is, let me show you the stuff. You go to the AWS admin console, and you can easily search for the VPC on top. Okay, you can see that it says VPC isolated cloud resources. You go to VPC dashboard or the VPC console. Now, once you just go over there, this is the VPC dashboard. if you click on the VPCs, this is the default VPC that you have. Okay. Now, why we're creating a custom VPC? This is a very important point. In default VPC, every subnet is public. Every subnet is a public subnet. There is no concept of private subnet in a default VPC. Now, I'm 100% sure that in your business environment, you need the private subnets. Where you'll keep your databases in too. Private subnets only. The concept of private subnet does not exist in the default VPC. So to suit your business needs and requirements, a custom VPC is needed. You get one default VPC in each region. So if I switch to North Virginia, you're going to see that there will be one default VPC. Plus, you can add on 4 custom VPCs per region. So you get 5 VPCs per region as a limit, 5 VPCs in each region, out of which 4 are custom, 1 is default. Now, for example, in my case, I am North Virginia. I already have a custom VPC. I'm not sure whether I can get rid of it or not. I can get rid of it, right? So this is so every region will have a one default VPC. Okay, so you need to go to your VPCs on the left-hand side. To create a custom VPC, click on Create VPC. Now, there will be small variation in terms of screenshot because AWS keeps on changing the layout of their pages. It says resources to create, keep it to default, VPC only. We just want to create a VPC. If you go with the screenshot, you don't get this option, right? So that's absolutely fine. You just need to tag the VPC my custom VPC. It's a simple name that you're going to assign to it. Okay. Now it says IPv4 CIDR manual input. The range that you're going to pick up is 10.0.0.0/16. Fine. So even if you see the screenshot, the same thing is mentioned in the screenshot itself, right? So 10.0.0.0.0/16. Fine. Okay. Now there's this very small variation on this web page. Then we're not using IPv6, so we're going to skip it. So IPv4 CIDR block is this one, 10.0.0.0.0.0/16. Fine. Now it says tenancy default. Basically, if I choose default tenancy, then on a physical server level, I can easily deploy my instances on a shared physical server or a dedicated physical server. So we always keep the tenancy as default. Fine. I go ahead and click on Create VPC. So 2 things main. You have to put the name of the VPC plus a CIDR range of 10.0.0.0.0/16. Please start with the steps. Let me know once you're done. So 2 main things that you have to mention. One is the name of the VPC and IPv4 CIDR. 2 things. That's it. Except all the default values. So you assign a name and IPv4 CIDR block. Only 2 things ought to be chosen because accept all the default options. Done. Okay, coming back to the next point. See, it is a default VPC. It is a plain VPC with no subnets. Now let's create 2 subnets out of the VPC. So the next step that I will show you now, there will be no change in the screenshots, only that small change was there. I will add 2 subnets. I will show you the step number 2 from 7 to 13. See what I'm doing, and I'll give you enough time to do it by yourself. Okay, so I just go back to the subnets on the left-hand side. Click on Create Subnet. Yeah, so the subnets you can find on the left-hand side of the navigation menu. I click on Create Subnet. Now, these are the subnets that are there for my default VPC, right? So I don't need to bother about them because I don't need them because I'm using a custom VPC. So I need to create separate subnets for inside my custom VPC. So I click on Create Subnet and it says create subnet in this or inside this VPC. So say select a VPC. I'll pick which VPC? Custom VPC. Now, some people can make this mistake. They will pick the default VPC. Please don't do that because every bit of configuration would be created or deployed in the custom VPC, right? Now it says define the CIDR block. First thing first, I assign the first name to my subnet and name it as my public subnet. Fine. It says availability zone. Pick, for example, US East 1A, the first availability zone in the list. Okay. CIDR block 10.0.1.0/24. Then scroll down and click on add new subnet. So this is subnet 1 of 2. I'll add another subnet, my private subnet. Okay. Availability zone US East 1A. Choose the same one. US East 1A for the public subnet and choose the same US East 1A. Whichever availability zone you pick, make sure that for this hands-on, you assign the same availability zone or you create both the subnets in the same availability zone. And the CIDR block would be 10.0.2.0/24. Okay. So first subnet, you can see the details. Second subnet, these are the details. First subnet is a public subnet and the second subnet is the private subnet. I go ahead and click on create subnet and this will manufacture my two subnets in the VPC. Please go ahead and do that and let me know once you're done. We need /24, we're picking this name because we want to further dissect the /16 VPC. So we add 8 more bits afterwards and make it /24 subnets. Because we picked /16 as a VPC, to further dissect the VPC into multiple small chunks, I add 8 more bits and make it /24. Done? Done? Okay, great. So what we have performed so far, we have manufactured one VPC with 2 different subnets. Okay, what's the next thing? Next thing is attaching the internet gateway, right? What is the internet gateway? It is a kind of a virtual router or a virtual gateway that gives the VPC access to the internet. It's like you have a router or modem placed in your premises, maybe in your office or at your home. That router gives you access to the internet. If you take out the router, then the premises you're working in, it is completely devoid of the internet access. So similarly, an internet gateway is a virtual router or a virtual gateway that you place at the border of the VPC that gives the VPC ability to access the internet. Okay, so I'll show you the step number 14 to 16 only right now. Okay, 14 to 17. See what I'm doing, and I'll give you enough time to do it by yourself. What I will do is I just go back to the VPC dashboard or the VPC page. On the left hand side, I have this thing called internet gateways. Now you link one internet gateway with a VPC. Fine. One internet gateway is more than sufficient for the entire VPC. Say maximum you can have up to 65,536 instances in a VPC. Even one internet gateway is more than sufficient for those instances. It can handle any amount of internet traffic going in and out. And also you cannot link more than one internet gateway with any VPC. And one internet gateway is more than sufficient. This internet gateway that you can see on your screen right now on your account, it's linked with your default VPC in the region that you're in. We'll create another internet gateway for our which VPC? Custom VPC. So I click on create internet gateway and you can easily see the definition just at the top. An internet gateway is a virtual router that connects a VPC to the internet, right? So you just label this as my internet gateway. Fine. Once you assign a label to it, click on create it. But once it's created, you're going to find that it's in detached mode. To attach it, you go to actions, click on attach to VPC. You can see that attach an internet gateway to a VPC to enable the VPC to communicate with the internet. So I select the VPC right now in front of you, and we just go ahead and click on attach internet gateway. The internet gateway would be attached. So steps number 14 to 17, please perform the steps right now, and please let me know once you're done. I was just going through the documentation. So IPAM is a feature of VPC that helps in the IP address allocation to the VPC and the resources. Plus, you can easily track that how your allocation is being done and how the usage of the IPs are being done. So you can monitor the usage and allocation of the IP addresses using IPAM. So it's a tool that helps you to track the consumption and the usage and the allocation of the IP addresses in your environment. Okay, so done, simple, fine. Even though this internet gateway is created, it is there for you, but it's of no use unless and until if you link it with a subnet. See, internet gateway is there, but it needs to be available to one of the subnets. In my case, it should be available to the public subnet. See, we have labeled this public subnet, but it's not a public subnet. It is still private. It becomes a public subnet if we link the internet gateway with this subnet. So how the linking process is done? So what we're going to do is I'll show you the process from 18 to 24. See what I'm doing, because this is where you can make some mistakes. So I'll go a bit slow over here. Basically what we're going to do is that we're going to create a route table while making sure that the route table can give this public subnet access to the internet gateway. I'll explain you something before I proceed with that step. If you go to the route tables on the left hand side, you're going to find two route tables. One is assigned to all the subnets of your default VPC, and another one is assigned to all the subnets of your custom VPC. If you pick the one that's assigned to all the subnets of your default VPC, you can see that this route table, this is a route table ID, is linked with both the subnets of your custom VPC. If you go to subnet associations, and you can see the subnet associations, your private subnet and the public subnet, both are linked with the same route table. Now, if you check the route of it, it only allows the local access, which means that both the subnets and the instances inside them can easily communicate internally. So this route table, if I just go to the routes, it only allows the local access. Now the problem is that if I add a route for the internet, it will affect both the subnets. Let's imagine if I click on edit routes, I add a route. I'm explaining you something. Don't do the things right now. And I link the internet gateway, right? What will happen? If I do that, it will affect both the subnets, public and private. Now, for the private subnet, internet gateway is a big no. You never ever attach an internet gateway with the private subnet, because if you do that, you somehow define the purpose of having the private subnet at the very first place. If you're linking the internet gateway with the private subnet, then how it's private? It's public only. Now, the best approach is that we create separate route tables for the private subnet and separate route tables for the route table for the public subnet. We don't use a default one. AWS recommends that if you are not satisfied, or if the default settings they don't suit your business needs, create your custom one. Don't change the default settings. So we'll not change the default route table. We'll create a new one for the public subnet. See what I'm doing. I go to route tables. I'm not concerned about the default route tables. I don't need to use them. I click on create route table. Now what's a route table? A route table specifies that how the packets are forwarded between the subnets within VPC, the internet, and a VPN connection. Basically, it determines the internal traffic flow and the external traffic flow. So the packets, the data flowing in and out, that's being specified by the route table. The very first thing is that I specify the name for it, my public route table, fine. And I select the which VPC, custom, fine. So this route table is created for the custom VPC. It will automatically pick the tag. You need to click on create. Now, once it is created, you go to the routes of it. Now, any route table that you create by default, from scratch, from beginning, it will automatically consist of local route. Now you click on edit routes, and then you add a route with the destination as 0.0.0.0.0.0.0 and the target as internet gateway. Automatically, it will populate the internet gateway in that custom VPC. And click on save changes. Now, if we assign this route table to any subnet, it will allow the local access in the VPC with other subnets instances internally. Plus, it will allow the internet access through the internet gateway. So I've jotted down the steps. I've shown the steps number 18 to 24. Let me know once you're done. Once you're done, then I will show you how you need to associate that with the subnet. Okay, now let's go to the next step. The next step is quite simple. Once this route table is created, you need to ensure that this need to be linked with the subnet that ought to make it as a public subnet. So on this route table entry, I go to subnet associations and click on edit subnet associations. Now, which subnet are you going to pick? My public subnet. And click on save associations. So now if I go to subnet associations one more time, this has been explicitly or specially assigned to the subnet that I want to make it as a public subnet. Now, this in actuality or technically has become a public subnet because this is assigned to a route table, which gives this route table, which gives the subnet resources access to the internet via the internet gateway. Please do the steps 25 and 27. Let me know once you're done. All right. Now I'll show you this. So you have to pick the public subnet. Because any confusion you have, I would say first see the documentation, right? Because I want to do it by yourself so that you can learn by seeing the screenshots and do the stuff by yourself, so that you have to put a stress on your brain to find the things out for yourself. Okay. Now, technically, the VPC is almost created. The major components like the VPC, the subnets, the internet gateway, the route table, So most of the items of the VPC are in place. Now, the next thing that we will do is that we'll deploy one instance in a public subnet and another instance in a private subnet. The software and the hardware specs of both instances launched in the public subnet and the private subnet would be same for testing purpose, because right now we're just testing the VPC. Of course, as we proceed further, we'll understand that yeah, in the uh, VPC will keep in the private subnet will keep our databases or backend application servers. So we easy to do the differentiation at that stage. So right now we'll deploy. I'll show you the step number 28 to 39. Right. So I'll repeat what I said. We'll deploy one instance in the public subnet and the another instance in the private subnet. Both instances will have the same hardware and software specifications, same AMI, same instance type, same configuration, same key pair, even the same security group, but the subnet would be different. Okay. So I'll show you the step to deploy the instance in the public subnet first, because there are small differences. So you need to go to your EC2 dashboard, right? So I have an instance running. Let me just get rid of it. I don't need this right now. So I'll deploy my first instance in the public subnet or the VPC. So of course you have to go to your instance dashboard, right? And go to launch instances. Now for this hands-on, the AMI that you'll be picking up is the NAT device. I'm sorry, Ubuntu Server 20.04. NAT also has a different AMI for that. So Ubuntu Server 20.04, this is the AMI that you're going to be picking up for both instances. Ubuntu Server 20.04, it's a free tier eligible Amazon machine image. Free of cost, it will not charge you. So I'll be picking up this AMI, Ubuntu Server 20.04, and click on select. Of course, the same instance type we are using so far, t.micro. Now on the third step, this is where you have to make some tweaks. You have to make sure that you choose a custom VPC, because everything that we deploy or we ought to create would be relevant or would be deployed inside the custom VPC. Inside the custom VPC or for the custom VPC. Now the first instance that we ought to deploy in this step, 28 to 39, would be launched in the public subnet. So in the drop-down menu, I get two subnets, public and private. I'll pick public first. You can see that 251 IP addresses available. This means that I can launch up to these many instances inside the public subnet. Basically, it should be 256. If you see the subnet calculator, it should be 256. But one is used for broadcasting. Then the other four are used for internal usage by AWS. So we're left with 251 usable IP addresses for each subnet. The next important thing that you are supposed to do is that the auto sign public IP, which is disabled by default, it should be enabled. And this is a clear difference that you would see in the custom VPC and in the default VPC. See, in a default VPC, let me show you. In a default VPC, every instance gets a public IP assigned by default. Let me show you. If I click on launch instance and try to deploy any instance in my default VPC without giving it a thought, first thing first, every subnet in the default VPC is a public subnet. And if I pick the default VPC, the auto assign public IP is automatically set to enable. If I pick the default VPC, automatically the public IP address is set to enable, which means that every instance inside the default VPC, no matter which subnet you pick, because every subnet is a public subnet, every subnet has access to the internet gateway, will be assigned a public IP. As soon as you choose a custom VPC, you're going to see that the state will change. The auto assign public IP is changed to disable, right? So in this case, what you're going to do is that you need to go back to the, I just go back to the this page, custom VPC I chose the public subnet. I need to click on enable so that I link the public IP with this instance to be launched in the public subnet. Fine. Please ensure that you perform this step, because this is very, very important. Okay? Because if you disable it by mistake or keep it to disable, then you have to link an elastic IP. That will add on few additional steps for you. So I simply scroll down and click on review and launch. I'm sorry, click on, I need to go back. I by mistake did that. So I click on next add storage. You need to accept the default storage options. Click on next add tags. Now you need to add a tag over here. For example, to differentiate between the instances, name it as my public instance. So just type a simple name over here, my public instance, anything that you think that is you can easily differentiate between the public subnet instances and the private subnet instances. Click on next configure security group. Now we will be creating a new security group to be assigned to both instances. So I name it as, for example, VPC SG, right? And make sure that you open all the 3 ports, SSH, HTTP, and HTTPS from anywhere. We're opening these ports because we need to open the ports just for this hands-on, because we want the open access between instances and from outside. So just for this hands-on, please open SSH, HTTP, and HTTPS from anywhere. Okay. Assign a new name to the security group. Click on review and launch. Click on launch. Now create a new key pair. I label it as VPC demo -SG. I'm sorry, -KP. Fine. So VPC demo -KP. I click on download key pair, and my key pair, okay, it already exists. I name it as VPC-KP. Download the key pair and click on launch instances. Please launch the first instance in the public subnet of VPC, and please let me know once you're done. What if you just want to allow it internally accessible? Then you don't need to allocate the public IP to it. Then in that case, the public IP is not supposed to be, or it's not required in any case. So if you skip the public IP, but in this case, of course, we need to access the instance via the internet, then in this hands-on, or for this hands-on, the public IP should be assigned. Guys, please perform the steps 28 to 39, and please let me know once you're done, so that I can get the confirmation and we can proceed to the next step. Please do that real quick and let me know once you're done. The commands that we're going to practice, the Ubuntu AMI commands will help us to easily install the packages, right? So just to make sure that we all are on the same page, I want all of us to use the same AMI so that we can install the packages and connect internally. So that all of us are on the same page. So it's my humble request, please use Ubuntu Server AMI, because if you pick any other AMI, then in that case, I'll not be able to help you out in terms of commands. Okay, so that's why I picked Ubuntu AMI. Please make sure that all of you use the Ubuntu Server 20.04 AMI so that I can give you the list of commands, the common commands for all the people to run. If you pick some different AMIs, we have to run different commands to the testing. Technically, for a single person to assist 70 people with different commands is impossible. Okay, so it's my humble request to please make sure that you pick the Ubuntu Server 20.04. If you pick any other AMI in the session and ask me for the help, I'm not able to do that. Okay, any experimentation that you have to do, please do that after the class gets over. Okay, now guys, let's start the next process. What's the next process? The next process is very simple. That the next step is that we have to deploy our instance in the private subnet of the VPC, right? There will be few variations, and we'll apply few settings that we applied in the previous step. That is, so I show the steps number 40 to 49 and see what I'm doing, and then give enough time to do it by yourself. So I just go to the instance right now, instance dashboard, and click on launch instances. Now you will be picking up the same AMI, Ubuntu Server 20.04. If you pick any other AMI, I'm not able to help you out in the session itself, right? So please, it's my request, please pick this AMI only. I observe some people, they start doing experimentation even after giving clear instructions, then ask for help. I'll not do that. An experimentation, you can do that after the class gets over. Because I want all of us to be on the same page, please use the same AMI for the instance to be launched in the private subnet. Same instance type. Now we're going to be picking up the custom VPC, but this time we'll pick up the private subnet. Fine, we'll be picking up the private subnet because this instance will be deployed in the private subnet of our custom VPC. What's next? Public IP is set to disable because we don't need to allocate the elastic IP or the public IP to the instances launched in the private subnet. That's not needed. Click on next add storage, next add tags. We're going to add a tag right now and then name it as my private instance so that I can easily differentiate between the public and between the instance launched in the public subnet and the one that's launched in the private subnet. Now, on the security group page, choose select an existing key pair and existing security group, not the key pair. Select an existing security group. Pick this one. Okay. Once you pick this one, click on review and launch. Click on launch. And now you have to select or choose an existing key pair. Now, please, this is a very important step. Again, don't do any experimentation. You have 22 hours ahead of you. Do any experiment you want. But for this hands-on, choose the same key pair that you chose for the instance to be launched in the public subnet. The previous instance, use the same key pair. There's a reason behind that because we'll be using both the keys we'll be using the same key to access both instances at the same time. Fine. Please make sure you choose the same key pair that you assigned for the previous instance, because later on you will see that the same key pair will be used to access both instances using the same shell prompt. Choose I acknowledge. Click on launch instances. Let me know once you're done. Or please launch your instance in the private subnet and let me know once you are done. Ravi, you have to go with the documentation. Based on the documentation, you have to pick the same security group, choose an existing security group, and pick the same one that you created for the previous instance. So let's do the next part. Is anyone using Mac over here? Is anyone using Macintosh? Okay, all right. So basically what we're going to do is that we'll follow along a process which is a bit weird, or it's a first time process that we're following along. Basically what we're doing is that we are using the same key.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
And the same shell prompt to connect to both instances at the same time. So why we're doing so? See, basically what we are trying to achieve is we are trying, so let's suppose this is us. This is an admin. Okay. So this administrator, what he's trying to achieve is that he will SSH to one of the instances in the public subnet. How? Because this instance has a public or the elastic IP and it has access to the internet gateway. Right. Now, we also need to SSH to the instance in the private subnet using internet. Now, the scenario that we are following, or the scenario that we are in right now, the situation that we are looking into right now doesn't gives us the internet access to the instances in the private subnet. Why the internet? So we don't have the internet access for the instances launched in the private subnet. So the other way around is that we can internally SSH to the instance launched in the private subnet. How is it possible? Because of the local route, which is there in all the route tables. Which local route I'm talking about? The local route that I'm talking about is this one, which allows a free local access internally between the subnets of the same VPC. So this local route will ensure that I can locally access or SSH to the instance. That's why I open the port 0.0.0.0.0 for the SSH, so that I can, just for the testing purpose, just for the sake of testing, I can do that. I could have also allowed the SSH from this IP, but this would unnecessarily confuse you. Okay, we could have also done that, but just for the testing purpose, I allow the SSH from all the ports, from all the IP addresses. I'm sorry, not all the ports. Now, the next thing that so we will do that. Now, how in reality this can be achieved? Basically, you'll be using the same CLI or the shell prompt, right? The same CLI and the shell prompt will be used, right? The same CLI and shell prompt will be used. The very first step is that you have to upload the key to it. The second step is that you have to SSH to the instance launched in the public subnet. And then from there, internally, you need to SSH to the instance launched in the private subnet. This is a 3-step procedure that you have to perform to achieve this type of capability. Now, the process to upload the key and to SSH to the instance in the public subnet first, and then to SSH to the instance in the private subnet in the third step, the process is different on the Mac compared to Windows. I'll show the Mac first. For the Macintosh, the good news is that you don't have to install any third-party software. It's pretty simple. You need to open your terminal window. So let me open the terminal. And the step that I'm showing you is the step number 50. Step number 50, right? Under step number 15 for Mac OS, you can see the processes is different. So step number 50. First thing first, I'll show you for the people who own Mac OS, including myself. So for the Mac people, the process is very, very simple. Only a matter of two or three commands. So for the Macintosh, what you have to do is you have to go to the place where your key is being saved. Because you're using the key for the very first time, just type in chmod 400, name of the key, so that you can change the access rights of the key. Now to upload the key, simply run the command ssh-add and type the name of the key. In the documentation, -k is also included. You can ignore it because sometimes -k doesn't works. If you go by the documentation in the step number 50, based on step number 50, it says ssh-add -k. You can skip -k if you want, right? So ssh-add, name of the key, press enter, your key is added. It is only these three commands you have to run on the Macintosh. Okay. Now, once you add the key, of course, then you can SSH to the instance, right? So for the Macintosh people, this is the simplest thing that you have to do. You have to add the key. Okay. Please proceed and let me know once you're done for the Macintosh people. Now, what about the people who are using Windows? Now, for Windows, of course, you have to rely on a software that's called Pagient. Now, I'm showing the process on. Okay, one thing for Windows guys, I want to show you one thing. So Mac guys, for the Macintosh, once you add the key, then you SSH to the instance in the public subnet. Just type in SSH-A, then type the username of the instance Ubuntu @ you need to copy and paste the IP address of the instance launched in the public subnet. SSH-A Ubuntu @ paste the public IP address of the instance launched in the public subnet. Just type in yes and you should be connected. So this is for the people who are using Macintosh. You add the key and please log into the instance in the public subnet. Okay, for the Mac people, it's done. For Windows, you have to rely on a software that's called Pagient. I asked you to install PuTTY, and Pagent software. First thing first, you need to use PuTTY to convert the key into PPK format. Okay, so what's the process? So I'm showing you the process numbers, the step number 50 only, but this is for the people who own Windows. Okay, now how to convert the PEM key to PPK key? Okay, just in case, I know that there will be few people who are still not aware of that process. If you go to the document, connect your Linux systems from Windows local machine, then you can follow this document. Basically, you have to convert the key from PEM to PPK format. Okay, so I go back to my Windows computer, open PuTTY and convert the key now. So basically the thing is that I'm using Windows Server because I don't have the Windows computer. The font would be a bit on lower side, so please bear with me. So I open PuTTY key generator, go to file, load the private key, which key I'm talking about, the PEM key. So make sure that you upload the PEM key and press open. Once it's uploaded, click on save private key and please save the same private key in the PPK format on your desktop. Fine. Once the key is converted, then you already have the Pagent software up and running. What you have to do is that once you have the Pagent software installed, there's a hat symbol showing up in the timepiece. Some people call it timepiece, some people call it as a system tray. At the bottom right hand corner, a computer with a hat symbol. You have to right click on it and you get some options to play with. Click on add key and add the PPK key and press open. You'll not get any prompt. The key would be added to your Pagent software. I'll show you one more time. You right click, the computer with the hat symbol at the bottom right hand corner in the system tray. Click on add key, choose the key, the PPK key and press open again. This will add the key in the background so that the same key can be used to access the instance in the public subnet and then access the instance in the private subnet. Fine. Now, once you are done with this, once you are done adding the key, then what you do is you're going to be using the PuTTY to connect. Once you add the key, you convert the key, you add the key to the Pagent software, then you use PuTTY. Fine. Okay, let's do one thing. just do this step. For Windows guys, I'll not go further because it's a bit confusing. Step number, yeah, please go to the step from, for Windows, 50 up to D, A to D, 50 A to E. Let me know once you're done. You have to convert the key via PuTTY. Convert the key first. Once you convert the key, then private, right? Fine. Now guys, I'll show you the next step, 50F, and then we'll wind up. In steps on 50F, what you have to do is you need to use PuTTY to connect. Okay, so I download PuTTY. Now the steps are very well documented. They're very well documented in the documentation. Because I'm using Windows Server, I don't have Windows Computer. I'm using Macintosh. The fonts are little small, so please bear with me. Once you open PuTTY, it will ask you for the host name. You have to mention the public IPv4 address or the public DNS name of the instance launched in the public subnet. So I'll choose my public instance and I pick the public IPv4 address of it. Go back and paste that in the host name. Now, if you expand the SSH on the left hand side and go to AUTH, there's one option that you have to select, that is allow agent forwarding. Now you may not be able to see that on my screen because the fonts are too small. If you see the documentation, then easily it shows you this screenshot, this one, allow agent forwarding. Where you upload the key, you don't have to upload the key, you have to choose allow agent forwarding. Once you choose allow agent forwarding, please press open, click on accept. Now I will increase the font size of the terminal session because I have the capability to do that. Now it says login as, just type in Ubuntu and you're able to access the or get access to the instance launched in the public subnet. Agent forwarding means that you're not uploading the key. The key is running in the backend in the pagent software. That key would be automatically used to access the instance in the public subnet. Okay, so guys, let me know once you're done with this. If you're done till step number 50th, only do one thing before you log out is you can stop your instances. Okay, so that the 750 hours that you get for running is because we're going to be consuming this or using this instances tomorrow. So the only thing that you have to do is that choose your instances and stop them before you leave. Okay, so guys, let's get started with the next step now. So the next step is that once you just connect, so let me just reconnect from my side. So I just reconnect from my end. So because I'm using Mac, I'll be using I'll be uploading this key now. Now I will just connect to the instance launched in the public subnet. So yes, I just go ahead and connect to the instance launched in the public subnet. Just did that, right? Now once I connect or gain access to the instance launched in the public subnet, the next thing that I'm supposed to do is I need to try to install the update. So the step that I'm going to show you is step number 51. So in this step, what we're going to do is that I run the command sudo apt get update, sudo apt get update. Now it should install the updates successfully. That's the expected outcome because the instance is launched in the public subnet. Plus it has the public IP assigned to it. So it has full access to the internet. We should be able to download the updates to it. Please perform step number 51 and let me know once you're done. So if you've configured the previous items properly without any challenge, any issues, the installation of the updates should be successful. Yeah, that's the expected outcome. Okay, if the instance has no access to let's suppose if the instance has no access to the internet, then it cannot download the updates. If the instance has no access to the internet, it is impossible for it to install the updates. So to test whether the instance has the full internet connectivity, it is completely exposed to the public network, to the internet. That's why we are running the command to test it. Now, what's the next thing you have to do? The next thing that you have to do is you need to perform the step number 52. In the step number 52 is what's the step number 52? Step number 52 is very simple. You need to go ahead and from here, you need to connect to the instance launched. You need to connect to the instance launched in the private subnet. I'm sorry. So right now we are logged in to the instance launched where in the public subnet. From here, we'll just use the internal local route to gain access to the instance launched in the private subnet. So I will go back to my AWS management console, just fetch the private IP address of the instance launched in the private subnet. Okay, so I'll fetch the private IPv4 address of the instance launched in the private subnet. I go back to the terminal. I just type the command in front of you, SSH. Then the user ID is Ubuntu. The commands are same whether you're using the Windows or the Mac OS terminal. @ paste the private IP v4 address of the instance launched in the private subnet. Press enter, just type in yes, and you should be able to connect. Let me know once you're done. So the step number is 52 that you have to perform. See, what's the next step? The next step is that we are connected. So step number 53, we're trying to connect. Now we will we have connected to the instance launched in the private subnet. Now try to install the updates. Run the same command sudo apt get update. The same security group is assigned to this instance as well. But if you try to install the update to the instance launched in the private subnet, it will time out. Right? So security group just perform the restrictions. That's it. But the internet access is given by the IP at public IPs and the internet gateway. Yeah. So that expected outcome. If you try to install the updates to the instance launched in the private subnet, it's doomed to fail. It should fail because there's no internet gateway working behind the scenes that's linked with the private subnet. Plus, we didn't assign a public/elastic IP to the instance launched in the private subnet. Fine. So now, what's the next step? We discuss the concept of NAT gateway or the NAT device. The purpose of the NAT gateway is pretty clear and simple, is that to allow the instances launched in the private subnet to access the internet on temporary basis or whenever required. Because generally the instances that we launch in the private subnet, they don't need access to the internet. Why a database need access to the internet? But there are some temporary situations where, for example, we need to upgrade our database. We need to apply some patches, do some maintenance, do some type of upgradations, which somehow needs internet access on a very occasional basis. Even it's occasional, we don't want the internet gateway to be linked with the private subnet, because internet gateway, it gives the open internet access and it has no mechanism to shield the instances launched in the private subnet. So we're going to be using NAT gateway. The NAT gateway, if you see the diagram that we discussed, if I just go back to the VPC document, based on this architecture, the NAT gateway should be launched in the public subnet with elastic IP attached to it. Right? Now, NAT gateways need to be linked with elastic IP. They don't work with the public IPs. Now, a word of caution. The NAT gateways are not free of cost. It will cost you 64 cents as soon as you launch it on an hourly basis. So this means that once we launch it, before 60 minutes gets completed, before the completion of an hour, we need to remove the NAT gateway. But of course, even if you remove it before the completion of 1 hour, 64 cents would be show up in your bill, right? So if you don't wish to test NAT gateway and pay the bill 64 cents, don't deploy it, right? You can stop right now. But you don't mind paying 64 cents for the hands-on, then go ahead and deploy it. Yes, but it's important that before the completion of 1 hour, I'll guide you through how to remove the NAT gateway. Now, the thing is, I'll show you the process how to deploy a NAT gateway. So I'll show you the step number 54 is done. So I'm showing the steps number 55 to 58. See what I'm doing. Steps 55 to 58. So what I'm going to do right now in this case is I switch back to the VPC service or the dashboard. Let's go there. Now, once I just go to the VPC dashboard, the next thing that I'm supposed to do is you can easily see the NAT gateways on the main page, or on the left side in the navigation menu, the NAT gateways is visible to you. You can just go to either of these two options. Now, again, I'm saying this will cost you 64 cents on an hourly basis. Otherwise, other components that we have deployed are free of cost. They don't charge you anything. So I click on create NAT gateway like this. And the very first thing is that you allocate a label or you assign a name to this gateway. And this is a very important thing that you have to do, that you don't do the wrong step, is that you choose the public subnet of your VPC. A very common mistake that people do is that they choose a private subnet, think that the NAT gateway is used for the private subnet, then of course it should be launched in the private subnet. It's a misconception. Even though the NAT gateway is used for the databases launched in the private subnet, however, it should be launched in the public subnet because it should have full internet connectivity. So once you label the NAT gateway, it is very, very important that you encapsulate it in the public subnet of the VPC. Connectivity type is always public. I'm not sure why they're using private for the NAT gateway, but it's always public only. I don't think you'll fall into any situation where the NAT gateway has to be kept private. It's always public. You click on allocate elastic IP. Click on allocate elastic IP. The elastic IP is allocated to the NAT gateway immediately behind the scenes. Click on create NAT gateway and your NAT gateway is created. Please type on done once you're done. Then I will show you how to link it with the private subnet using the route table. Done? Okay. So what's the next step now? So even though this NAT gateway is being produced, it's created or it's manufactured, we need, because if the NAT gateway has no access to the internet, then how it can help the instances launched in the private subnet to gain internet connectivity. If itself has no internet access, then how it can allow the databases to download the patches? We're choosing public subnet because it should have the internet connectivity. So what's the next step now? This next step is 59 to 68. So see what I'm doing? So what you're supposed to do is you need to go back to the VPC dashboard and go to the route tables on the left hand side. Now, if you remember, yesterday we created a different route table for the public subnet. Now we create another one for the instance launched for the instances to be launched in the private subnet. So a different route table for that. So I click on create route table right now in front of you, and I label it as my private route table, and I choose my custom VPC. Please make sure that you choose a custom VPC only. Don't by mistake choose a default one. Click on create route table. Now I go to the routes. The local route is there by default. Click on edit routes. Now I'll add a route to the internet with a target as NAT gateway this time, right? So I'm saying that if you want to access the internet, then the NAT gateway is supposed to be used. If you're trying to use the internet, then your target should be the NAT gateway, not the internet gateway. And click on Save Changes. So in this case, we have added a new route, which is if you want to gain access to the internet, please make use of the internet gateway. Fine. Now I go to subnet associations, click on Edit, and I choose my private subnet and click on Save Associations. So what I did is that I created this route table, adding a new route which allows the internet connectivity via the NAT gateway, and then I use the concept of subnet associations to link my private subnet with this route table. Please perform the steps 59 to 68 and let me know once you're done. NAT gateway has a different purpose. We are connecting via the public instance, has a different purpose. So, and if your question is that why we're trying to connect to the instance launched in the private subnet, why the public subnet, even though the NAT gateway is there, the purpose of the NAT gateway is not to connect to the instance, right? The purpose of the NAT gateway is not that you use the SSH to connect to the instance. NAT gateway is not designed for that purpose. It is purely designed for allowing the HTTP or HTTPS traffic from the internet. So we're connected to the instance via the public subnet because NAT gateway is not designed for that. You don't connect to the instances via the NAT gateway. The purpose of the NAT gateway is only one sole purpose: to allow the instances launched in the private subnet to download the patches in a secure way without advertising their private IPs over the internet. That's it. There's no other purpose of the NAT gateway. Now, in the last step, step number 69, what you're supposed to do is, if you try to, because we are still connected to the instance launched in the private subnet, I run the command sudo. So I'll repeat the step number 50 and connect back to the instance launched in the public subnet first. Now I just SSH to the instance launched in the private subnet because I got disconnected. And now because I've deployed the NAT gateway, previously I was unable to install the updates to the instance launched in the private subnet. Now I run the command sudo apt get update. I should be able to install the patches now because I just linked the NAT gateway with the instances launched or with the private subnet. Now it says that sudo apt get update in release. Yeah. So if you try to install the update, it should work for you. In my case, I'm not sure why the update is working. So hang on 1 second. I just check. Yeah, I'm able to ping the website or google.com, so it is responding me. Yeah, I'm able to ping. So this means that this is working. Okay. So even if you just type in ping google.com, ping any website, you should be able to ping the website. Just in case if the package update is not working, as it didn't work for me. So that's about the stuff. This simply means that now this instance launch in the private subnet has access to the internet. Fine. This completes our hands-on. So guys, this completes our the VPC part, especially the deployment process. Now, I just help you with a cleanup process because NAT gateway is not free of cost, so it needs to be removed before the completion of an hour. So what you have to do is that I'll help you with the removal process or the cleanup process. You have to go to the NAT gateways, right? If you're getting the output, you're able to perform the steps number 69. Please go to the NAT gateway, choose the NAT gateway, go to actions and click on delete NAT gateway, and please let me know once you're done. you need to just go to the NAT gateway, right? So please go to the NAT gateway, choose it, go to actions, and then you get the option to click on delete NAT gateway. Once you hit delete NAT gateway, then you should be able to just type in delete over here, and just click on delete one more time, and this will just wipe out or initiate the process of the NAT gateway removal process. So your NAT gateway would be removed. So it will show the process is deleting. Let's wait for some time. It will take 1 or 2 minutes for this to get wiped out, because this is the only component that is paid. Otherwise, every single component of the VPC, the route tables, the subnets, the internet gateway that we've deployed so far, they're free of cost. So the NAT gateway is chargeable. Now, once the state is deleted, on the right hand side of it, it shows the Elastic IP address. Click on the Elastic IP. It will just take you to the Elastic IP dashboard. You need to choose Elastic IP, go to actions, and click on release Elastic IP. Let me know once you're done. For few people, this sometimes it is grayed out. If it's grayed out, then you have to wait for next 1 minute. Hit refresh one more time on the top, and then it shows up. Okay, so you have to go to actions and click on release Elastic IP address. Now, for few people, it will be grayed out. This option will be disabled. Nothing to be concerned about. You need to patiently sit there for at least 1 minute. Hit one refresh. Go to action one more time. Click on release Elastic IP address. Click on release, and please release Elastic IP from your account. So because the NAT gateway is removed, the Elastic IP of it is released. The next process that will follow along is to terminate the instances. So you have to go to the instance dashboard, the EC2 dashboard. Please select your instances, go to instance state, and click on terminate instance. Now, because especially I don't need these instances anymore, it's better to terminate them. So please select your instances that you launched in this VPC. Choose them, go to instance state, and choose terminate instance. So please wipe out or terminate these instances because you don't need them anymore. They're of no use. Are we done terminating the instance or instances? Both instances need to be terminated so that you don't exhaust the 750 hours of free running instances, especially for Linux, because you get 750 hours for Linux per month, 750 hours for Windows per month. If you exceed that limit, then the charges would be imposed or will show up in your bill. Okay, that's been done. So NAT gateway is removed, its Elastic IP is released, and the instances are being terminated. Fine. Now you just go to the VPC now, go to the VPC dashboard. You have to choose your custom VPC. Now, please, it's my humble request, don't by mistake. You don't have to catch a plane or train. You'll not be rewarded by if you do it very fast. 10% of the people accidentally delete the default VPC. Default VPC should not be deleted because it's very hard to get it back. Choose your custom VPC. Okay, if you are dozing off or you're confused right now, don't delete the VPC because it's free of cost. Make sure you delete that VPC with the range 10.0.0.0.0/16. Okay, go to actions and click on delete VPC. Now, once you initiate the process of removing the VPC from your page, it removes these resources: the internet gateway, route table, subnets, and it will also additionally remove the security group of the VPC. Basically, it will remove every single resource of the VPC, including your security groups, because the security groups are the VPC related resources. So your security groups, your gateway, route tables, subnets, everything would be deleted. Okay, so what you have to do is that you need to just type in delete like this, click on delete one more time, and let me know once you're done. Fine. Okay, so guys, this wipes out the entire stuff, and this completes the VPC deployment process. So guys, let's start with the next stuff now. So CloudWatch is a tool to monitor the performance of your resources, and it's that resource that you use to gauge the performance of every single, or I would say most of the resources performance are being analyzed and gauged using the concept of CloudWatch. Let's try to understand the CloudWatch. So why exactly you need the CloudWatch? See, whenever you run any resource in any infrastructure, be it on premises, be it cloud infrastructure, whatever infrastructure that you own and you deploy resources into, right? It is very essential that you always have a deeper insight, and you can easily gauge on that how exactly that instance is performing, that volume is performing, the database is performing, the gateway is performing. You always need to be on toes and gauge the performance of the resources, so that you need to understand that whether the resources are performing up to the mark or not. Now, if you remember, we use CloudWatch in auto scaling. Now we created a scaling policy, application request count per target, that metric that we used in the auto scaling concept or deployment, we use CloudWatch. So whether it is automation, whether it is monitoring, CloudWatch has a very big role in your infrastructure. Now, CloudWatch we discuss in a lot detail in the SysOps certification. But in the Solutions Architect Associate, we discuss the basics of it, understand the functions of it, the implementation of it, and there will be a single hands-on on the CloudWatch. So let's understand CloudWatch. What are the functions of it and how it operates? See, CloudWatch is a default monitoring tool that you're going to be using. So if your resources performance need to be analyzed and gauged on, so if you want to analyze any resource performance, you need to have CloudWatch. And I've discussed with you the CloudWatch before at the time when we discussed the EC2 part. Okay, it's a default monitoring tool. So I guess if I just go back to the previous notes, I discussed with you just after the security groups. Yeah, here we go. This is the one. So just before the after we discussed few concepts like security groups and tenancy options, this is what we discussed. See, CloudWatch is a default monitoring tool. Basically, how it functions, how it operates. Or what are the three functions? The three main functions of the CloudWatch are the following. The first one is that, of course, it monitors the performance of the resources. The second thing is that it can send you the alerts or emails. If I say send alerts, I'm talking about the emails to you, just in case if a threshold is being breached.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job. Now let's continue with the session.
Right, you're being alerted if something is going wrong in your environment, and you want to fix it as soon as you can. So it will alert you that there's something inappropriate happening based on expectations. Maybe the CPU usage, CPU utilization of the auto scaling group is very high. There's a high amount of traffic coming in, or maybe a resources is not performing up to the mark. Whatever the problem might be, it sends you the alerts based on the conditions and the metrics that you define. It will send you the alerts. Plus, it can perform few actions on your behalf. It can perform few actions on your behalf. For example, there are few EC2 actions it can perform. Let's suppose, what are the few EC2 actions? You can say that if the CPU utilization of any instance is less than equal to 30%, then either you can just go ahead and you can either stop the instance or you may terminate the instance. So it can take few actions automatically. It can either stop the instance or it can either terminate the instance. So based on the conditions that you set in, what's the condition? That if the CPU usage of the instance is less than 30% because it's not being used to the optimal level, then please stop or terminate the instance. So it's a default monitoring tool. It sent the alerts just in case if the threshold that you set is breached or the conditions that you specified are not met. Plus, it has a capability to take few actions on your behalf, the automated actions. It can stop the instance or it can terminate the instance. It can reboot the instance as well. It can reboot the instance. So it can take few actions automatically just in case if conditions that you set based on those conditions, if some thresholds are breached, then in that case it will perform either of these three actions. So it can take few actions on your behalf. It can monitor the performance of the resources. It can send you the alerts. Now, when I discussed with you the EC2, I briefly discussed about the CloudWatch. So how the CloudWatch operates? Basically, the CloudWatch operates based on something, a concept called metrics. What I'm talking about? Metrics. What are the metrics? Metrics are nothing but these are the parameters against which a resource performance is being gauged upon. For example, if I want to decide that what's the performance of a marathon runner, what I will say, the distance covered and the time consumed. So if a marathon runner has covered 10K distance and let's suppose an hour, so I will take distance and time as two metrics to decide that how that marathon runner has performed. Okay. Similarly, how exactly a resource performance is being analyzed or gauged on based on the metrics. Every single resource has its own metrics. EC2 instance has its own metrics. EBS volume has its own metrics. Database has its own metrics. The DBS instance, the database instance. For example, let's see the EC2 instance. EC2 instance has some metrics to start with. For example, CPU utilization, number of packets coming in, number of packets going out, to name the few. So based on these metrics, the instance performance can be analyzed and gauged upon. Now, let's suppose that I just deploy the instance. Immediately, the instance will push those metrics to the CloudWatch. The CloudWatch will ping the instance or perform the health check towards that instance every 5 minutes. It will access the instance. It will perform the health check towards the instance by default every 5 minutes and get the fresh statistics out of it. So for example, at 11 a.m. UTC, the exact CPU utilization, which is a metric, has a value of 70%. So the CPU utilization metric has a value of 70%. I, as a server administrator, can log into the CloudWatch dashboard and exactly see the real-time performance of the instance in terms of the CPU utilization. Now, if you want to decrease the frequency to a minute or less than that, it comes under the detailed monitoring. Fine. So the main thing that empowers the CloudWatch are the metrics. Based on the metrics, every resource has its own metrics. The CloudWatch is able to gauge upon the performance of that specific resource. The metrics are pushed to the CloudWatch, and based on those metrics, you get the real-time statistics or the performance of that resource. So apart from monitoring, it can send you the alerts via the emails. Plus, it can also be perform few actions like rebooting the instance, terminating the instance, or stopping the instance based on what conditions you have put in. Fine. This is the overview of the CloudWatch. Okay. Now, in this case, we'll also be using the SNS, the simple notification service feature, to send us the alert or the email just in case if the CPU usage of an instance is high. Okay, we'll set a threshold, for example, 70% in this case, or 90%, whatever threshold we can set in. Now, what's the purpose of this document? The document says that you need to create a CloudWatch alarm that will send you the notification using the SNS. SNS stands for Simple Notification Service when the state of the alarm changes from OK to alarm. Okay. Now, why it will send it to the alarm state? Because the average CPU of the instance, the CPU utilization of the instance is exceeding a certain value that you've set. What's the first step? I'll show you the step number A and give you some time to do it by yourself. Then we go step by step and perform all the steps. In step A, you have to launch a simple instance with very basic minimal settings. So step A is very simple, but you have to make sure that you choose the Amazon Linux instance. So I'm showing the step number A, and then I'll give you 1 or 2 minutes to do it by yourself. So step number A, you have to just go to AWS Management Console, right? Just click on Launch Instance. Let me just go back to Instance page. Click on Launch Instance. Please make sure that for this hands-on, the AMI that you have to pick is the Amazon Linux 2 AMI, right? Please click on Select. Now you have to choose the instance type, that's the T2.micro. Click on Review and Launch. So don't click on, so basically you don't have to go through every step. On the second step only, where it says choose an instance type, just simply click on Review and Launch. Don't go to next configure instance details because we don't need to configure any security group, any EBS one for that one. Just on the second step where it says choose an instance type, click on Review and Launch. Launch. Just choose proceed without a key pair. Hit acknowledge that I can deploy the instance without using the key pair. Click on Launch Instances. Let me know once you're done. It's there in the document. It's very clear. Go to the step A and launch a simple instance. So a simple step, you have to create a launch an instance with very basic minimal settings, but make sure that you choose the Amazon Linux 2 AMI to deploy the instance because the Linux commands we're going to be running will be based on that AMI. Done. Simple. What's a B step? B step is that now you have to set the CPU usage alarm on the AWS Management Console. Now I'll break the B step into multiple chunks because it's very lengthy. In step B, we will start with the creation of the CPU usage alarm. The instance that we just launched in just few seconds. So if you check the instance and go to monitoring, this is the CloudWatch feature only. These are the metrics that you can see that based on which the CloudWatch will gauge on the performance of my instance, and these are the metrics. right? So based on the documentation, I'll show you the B step. In the B step, I'll pick first few steps, 9, 10. Okay, so I'll show you that how you need to create an alarm. So I'll show the step number 9, 10, 11, 9, 10, 11. Okay, so step B, or steps number 9, 10, 11, I'll show you exactly steps 9 to 11. What you have to do is that check the instance, go to monitoring, right? Under monitoring, it says CPU utilization and the 3 dots. Go to the 3 dots and it says view in metrics. Basically, if you just go to view in metrics, it will open the CloudWatch page or the dashboard, right? So it will open a new tab for you. A new tab will open up where the CloudWatch console will show up. This is the CloudWatch dashboard. Now on this CloudWatch dashboard, it selects the instance that we just launched with the details of the CPU utilization. Now, just on the right hand side, it says actions. Under action, there's a bell icon. You click on this icon, this bell icon is to create an alarm to send you the notifications or to alert you if a threshold is breached. So I go to this alarm and automatically it opens the specify metric and conditions page. Now in step number 11, what you have to do is that step number so please let me know once you're on this page, then I'll move you to the next step. Done. Okay, now the next step that I'm going to show you based on the documentation is a steps number 12 and 13. So I'll show you the steps number 12 and 13. I want to go a little bit slow because I don't want you to be confused right now. In steps number 12 and 13, basically, because I want to explain you a few things as I go along. What's the metric name? It's a CPU utilization. This is the instance ID. Now, the statistic is average. We take the average CPU usage in a specific period or time frame. Now, decrease the period to a minute. Don't go less than that because it will be too fast in that case. Why we changing the period to a minute? So that in a minute we should get the output, or it should send us the alert as soon as the threshold is breached. Fine. So I'm saying that every 1 minute you need to gauge on the performance of the instance, and if a threshold is breached, then send me the alert. Scroll down, then you have to set the condition based upon which the alerts are generated. Threshold type would be static. You want to define a static value. And then it says whenever the CPU utilization is greater than equal to, lower than equal to, or lower than. Based on the documentation, I think I've set it 70%. Yeah. So I will say greater than, and the value is 70. Now, if I say put 70, it is 70% only. You don't have to put in percentage sign, just define as 70. Okay. So I decrease the period to a minute, and I say that if the CPU utilization is greater than 70 value, then this alert is generated. You don't have to change the additional configuration. It says what's the number of data points that need to be evaluated for the alarm to be generated. It's not that much important. It's an advanced feature. Please perform the steps 12 and 13. Let me know once you're done so that we can proceed to the next page. Done? Okay. What's the next step now? I'll show the step number 14 to 19. See what I'm doing, and I'll give you some time to do it by yourself. I go back to the CloudWatch console and click on next. Now it says that in which state the notification has to be triggered. Notifications means that I will be alerted or send an email. Of course, in an alarm state, you always want the emails to be triggered. So under the alarm state trigger, it should be set to alarm. It says select an SNS topic now. What is SNS? SNS stands for Simple Notification Service. We create a topic to receive the notification. Okay, so you have to choose create a new topic and enter any random name. I name it as, for example, demo or my new SNS topic. Topic means that if it is a capability to send you the alerts. Now you specify the email address of yourself, okay, so that you are being notified just in case if an alarm gets generated. Now, if you want multiple email addresses, give a comma and then specify the email address like this. Give a comma, give a space, and then you can specify another email ID. So you can include multiple email IDs in this email endpoints section. You name the SNS topic. You define the email addresses. You can define one only if you want, but if you want to define two, give a comma, a space, and define the second one. Then click on create topic. This creates a simple notification service topic with the two email endpoints. Fine. Once it's been done, you have to open your mailbox and accept the subscription. So I'm going to just open the mailbox real quick. You just allow me a second over here. So immediately it says AWS notification subscription confirmed. I go over there and click on confirm subscription. What is this subscription confirmation? This means that I'm able to subscribe myself so that I'm eligible. My mailbox can receive the alerts in the future. If I want to do it for the second mailbox, I'm not sure. Let's see that if I can just log into it. So I just go to my second mailbox now in front of you. I just go to the second mailbox. I just open the email. I just get the subscription confirmation, click on confirm subscription, and my subscription will be confirmed. This means that now this second mailbox will be able to receive the alerts in the future. Once the subscription is confirmed, you're good to go. Scroll down. Do you want to perform any action? I would say no action as of now. So we'll not perform any action at this stage. If I click on, for example, add is to action, I can stop the instance, terminate the instance, or reboot the instance, but will not include any action. I just want to show you as an FYI. Once I create the topic, subscribe on behalf of subscribers, confirm the subscription on behalf of these two email IDs, click on next. I assign a name to this alarm. So I name it as high CPU alarm. Okay. Click on next and then click on create alarm, right? Let me know once you're done. Steps number 14 to 19. You will get the okay. So basically, what you will get is that you will get the insufficient data message. The reason being because you just created the alarm, so you don't expect it to just give you the state okay or alarm immediately. That the two main states, okay, which means that it's within the threshold that you have defined. Alarm means that it's above the threshold or lower than the threshold that you have defined. Okay, so please complete the process of the alarm creation. Please let me know once you're done. Just tap in done. Once you're done, you have completed steps number 14 to 19, which means that you have completed the process and you have created the alarm. So your alarm will be created. Done. I'm just waiting for next few seconds before we can just move the next step. So if I hit refresh, I would say that next 1 minute maximum, it will just go to the OK state. Shravan, this is a one-time process. Every subscriber has to accept the subscription once. It's not every time that you will do it. The subscription has to be confirmed from a single email ID or individual email ID once. At least once. It is a one-time process. If you have, for example, 10 people or 20 people who want to monitor a server, all the 10 or 20 people need to subscribe themselves. It is mandatory. Now, what's the next thing? You need to SSH to the instance. So if so, I'll show you the step number C. Step number C is to connect to the instance, right? So step number 20 and 21, let me show you that how it needs to be done. You need to just go back to the instance dashboard, choose the instance, and click on connect. Now it's a browser-based connectivity option that we're using this time. I go to EC2 Instance Connect. Don't change the username. The default username EC2-user to get access to the instance. Click on connect and please let me know once you have connected to the instance. So we're using the browser-based utility to get access to the instance. Now, what's the next step? The next step is step number D. You have to run. So basically, we want to install a stress package and we want to ensure that we can bump up the CPU usage of the instance, the CPU utilization of the instance. So you have to do the step number 22. See what I'm doing? And then I'll give you enough time to do it by yourself. In step 22, you have to make sure that you can copy the first command. This one, sudo Amazon Linux extra install EPEL-y. You go back and paste it. Okay. Now, basically, I've included a dot in the front. Remove that dot. It should be sudo Amazon Linux extras install and the package, right? So once you install this package, then you have to install the stress package. I go back and install the stress package. Make sure that you remove the dot in the front. Sudo yum install stress. Install the stress package. Both the packages need to be installed. Let me know once you're done. Step number 22. Install both the packages. You can copy and paste that. Please make sure that you remove the dot in the front at the time when you paste it. Done? Okay. Now, once you install this package, the next command, step number 23, is you have to pump up the CPU utilization of the instance intentionally. Run the command stress-c number 5. Press enter. It will dispatch some hawks and bump up the CPU usage of the instance. Now, for few people, this gets stuck after few seconds. If that's the case, you have to reconnect to the instance and do that. But if you have initiated this command, then in this case you go to step number E, and in the next step what you have to do is step number E. Just copy and paste that step. You have to monitor the CPU utilization of the instance via the CloudWatch. How you do that? Let me show you. You have intentionally bumped up the CPU usage of the instance. If you go back to the instance dashboard, basically the problem is that if you click on cancel, it may cancel this connectivity. So what you can do is that you can try to open EC2 in a different dashboard so that you don't cancel it out by mistake, right? And then you just check the instance. You check the instance like this, go to monitoring, and you expand the CPU utilization, and you will see that it will spike up now. It is going to spike. You hit refresh, you're going to see that there will be a spike in the terms of CPU usage. Now you have to make sure that this thing doesn't get disconnected. If I press Control Z, it stopped. I display the hogs one more time, making sure that it's running. In next 5 minutes, it will increase the CPU utilization of the instance. Let me know once you're done. We need to wait for some time, for 5 minutes on an average for this thing to spike. Now, in my case, it's increasing a bit. I want to make sure there's nothing wrong. I just press Control Z one more time, dispatch the hogs again. It will take some time, right? And what about the email now? If you check your mailbox, I just got the alert. Yeah, this is the expected outcome. Fine. This completes our CloudWatch.
Just a quick info guys, if you want to make a career in cloud computing, then Intellipaat provides an advanced certification on cloud and DevOps by IIT Madras. This course is taught by industry experts and IIT Madras faculty. This course is designed to upskill and land your dream job.